Hello everyone, this is Alex USA Days, and this is an introductory video to my online course on YouTube on how to become QA engineer. It's called Learn Quality Assurance from Scratch. And in this course, you're pretty much going to cover all of the skills required to start as a QA engineer. A little bit about myself. So I've been QA engineer for about 10 years now, and I worked in so many different industries. I worked in a mix of hardware and software, worked in e-commerce, worked in gaming, medical API, so a lot of different things. And I picked up quite a lot of tools, and just wanted to share my experience and get you started with QA career if you want to learn it. And uh, I think that's going to be a good way to start your journey. Now, this playlist will be updated over time. So as I create content, I will be adding it to this playlist. But I already created a roadmap. I think I know what kind of content I want to add to the playlist. So let's take a look at it. So pretty much, uh, there will be 14 modules, and within the modules, there will be videos dedicated to that topic. Where we will start with what is QA and where it is needed. Then we will go into development methodologies and how QA might differ in different development methodologies. Then we'll talk about types of testing and test plan creation. Then we'll talk about bugs and how to report them. After that, we will talk about managing test cases, creating documentation, test matrices, and so on. The next one will be basic console commands. So a lot of companies are using Linux or Unix-based systems where you would need to know the console commands, how to navigate, and perform different tasks. So we'll cover that. After that, we will do some Git introduction. So most common use command if you need to use Git at work. Then we will do SQL introduction, and it is pretty much like a language for database. Updating database management, managing database. So we'll get some basic commands required for QA if you need to verify some data in the databases, in SQL-based databases. Then we'll talk about API testing, what it is, what kind of tool you can use to perform it. Then we'll have some automation introduction. So we'll pick some tool that you can start and spin up easily and start automating right away. Then we'll talk a little bit about mobile testing, how to perform it, what kind of tools can be used for mobile testing. Then we'll have a module on like first work experience and how you can start getting your work experience, even if you never worked as a QA. Then we will have a conversation about team composition, how your day work might look like in different companies, what you will do, who you'll talk to, and how you communicate, how the whole thing gonna flow pretty much at your work. And then we'll have a section on interview preparation. So, what do you need to do for a good interview? What kind of questions might be asked? And overall, get you ready, so you can be confident when you start looking for jobs. So, yeah, this is the basic idea for this course. I'll try to update it regularly. It's going to be a pretty large playlist that's going to grow over time, and then each module probably will have its own playlist dedicated just to the module, so it's going to be easier to manage it. Yeah, but everything going to be here was the starting video, and I will be providing multiple links in the description that are helpful, like getting books or getting materials from that were used in the lessons and so on. So yeah, I think it's going to be an interesting journey. Hit like and subscribe if you're gonna want to watch more and you're interested in the content. And this was Alex USA Days. Thanks for watching, and bye bye. Hello, everyone. This is Alex USA Days. So we're continuing with our QA journey. So we already talked about the course and so the overview. So today we get to the first module, and it's going to be probably the shortest one. But we will talk about what is QA, what is quality assurance, and where it is needed. So you will have some understanding of the profession. Okay, so let's go. Um, what is QA and where it is needed? So QA stands for quality assurance. Goal of QA is to verify that specified requirements are met. So if there's a product, it has to have some requirements, what it should do, how it should do, how often it should do something, how much load can it take, and so on. So this is essentially the requirements that's being set in place when the product is being developed. Quality assurance is the process that makes sure that in the end, when the product is out, it is following all those requirements and it is as much as possible bug free. Okay. What are QA engineers' duties? Well, they may vary depending on the product because there are different industries, and you can work in medical, you can work in military, you can work doing something for the government, you can work for hedge fund, or you can work for real estate company. All of those things, they will differ depending on what product you will be testing around that business. That may be a web page, that may be testing their API, or maybe something to do with their backend. That may be a wearable device, so maybe you're wearing like a Fitbit bracelet and measuring your steps, stuff like that. So a lot of different things. So essentially your duties will vary depending on the product. But the main goal is to make sure that the product meets the requirements and has as few bugs as possible. What QA engineers test? So essentially, the same thing as the previous sentence. It's just whatever there is, right? So almost anything that has code in it can be tested. Coffee makers nowadays, X-ray machines, web apps, smart devices, routers. You can test connectivity. You can test localization. So if the a game, let's say, translated correctly and it sounds okay in the national language that it's been translated to, you can test games, you can test mobile, you can test cars, you can test toasters. So essentially anything that has code in it. Um, some of you might not realize the scale, how much stuff has code in it nowadays, but almost anything you take has tons of code. For example, let's take cars. Let's take a new car, your modern new car, and I'm not speaking about Tesla, just your average middle class, brand new 2022 car. And the amount of lines of code in the car is staggering. It will be around 100 million lines of code. So essentially, you're driving a computer. You're not driving just a car. And it goes with the other devices that are smart. There's a lot of code. So the more products are being developed, and more products are in the market that have code and require ongoing support, the more QA jobs will be out there. So essentially, what that means I don't think that quality assurance as a profession is going anywhere, and it doesn't matter if it's manual or automated, because you can't automate everything, right? Some of the things you have to move around, you have to interact with them. You can need to actually wear them, or you need to put them in one place and then in another in your apartment. Maybe you're testing a router or something. So essentially, I think the the more products we will have that are developed in the states, and the more products we will have on the market that have ongoing support and new features added, the more QA positions will be there. So QA kind of grows exponentially, same as the industry of development and development jobs. Um, they always talk about everything will be automated one day, or there will be no more need for coders and programmers. Code will write itself at some point. But all of those things just seem too futuristic. It's not here yet. There are some codeless solutions for automation, but it still require a person to actually write those tests. So yeah, I think in the matter of like how long we will have this as a profession, I think it's for quite a long time. Still, it's going to be very in demand. Uh, so who hires Q engineers? I think almost every modern industry does. So small startups need QA engineers. Big corporations alike, they need QA engineers. We can talk about banking, real estate, gambling, government, medical, gaming. The list really goes forever, on and on. Any modern industry, any product that has developers or something done by developers for that. For example, for real estate, you might have an app where you actually search for local listings and so on. This will too require testing. For your X-rays, it will too require testing, right? If you go to a dentist and someone taking your X-rays, before you have this device there, it's been thoroughly tested and it's been worked on, and that all the outputs, radiation outputs, the image, and everything is correct. So there's certain standards that had to go through and follow, certifications. QA is needed. Almost any industry that has something to do with code, there's some product or part of it has some code, will require a QA engineer. Why hire QA engineers? Why not let developers test? That's not a question that people ask. And the thing is, with developers testing, if they knew where the bug is, they wouldn't write their software to have that bug. So in the ideal world, maybe they could write code that doesn't have any bugs. But there's so many interactions happening. Multiple developers working on the product, multiple tools and tools are used. So there are all this interaction that's happening between different modules and components of the product. That this system is actually starts breaking. Even maybe on the low level, developers write something called unit tests, and they have some coverage. But when you start bringing things together, and then bringing those things to different platforms, you will have all those unimaginable connections and interactions happening that create situations that developer could not predict it. That's one thing. The other thing is with developers, often enough their code is like their child in a way, right? So for them, it's kind of hard to find flaws in their own baby because they made it and here it is. So for them, it's essentially even just psychologically kind of hard to test and make sure that their product works as expected. Because for them, they created it, they were reading the specs, they were writing according to the specs, and at the end, they think it is working as it's supposed to. But when you come with another mindset as a tester and you look for things that were missed or how you can actually maybe interact with the system so you break this functionality, you start finding a lot of issues. So this is why you need QA engineers, right? That's why developers can't test. Other thing that bugs in production cost millions and millions of dollars, and having major critical bugs will turn away users towards competition, so business will lose money. Um, Bugs may even put companies out of business. So if you have a company that manages other users' data, and maybe it's some personal information and credit score and whatever, and there's a bug that system leaks out and all the data is lost and it's now open in public, uh, your company might go out of business. Yeah. Uh, and the bugs may harm end users. So imagine automatically driven cars like Tesla running into pedestrians because they were not properly tested, right? Or imagine road navigation app taking you somewhere else, not where you wanted to take you, and then you'll get lost, and all of a sudden there's no gas station anywhere nearby, and you get stuck. Or imagine that X-ray machine in the office when you take an X-ray, so it's just producing too much radiation, and it's actually harmful. So yeah, QA engineers are definitely needed. It's not like we can just get rid of QA and start just coding and releasing the product without making sure it works properly, because the product gonna be terrible, and whoever gets the better product will take the market. All right. So what activities QA engineers do at work? What essentially QA engineers do? So QA engineers, they estimate, prioritize, plan, and coordinate testing activities. So what testing is required, they prepare and give time frame, how much time they will need to test something. They review requirements and specification, and based on those requirements, they create test plans and test cases. So essentially, if product needs to do A, B, and C, you'll write requirements. You will write tests based on the requirements and make sure that what is happening. Uh, Testers perform testing. QA engineers perform testing, so they make sure that product meets expectations and the acceptance criteria. They gather, analyze, and report test results. So sometimes you test on multiple platforms, multiple devices, multiple builds. So you have to have this information accumulated, analyzed, and send a report out on how does it looks in general. You also open bug reports when you find issues, and then when developers take the bugs and fix the issues, you verify that the issues were actually fixed and that no new issues were introduced after the fix. Sometimes QA engineers will also build test beds, so configure environments that are required for testing. So if you're doing some connectivity testing and you need to connect multiple devices to a router, you'll have to set it up. You'll have to set up an access point. You'll have to connect the devices. You'll have to measure throughput and so on. So building test beds could also be part of QA engineers' responsibilities. QA engineers participate in meetings, groomings for upcoming stories and sprints, and do other team activities. So, especially in Scrum environments, and we will talk about different testing methodologies and development methodologies, but in fast-paced, small teams, QA engineers provide a lot of input together with the team on how to uh, test things. Maybe they even can add some valuable opinion on how the end functionality should look, how to improve it, and so on. So, in a way, you can say that QA engineers also serve as a connection layer between developers and product owners. I've seen that a lot through my career. So, you're essentially like a bridge to making sure that the requirements are read correctly and implemented correctly, and there's no miscommunication between product owners and developers. And you also, as a QA engineer, you add user perspective to requirements and suggest improvements. So that's happening quite a lot too throughout my career. Uh, that is pretty much in a nutshell. If you go into profession, become QA engineer, and start growing with the profession, then you will have other responsibilities as a QA automation engineer, or as that, or so-called software developer in test, or maybe you will even move into some DevOps positions from QA. But uh, that's how you start, and then the list of what you will be doing as part of the team may grow. Why choose quality assurance? I think quality assurance is unique because it gives you an opportunity to work almost in any industry that you want. So, from software development, like building mobile apps, or working maybe on some e-commerce web pages, into gaming, into medical. So, essentially, any industry that has anything to do with code and has requirements for a product to be coded, you can work there as a QA engineer. So you can choose a huge variety of places where to work in different industry. QA engineer is also a very good entry point into IT field. It's not as extensive as coding. It doesn't require as much knowledge as a programmer would need. I mean, essentially, you want to understand some code, you want to be able to read some code, but you don't have to write a framework and build an app from scratch. It's a completely different level of skills that required for like proper development, right? So overall, if you want to work in IT fields and if you want to go into startups or work for bigger companies, maybe like Google or Apple or Amazon, QA engineer is a very good position to start. Really good position. Also, QA engineer, as part of the IT world industry, has great benefits, has very competitive salaries, a comfortable work environment. You can work from home in many places. Uh, I wouldn't say you would be making as much as developer. Maybe you'll be making a little bit less, maybe 10, 20%, sometimes 30%. It depends on the industry. But I think overall, it's just really, really good uh, in terms of payout. Could be one of the best industries if you compare amount of time and money required for education and then output of the profession and how fast you can get into the profession. I think QA is in top 10 for sure. All right. And the last thing, why I choose QA. There's a lot of growth potential into, and you can become QA automation engineer, software developer in test. You can do DevOps. You can even be a project manager, or you can go into management. So as the more you work in the industry, the better you will understand it, and you will shine and understand what your personal strengths are, not only as a QA engineer, but overall what you can contribute in organization. You can definitely choose another path and switch, and QA gives you this opportunity. So, in a nutshell, essentially, this is what is QA and where it is needed. Hopefully this was helpful. If you like the video, hit the like button. Please subscribe for more. This playlist will have all other topics coming up. and we will have essentially all those blocks covered going forward. This was Alex USA Days. Thanks for watching, and bye bye. Hello everyone, this is Alex USA Days. So today we start new module, and this is development methodologies. Now, the initial start of this module is about software development lifecycle. This is the how everything started, how we developed other methodologies. This is like the foundation, the base of it. So SDLC, commonly known as software development lifecycle or systems development cycle, is essentially approach on to development software or systems or both software and hardware. There's several stages that it goes through, and those stages are clearly defined. It starts with the planning stage, where the goal of the project has to be defined. There's estimation of costs and the timeline for completion of the project. Then it goes into next stage, and the next stage is analysis, and this was where you analyze needs for the product and develop user requirements. So there's functional requirements documentation set in place. Next stage is the design stage, that is answering the question how it will be built. So detailed system design documentation created, design is created. So essentially, this is all the foundation requirement to start development. Next stage. Now, then there is development stage, and this is where the project setup happens, environment installation happens, database created, and the actual coding is done. So all the development goes into this stage. Next stage would be verification. During verification, product is verified against the requirements. Bug are fixed. So if testers find issues, they send code back. Then it gets fixed by the developers. Then it sends developers send it back to the testers, and testers verified it was actually fixed, and no other regressions were introduced. This is the stage where tests, analysis, and reports are produced, and overall the quality of software is estimated, and it should act and behave. The program system should act and behave as laid out in the requirements. After that, there's a deployment stage, and during the deployment stage, product is being deployed to production environment, and any resolutions that happen during this or production issues, this is happening in this stage. So if there's something that's not going well during the deployment, after deployment, this is part of deployment stage, and fixes are here. After that, there's a last stage, a maintenance stage, which includes system updates, patches, customer issue reports, and bug fixes. So initially, there's mostly a skeleton crew. There's no more active work on it, but you will get your updates every once in a while to make your product better, right? So initially, a software development lifecycle originated back in 1960s, and the idea was to help develop large scale systems, because back then computers were created and managed by large corporations like IBM, and a computer could be a size of a room, so they're pretty big, and they were mainly designed for large scale scientific and technological applications. So it wasn't back then like it is now. Not everyone had their computer at home and you could start working on an app, or you had a business idea. No, it was lab settings with scientists and big corporation with big money working on scientific projects, right? So computers back then were completely different uh, what they are now, and this approach was created in order to make sure that all the time and the money invested in the production were not wasted, and everything went through stages that were thoroughly documented. Everything was estimated, measured, calculated. There were no money wasted. Initially, at the end, you had a completely finished, full working product. You might have some upgrades going on, some new features may be added later, but it wasn't like it is right now when we have like continuous development happening and things are getting updated and upgraded pretty often. Now, back then, something was developed for a long period of time. Once it was out, it served for a long period of time. An example of a technology like that that I could think of is maybe your X-rays at the dental office. It was developed once, took some time to actually make it work properly. The documentation was in place, all the estimates, the cost, everything was estimated. And once it was completed and tested, it went out in the field and then it stayed there for, I don't know, 5, 10 years, right? Until the new version, the new release scheme. Okay. Um, so development methodologies initially started with the software development lifecycle. That was like the basis of it. Now it grew in many other approaches, and we have numerous of different development methodologies that are available today. We will cover more in the next classes. We will talk about, and this is just prototype. There is no slides yet, but we will talk about waterfall model. We will talk about Agile. We will talk about Scrum. We will talk about Kanban. We will talk about Shift Left. So, and then we will talk about Lean and what part of it can or how it can be used in the current settings in software development. And this is pretty much it for this module. So you have to remember that software development lifecycle is initially a model that was developed a while ago that kind of was the foundation for the ongoing methodologies, for the development methodologies that are in place right now. And it's like the classics and the standards for the development of systems or software. Now, in the description, I will leave a link to materials, to a webpage where there are slides and more proper, laid out description of what it is, more visuals. But in a nutshell, this is what software development life cycle is. Now, if something is completed and then it's went through the maintenance stage and now it's being getting rid of, then there's could be another follow-up stage, which is not mentioned here, but something to wrap up with the product, to I don't know, to transfer customers maybe from one product to another. So there is potentially another stage that is about closing the product, but it's not actually often mentioned. Sometimes you will find it, sometimes not. But this is the most like classical representation of it. Now, if the product, why it's called cycle, if the product will be developed with new additional features or redeveloped or upgraded, updated, it might actually go through the whole thing all over again. So, we start with the product A, we release it. Then there's some changes that will go in place that not simple patch or a simple upgrade, more new features added. Maybe it's like will be a newer version. It will start in new. It's like the difference between iPhone 4, 5, and 6, and 7, and so on. So each release of the new product won't be just maintenance and update, but will actually go through all the stages all over again. So it will have planning, analysis, design, development, verification, deployment, maintenance, and so on. Okay, so when you asked on the interview, and if you asked on the interview about this question, you can freely speak about those stages and just add, that this is the classical approach that was created back in 1960s when the times were different and the system were mainly managed and developed by big corporations, was very scientific. Uh, but this approach was a foundation for the development methodologies that we have in place today, right? Such as, and we will talk about them again in the next classes, Waterfall, Agile, Scrum, Kanban, Shift Left, not so much Lean, but more on that later. Lean is pretty much a term that is coming from manufacturing, but the principles of Lean are also applied in the software development nowadays, and they go in parallel with the implemented development methodology. Okay, so hopefully this video was helpful. Again, for more detailed information, I will leave a link below this video so you can follow and read. If you enjoyed this material, please leave like, subscribe, I will try to release videos more often, so probably a couple times a week. Right now, I'm doing it on the weekends, but as time allows, I will try to release at least maybe twice, even maybe 3 times a week, so we can cover the whole material faster. Okay, so this was Alex USA Days. Thanks for watching, and bye. Hello, everyone. This is Alex USA Days. So we're continuing with our QA course, learning QA from zero. And today we're going to talk about Waterfall. So Waterfall is one of the first SDLC models, and Waterfall model name appeared around 1970s. Waterfall development model looks very similar to classic software development lifecycle. So there's stages that the development goes through. Remember, when waterfall model appeared, the companies still that were in the IT industry were big corporations with scientists on board with large computers. So the processes were very scientific and strict, right? So the layout for the waterfall essentially was in the beginning of the IT industry in general. So, stages of waterfall model are creating requirements. So, at this very first stage, product requirements documentation created, so-called PRD, and you want to answer questions such as what problem product is solving and what resources are required to do it. So, you have to put a good amount of research before you actually start working on the product and on the project to understand what kind of resources you will need to complete it, what might be limitations, what kind of maybe guidelines you need to follow, and put all this documentation in place. The second stage is design. And in the design stage, software requirements analyzed. So there's software requirements analysis is made. There's modeling of the architecture. Well-designed systems add to quality, reliability, security, performance of the product. So if you have a well-designed system in place and you're not developing yet, but you're just structuring how everything should work and how it will be implemented, then at the end, as a result, you will have a very well done product. That would not require additional updates or redoing things because from the start everything was designed in place so it would work um, as expected at the end, right? Then there's a third stage, coding stage, so actually building the product based on the system design, based on the requirements. It's actually the stage where you create things that do stuff, so you actually coding something, right? The fourth stage is integration and testing. So during this stage, all the components are brought together. Verification happening that product actually meets requirements. So in this stage, QA engineers test the code, open bugs. When the bugs are open, developers fix them, and then QA engineers verify that bugs are indeed fixed and there are no new regressions introduced by the fixes. Okay. And then there's a last stage, the fifth stage called operations. And during this stage, there's deployment, there's support, there's maintenance of a complete systems. So if user find issues, then they're fixed, there are updates, patches, there's system monitoring, and all the live product related activities around it. So like customer support, installation guides and updates, whatever is needed to make sure that the product is stable and working as expected. Okay, so those are stages laid out and defined pretty clearly. They can take significant amount of time. So preparing documentation can take, good 30% of the time. Then and design can take 20% maybe, and then you have 30% for coding, and then 20% for testing, and then the rest once that it's up, it's just a live product that is operational, right? So, but all of the stages can take some amount of time to complete, and this process is sort of rigid in place. um, I tend to imagine waterfall like this. So for me, it's more of a staircase where you have set of steps that you go through. in order to get to the exit final product, right? So I like to envision waterfall model as a staircase with a set of steps. Each step takes some time to complete, and once product is out, only maintenance remains. You might find online that last stages of waterfall model are deployment and maintenance, but in the original model, they all part of operations. So if you do your research, and I will add some links under this video where you can read more about uh, waterfall model and how it happened to be, what does it include, and maybe more details on the stage itself. But yeah, in the core, it is what I'm telling here based on my experience, what waterfall is. All right. And if we talk about advantages and disadvantages. So since the time the waterfall appeared, a lot of new methodologies came to be, mostly starting 2000s, the new methodologies we're going to talk about, agile based, are very popular right now. But you have to think about the time when waterfall appeared, right? What kind of companies were running it, and it's still good. It still can be used in some industries, and I'll give you some examples. But if we talk about advantages of waterfall methodology, so it is well planned and documented. It's hard to do anything, impossible to do anything without documentation first being in place. Within waterfall, the stages are clearly defined. So there's documentation, design, there's development, there's testing. So everything is perfectly staged, and you know when it's what happening, right? It's a structured approach. So there's not no chaos. Everything is structured, and the requirements are set in place. It can be an advantage, it can be a disadvantage, but I think when you have set in place requirements and you have set in place expectations, you can actually get the product that you wanted, that you designed for, that you worked for, and you have the quality that goes with this product, right? Um, it creates mostly monolithical applications. This also can be advantage or disadvantage, but I put it as an advantage because your product is stable and ready. And once it's released, there's maintenance, yes, support, but there's again no chaos. If it's out there and it's working, it will be working and working. 10 years after, it still be working as defined. Uh, Advantages also can be that if it's well planned, it will have realistic estimates, dates, and contracts in place. So if something's been contracted, that this work will be completed within a period of time, the requirements were set in place, how long the development will take was understood, everything was cost estimated. So as a result, you will have a product around the date when it was scheduled. So I think for waterfall, it is good for regulated industries, big corporations, places where the requirements are clearly defined. There's some, expectations of what product have to do. There are actual examples on the market, that has it working for a while, how it's working, right? We can think about situation maybe in finance when there's some internal development, and uh, let's say there's regulations around the product. The product does not need external financing or investors. There are no really competitive startups on the market that will take your share if you don't do frequent updates based on what customers want, right? So let's say there's a financial institution and they develop internal application that has to be secured just for that company. So they will allocate budget. They will put in estimates in place, what needs to be done, what functionality goes in, what is allowed in this application, what is not allowed. Maybe they'll hire some contractors, right? And those will give them estimate of the cost and how long the work will take place. Maybe with the regulations in place, they have some other project that already, or they did a similar thing, um, so they can have a plan laid out. So they will finance it. The work will be done. Everything will be tested. The issue will be ruled out and fixed. And then, as an output, you will have a working product. That where uh, how it works, and it will be working like that for quite a long time. It's just defined there. Another example would be like medical industries. some government industries, some of the older like military projects that were done in 80s, 90s still use like really old code. So yeah, it's still used mostly in big corporations, in the companies that don't require outside financing, that have a good understanding of what they created. The expectations are clear and will not change. Uh, you can still have this developed and should be developed within a waterfall methodology. Now, disadvantages of waterfall: it's hard to update requirements. So, if something is already set in motion, so if the contract was signed, the estimates were put in place, people hired to do it within the requirements that were defined, you can't just go and change it, because you're gonna your costs gonna grow. It's like starting over pretty much. So that also means that going back to previous stages is almost impossible, or it's very expensive, right? Uh, Another risk is that most of the testing comes after development. Even though during development there might be some unit tests, and but when you start actually building parts, putting them together, and there's integration happening in actual testing. If the design wasn't set in place properly, you might start finding a lot of issues. And then when you find a lot of issues, that will gonna delay your release date. That's gonna increase the cost. So your whole waterfall model can break really fast, because product gonna become more expensive. We'll need to hire more developers, maybe other experts. I don't know. So there's some uncertainty there. So testing that comes after development might impose risks, of finding very critical things that not easy to fix. Um, Another thing with waterfall, there's really not a lot of feedback from end users. So there might be initially some ideas set in place, some research done, but nobody really goes to the end user if, let's say, it is some medical equipment, or maybe some military equipment, or something in the in the finance industry. There's really no a lot of communication with the end user a lot of times. So it's mostly product owners and the stakeholders, whoever's interested in in releasing the product, like maybe a director, or bank owner, whatever. So, but the end users don't really get much input, so they are just presented with the product in the end. Uh, and waterfall doesn't really fit well in competitive and changing market. So if you have a great idea you start working on, and you start capturing shares of the market, but the market changes and you need to adapt and adjust, you need to add new functionalities, and your competitors are doing the same, it's impossible, almost impossible, to do something like that in waterfall approach. So you have to be agile for that. And there is a high risk if product fails. So if all of this work was put in, and at some of the stages something went wrong, the estimates were not proper, if the product fails, you will bear a lot of costs to actually pretty much restart and redo it. So there are pros, there are cons to that approach, but in general, I think it works in some situations better than the others. So, for example, if you have some heavily regulated industry, let's say, some airspace industry or medical industry, you would want your devices, when they on the market, to be properly tested, to abide with all the regulations. You want to have something that is actually working as expected, and there's not a lot of place for error here, because it was clearly defined, the expectations were clear, and the work that was put in uh, gave you finished product that is ready to go, and it's complete. Um, if you're in some other industry where this is not the case, so if you would go to a hospital, like, you would need equipment that was properly tested and worked on, and abide by the standard. So here's, you probably wanted to use waterfall model for development. Or let's say in construction, you have a specific plan in place, the architect drawn everything, what kind of materials will be used, how much they cost, how fast the whole project gonna move, how many uh, people will work on it. Yeah, you still want probably waterfall here. Now, if you go into something, uh, more competitive and fast paced on the market, like you're developing uh, new Facebook or some other application, new social media, new TikTok. Well, yeah, if users want something else, you have to change it. You need to adapt. So Waterfall wouldn't work for that, really. Also, in real life, it's hard to find pure Waterfall, or as a matter of fact, any other approach like pure Agile or pure, Kanban, whatever, pure Lean, whatever they want to implement. A lot of places, most of the places, use their own interpretation of the development methodology with some hybrid practices in place. So you'll have a mix of one and another. You might even have mixes of waterfall and agile. So, for example, from what I've been reading online and researching, so like Microsoft, for example, is using some waterfall like model with elements of agile. Also, one company doesn't have to use only one methodology. Different teams or different projects can use different approaches. So maybe development will be done in agile, documentation for the business people. Maybe everything's going to be more waterfall model, or one specific project will be more waterfall because it's in a regulated industry, and the other will be more in agile because it's working on some startup like application, right? Okay, so yeah, this is in a nutshell waterfall. So I mean, it is a lot less waterfall right now because most of the startups and smaller companies use agile, and agile is trendy. Agile is newer. Agile came as a result of waterfall is not being capable of fitting fast-paced industry of IT industry that it's exponentially growing. But someplace still, I would rather see them doing waterfall and have clearly defined requirements and ready product once it's released, and not do it in a fast-paced like agile style. Okay, so it has its place still. There are downsides, there are upsides of it, but yeah. All right, so this was Alex USA Days. Hit like if you like the video, hit subscribe. There's a link to the playlist for the whole QA series. Everything's going to be in this playlist on the YouTube. It's free. So, yeah, feel free to subscribe and check out my next videos. Thanks for watching, and bye bye. Hello, everyone. This is Alex USA Days. So, today we're going to continue our Learn Quality Assurance from Scratch playlist. And today we will talk about Agile. So we're still on module 2, where we talk about different development methodologies, and we will have some more to cover before we go into module 3 and talk about types of tests and test plans. But let's get into it. All right. So, what is Agile? Agile is relatively new software development methodology that was established in 2001. Agile Manifesto was created by a group of developers that came up with new approach how to develop software. Now we will cover and look at Agile Manifesto and Agile principles once we're done with the slides for Agile. But you need to understand that the world has changed since Waterfall appeared. The initial companies were big corporations that had a lot of resources, scientists on board. So developing software in waterfall way was perfectly normal for them. Now, since then, there are a lot of more startups, a lot of more coding that happens from your basement or from your, from your garage. So a lot of new companies appear that can't really follow waterfall approach. They need something really fast, something that can be changed easily. So this is how Agile came to be. Now, Agile also came with a concept, well, within Agile, there's a concept of MVP, which stands for minimum viable product. And that means that the team can deliver something that has minimum functionality and just provides proof of concept that the program actually works. And then further direction of product can be adjusted if needed. So once the MVP is out, then the startup maybe can get more money from the investors, or they can see how it will respond with the customers or stakeholders and if there are any changes needed. And then since Agile appeared, a lot of different branches came out of Agile. We will talk about Scrum, we will talk about Shift Right, Shift Left, and other approaches. But they all have the same approach of continuous incremental improvement through small and frequent releases. That's the core idea of Agile. There's also no exit like in Waterfall. So as long as product is viable and it is in demand, it will adapt and improve. Backlog, essentially, list of features to work on is never empty. Things are always getting added in there. I can give you an example of YouTube, right? So when YouTube appeared, you can remember they have all those changes every other month or every half a year, like design changed, the application. Then from just the web application, now we have YouTube on our phone. Then there's also YouTube Studio, YouTube Music, all those other services around YouTube. Now YouTube also has a micro blog with like a wall where you can write your thoughts. And then there's also shorts instead of like long videos, and a lot of things that are happening with YouTube. More and more stuff keeps on adding. So as long as product is on the market, as long as it's used, it's making money, features will get added and it will get improved. Okay. So Agile, instead of working on complete product in one large cycle like Waterfall, from the start to the end to the monolith product being pushed out into the world where it stays there with like rare updates and upgrades. Essentially, Agile has small feature cycles, and those iterations starts with epic, or essentially the idea, right? What we're going to bring, and epic includes multiple stories within it that that have describing behavior of what this feature should do. So for example, you want to add a new type of an account for YouTube, like a manager's account that can manage other YouTubers or something like that. So you'll have to create a profile, you have to create special login. So this will go under the epic, and then those epic will include stories, and stories will have your BRD or PRD, which is like business requirement or product requirements documentation, which is essentially story description, which is requirements for that features. So Epic is full of stories. Those stories then go into the develop. Once the develop is done, testers test it. Then it is deployed. Then there is a review of the sprint of the cycle of development for the set of features, and then the new sprint starts. New Epic brought in, and the cycle repeats itself. So classic Agile can have release cycle anywhere from 2 weeks to 2 months as long. It may have different departments and a standard hierarchy, like with managers in the QA department with a set of QAs, and then there's developers department with a developer manager or director. But classic Agile is still flexible. So it does not mean there are no documentation or processes in place in the Agile environment, but the focus is on continuous improvement of working product over comprehensive documentation. In reality, though, you will find a mix of different approaches called one or another way, but with elements from other different approaches. So, you can actually see some mix of waterfall practices and Agile. And again, different teams may be using different approaches, or everyone say that they use Scrum or Agile, but, different team has something else going on for them. So from company to company, from project to project, from place to place, you will see some differences in Agile, Waterfall, Scrum, all other development methodologies. They might have the same name, but normally it's just a mix of things. Okay. All right. So what are the advantages of Agile? So Agile has high level of communication between business and development. So there's always conversation happening in Slack and emails. There's really not a lot of documentation, so a lot of it, based on communication, and your requirements can get updated, your stories can get updated depending on the communication. So there's a lot of talk going on, right? Business talk and development talk There's also another advantage of Agile. Customer satisfaction as key indicator of product success. So because there's a lot of feedback, there's that loop between stakeholders or customers and then development team. So there's always or business team and stakeholders and development and clients and customers and end users. So there's always this, understanding. Okay, if this was a good release, if this was a successful feature, what is the feedback? Are customers happy? Are customers satisfied? Um, why one of the reasons why Amazon got so big as they got today, the core idea of their business is actually around customer satisfaction. That's why we have Prime. That's why we have like next day delivery, which comes with Prime membership. So customer satisfaction, that's why it's so easy to return items. Customer satisfaction is in the core of the business. And the same thing was Agile principle. Adaptability to unexpected changes and market challenges. So if you're a competitor trying to take your market and they come up with some, new features in their product, you can quickly change your pipeline and implement the same features to keep your customers in place. So adaptability is a big thing. If testing is implemented on all stages and it is implemented properly, another advantage is better quality of product. It's not always the case. I've seen this disadvantage of this because there are many teams that don't, they're responsible for their part, like front end for front end part, back end for back end part. Sometimes you will have problems and discover issues when you start bringing things together, like integration part wouldn't be that great. So testing has to be implemented properly in order to increase the quality of the product. And the last one, but not least, is continuous improvement of products. So as long as the new features added, new technologies used, new stuff is built, and feedback is great from the customers, the product will improve. Okay. Disadvantage of just of Agile. So it's not always good to have Agile. Some things that require robust documentation in place. Industries that are regulated, that have certain standards you have to follow, that has certain like procedures and certifications in place, like being big bank and financial industries, maybe some like medical stuff or some government stuff, some military stuff. Those might not work well in Agile setup. So it doesn't serve well in regulated industries. Well, at least from my experience. Also, frequent changes, which is also called context switching in the industry, can lead to fast burnouts. So imagine you're working in a project and you've been thrown from one team to another, from one technology stack to another, from one product to another. Over time, your project gets shut down, you start working another one, this one gets shut down because there's market change. So it can lead to fast burnouts. It can be really challenging environment if there are a lot of changes and you feel like you're not really contributing. Limited documentation or no documentation at all, that also can happen in Agile. And source of truth can be someone's expertise or even an opinion. So you wouldn't have somewhere to go and actually read about the product or the feature, how it should work, or what is already implemented. You'll have to talk to people to figure things out, and it's not always the best approach. Okay. And fragmented delivery can lead to gaps, and that's what I've talked about in testing. Fragmented delivery can lead to gaps in integration and unexpected bugs on release. So if there's only front end team that says we're responsible for front end, hey, our tickets are done, and then back end says, hey, we're responsible for back end, our tickets are done, and then they kind of bring their back end front end together, and all of a sudden there's a mismatch in API calls, and they're just things are not working. So this part, integration has to be tested well. Okay, so this is mostly it about Agile. So let's go and take a look at this manifesto. All right, so what is Agile Manifesto? So a team of developers came together in 2001. They're the names of them right here. And they created this manifesto that says, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value. And that's the focus of Agile: individuals and interactions over processes and tools, work in software over comprehensive documentation, customer collaboration over contract negotiation, responding to change over following a plan. That is, while there is value in items on the right, we value the items on the left more. And on this webpage, you can read about principles of Agile. You can see all the people that signed Agile over methodology over the years, all the way up till 2016. You can explore this webpage. It's pretty cool. Okay, so that's it about Agile. Hopefully you enjoyed the video. Hit like and subscribe if you want more content on QA. More lessons are coming in the future. And thanks for watching, and bye-bye. Hello everyone, this is Alex, USA Days. So today we're going to talk about Scrum. Scrum is one of the methodologies for development, and I pretty much call Scrum Agile on steroids. Fun fact, Scrum is not an acronym, and Scrum usually works in small teams. There's no classical hierarchy like you would see in a bigger company. There's really no QA department. There's really no dev department. It's all just one team. So a team consists of 6 to 9 people that may have different members like developers, QA, Scrum Master, product manager, DevOps, designers. It may change from company to company. But small self-organizing teams work on selected project and act like special ops of development with high performance and high delivery speed of features. It's quite common. You might wear multiple hats in Scrum and do many things, not only just your responsibilities. All work organized within sprints. Each sprint can last from 2 to 4 weeks, and typically 2 weeks. There may be release after each sprint or planned release after several sprints. So sprint is a set amount of time that is allowed to work on different features. So every time a sprint starts, developers and the team gets together, they select some stories or features that will go into the sprint. They assess the complexity of those stories, and I'll have some visuals for you. And pretty much they select their workload for a sprint. So for 2 weeks, you can't make sprint longer or shorter. It has to be a certain amount of time, and developers and the team has to work around in order to fit that work in that selected amount of time within a sprint. If I would give you an analogy how to easily understand sprint, think about a vacation. Your vacation only lasts 2 weeks, and you have to fit a list of things you're going to do during this vacation. Maybe you want to go visit Disneyland, maybe you want to go and see your parents, but you can only have so many things within those 2 weeks. So you have 2 weeks, you select work you do. Once 2 weeks are done, you report on it pretty much, and then you start over again with the new sprint and new features selected to work on that sprint. Scrum has a unique role called Scrum Master with the task to facilitate Scrum process. So it's not a developer, it's not product owner, not product manager, not a QA. But Scrum Master helps in many ways organizing the process. Sometimes they would help with the organizing release, connect team members, help product manager with stories. So they participate a lot. Scrum has daily morning meetings called stand-ups, and stand-ups last 15 minutes during which each member reports what they are working on today and if there are any blockers. All right, so let's get into some visual representation. And a lot of companies work in Jira, and Jira looks like this. You will have a backlog, and backlog essentially a collection of stories. So stories are the features that you need to work on or team needs to work on. The hierarchy of things goes like this. So if I'll create a ticket, you can see there's different styles. Actually, I did not set it up completely yet, but yes. So there's an epic. You see this purple right here. Epic is essentially the collection of stories. So it's a high level module of work that needs to be completed. It's normal that Epic can go in this from release to release. Work on Epic happens, or maybe work on Epic might happen within a sprint itself. Now, inside of Epic, you will have stories. So if you think about it, you can think about it as like you have some books that you like. Let's say Harry Potter. Harry Potter has many books, so all those books are essentially an epic. But if you grab one book, it's like a story. So before you complete the whole epic, you have to complete all the stories that are within it. So then there's stories, and those stories are going into backlog. Backlog is like a library of books, and it's never empty. You keep on adding stories, new features, new ideas, new requests from investors or customers, whatever. So essentially, backlog is never empty. And then what you drag from the backlog, you put it into the sprint, and we will work on that just right now. Okay, so here is our empty project. Let's go to backlog. So now I will start. I'm not creating a sprint yet. Let's add some stories. Okay, so story one. I'm not sure what it will be, but let's say create manager's profile for Facebook. And then maybe story 2 will add something like create manager's login for Facebook, and so on. And let's maybe add a bug. User can't log in with new profile type. So this is just very high level. We'll go more in details later on, but essentially before the sprint starts, there's a meeting called sprint planning, and all team members get together and developers assess the complexity of stories. So developers discuss, hey, how much time is going to take to complete story 1 and how much time is going to take to complete story 2. So let's say they talked, and then they have to give it some points. Normally, complexity is measured in Fibonacci sequence. So 1, 2, 3, 5, 8, and 13 is the max. So each number is a sum of the previous two. So 1 plus 1 is 2, then 2 plus 1 is 3, 3 plus 2 is 5, 5 plus 3 is 8, 8 plus 5 is 3. If you think about time frame, so 1 point is 1 hour or so. There's like no exact measurement and it will differ from place to place, but I'm just giving you some example to base on, like half a day, 3 couple of days, 5, maybe 3 days, 8, a week, 13, 2 weeks. So if we know that our sprint is 2 weeks long, we can't have tickets larger than 13 points, or a developer can't have a ticket that is larger than 13 points because it's going to take all his development time. So developers get together and they, during this sprint planning, assess the complexity of stories. And let's say this one will be, okay, let's say, do we have story points here? Estimate maybe. Priority. So let's see if I can add a story point here. Okay, story point estimate. Okay, so let's take a look again at our stories. So they assess the complexity of the ticket, right? Together. And they would vote. One would say 5, others say 8, and then they discuss why. So let's say this one is 5. And we know our sprint can have only up to 13. Okay. So then this one can be 8 here, right? Not more than 8. Otherwise, we will be over 13 points, and it's 13 points per developer. So let's say we have only one developer in our team for right now. So this will be 8, and now we're essentially at 18. Maybe as additional task we can fit in this bug because it's a small thing, and maybe it's just like a 0, half an hour, or 1 really small. So then the stories from the backlog added to the sprint. And again, we just created some stories right now, but actually backlog is never empty. There's a lot more stuff in there. It's sorted by priority, but we pulled this in. So then we start the sprint, and the Scrum Master together with Product Manager would start the sprint. Let's say our sprint will last 2 weeks, like a default time goal. Complete manager's profile. So we're creating like some login that has manager permission or manager accounts, whatever. So, okay, here we are. Now sprint is started. Now, within the next 2 weeks, developers will work on the stories, right? Once they work on the story, it will be in progress. And we need to update this board a little bit. Then story moved into progress. Then from progress, it goes into QA, and quality assurance engineer will verify that the story is implemented according to the requirements, story description. If some requirements are violated, they will open a ticket or just send it back to development. So it will go back to developer, and developers will fix it. Then it will be back in QA again. QA verify that everything works as expected, and then it goes to done. Same process with other story, goes into development, in QA, into done, and with the bug, the same thing. It goes into development, then QA verifies the bugs was fixed, would run some regression testing, making sure no other things were broken, and then also done. So 2 weeks passed, all of the work in the sprint was completed, everything now in done, great success. If we take a look at our backlog, we see all they crossed out. We can essentially 2 weeks passed. Let's imagine 2 weeks passed. We complete the sprint. There is a metric called burn down chart, and essentially it's like a chart that shows how much stories, how much points are left, and when is the end of the sprint. So as the time progresses, you can see how it kind of goes down to 0, from the 13 points down to 0, or however many points was in the sprint, right? And then so after that, there is sprint retrospective and discussion on how it went, what was the strong side, what was the the weak side, was the estimate correct, whether any wins or gains. So essentially it's ongoing thing where there's a discussion of the process, how it is going, how it can be improved, and then the new sprint starts. And the same process all over again. So new stories selected from the backlog. They estimated how complex they are. Everything pulled in by priority. Those stories are part of an epic, right? And then work is completed. You test it. Developers fix bugs, you test it, another release, or just, or maybe just it sits in a test environment or sandbox or some pre-production environment waiting for a big release, like maybe released every 3 sprints. But again, now we can see a lot of companies moving even faster, so they prefer to release smaller chunks of work weekly, bi-weekly. So maybe you will have a release like every 2 weeks. And that's it. That's pretty much Scrum in a nutshell. And you know now the flow of Scrum. So if asked during the interview, you'll be able to speak about it and say how it actually goes. Scrum is popular. A lot of startups use Scrum. I like Scrum. One problem with Scrum, I think, that sometimes stories don't make it within a sprint, and then there's a decision to make. If you have pre-planned, work ahead for a sprint, you start pulling stories, and they don't make it within sprint, you can send them back to the backlog, or the work kind of overflows into the next sprint. And then into the next sprint, you have your own work. So maybe you can't complete that either. Some of the work for the second sprint, the third sprint now, right before the release, you actually kind of snowballed a bunch of stories that you can't complete on time before release. So there is that problem with Scrum that, if you can't estimate correctly and the stories are not done by the end of sprint, if they overflow to the next one, and that happens again with the next sprint, by release time, you might not actually cut it and have a proper release because not all of the functionality will be done. I think this is one of the main downsides of Scrum. It has to be organized really well to work well. Okay, so this was Alex USA Days. Hopefully you like this video. Hit like if you enjoyed it, subscribe, and in the playlist there are more videos on how to become QA engineer from scratch. Thanks for watching, and bye-bye. Hello everyone, this is Alex USA Days. So we're continuing to learn quality assurance from scratch. We're getting closer to actual test plans, test cases, bug filing, different QA tools, and really hands-on stuff. But couple more videos with software development methodologies. Okay, so today we're going to talk about Kanban and Lean. So essentially, Kanban is a mix of Lean and Agile methodology, and the method of development was visualization of workflow, where teams prioritize tasks and complete them by moving through stages and from one side of the whiteboard to another. You've probably seen those like whiteboards with stickies, and there's a lot of like images and screenshots and pictures online. And let's talk a little bit about Lean. So, Lean is essentially principles of manufacturing. It came from manufacturing. I think it's all started in military during the development of bombs in World War One or World War Two. How they were trying to standardize process and put it in little segments, so there's no delays. And then Japanese actually took that and improved that, and it became like a staple of manufacturing in Japan. So the Lean then became like worldwide and moved from manufacturing into software development. Okay, so the key principles of Lean process is eliminating waste. So you want to eliminate anything that is not adding value to the customer or minimize it. That means bugs, partial and incomplete work, micromanagement, like too many meetings that are not important. Focus on delivering value to the customer. Then another principle of Lean is build quality in. That means you want to test early. You want to eliminate as many bugs as possible in early stages. So essentially, you have to have good quality product out of the door and not try to fix it later and find critical issues. No, build quality in. Third principle is create knowledge. So you want to build often and practice small releases. And with that, you want to have code review, you want to have knowledge sharing, you want to have documented processes. So, team is learning as they go, they're building knowledge and they create knowledge. Uh, Delay commitment. That's another principle of Lean. It's It's kind of interesting. So you don't want to commit to design or architecture until all assumptions are ruled out and multiple solutions evaluated. So if you're committing to something, that means you want to be sure that it's going to be this way. Okay. Uh, the fifth principle of lean is deliver fast. That means you want to develop fast, you want to receive feedback from the customers, you want to improve based on it, and essentially, it also may be called like fail fast and learn from results. Number six in lean principles is respect people. So you want self-organized teams. You want to develop leaders within those teams, and you want to make sure that teams are properly staffed with needed expertise. And you, as manager or the owner, you set reasonable goals to those teams. So this is all part of respecting people. And principle number seven is optimize the whole. So it means each stage of software development life cycle should be analyzed with each iteration and optimized and improved through learning and experience. So there's a feedback, something didn't work well. Make sure it's gonna get optimized. Okay. Um, for Kanban, so essentially, again, this is the whiteboard with sticky notes, and I'm pretty sure you've seen that a lot. There's a lot of advertisement for Kanban specialized boards, like I think Trello, one of the very popular ones. So the key ideas of Kanban, right? You want to manage flow. So you want to identify bottlenecks and you want to estimate effort. So the flow should be seamless, right? You want to limit work in progress. So you want to set WIP limits. You don't want to have multiple tickets sitting in one column and nothing's being done about. You want to also to have visible and simple processes, so everyone knows what's going on, what are inside those tickets, what is the next stage. The team is actually aware how the whole flow work. You want to have continuous feedback. So if something's not working well, you want to get feedback from the team. You need to have those discussions regularly. And if something is broken and there's ideas how to improve it, you have to continuously improve the process. So you start where you at with Kanban. You start creating those storage tickets, and then you initialize the process and you keep on improving it. So visually, it's very interesting, but Kanban board looks something like that. And this is from the previous video where we actually had a project in Scrum, right? But in Scrum, if you go into actual board, it's essentially going to be the same as a Kanban board. So you'll have a set of stories and tickets and tasks in backlog that's going to be selected here for the work. They should be prioritized, so the top priority goes first, and you move through those columns. You essentially move this ticket through work to in progress, and let's say there's some WIP limits in each column, so you can't have two or more tickets here. Let's say 3 in progress, so that means developers don't work on 3 uh, different stories or features, more than 3 at the same time, right? Once you have more than 3, this whole column gonna light red. So you'll immediately see there's an issue there. Then it moves to QA. Again, QA also will have like a WIP limit in their column, so maybe not more than 3 as well. So you can test 3 stories at the same time, not more than that, right? If there's more, then it's gonna light up red, and there will be a conversation why. Okay, then it moves into done, and essentially it is complete. There's no sprints in Kanban. Mostly, there's no sprints. There could be some release dates. There could be some, epics that have some expectation delivery date, but it's not really working in a sprint manner. It's working by moving those stories from left side of the board to the right side based on the priority, right? And it is continuous work, continuous delivery. As something small gets in, it's done. You want to ideally release when it's done. A couple of things that are not visible here, but you also can have swim lanes. A swim lane essentially is like a separator in your board that stretches across all of the columns. And what can be two different swim lanes, for example? Well, you can have a swim lane for software development in the process, and then let's say maybe hardware development in the process. Or you can have a swim lane for internal use or external use, or top customers, most revenue making customers, or maybe some other type of customers. So swim lanes is essentially dividing your board with a specific set of end users that going to be receiving the product and how it's going to be delivered. Like what are the differences between hardware development swim lane or in the software development swim lane, right? Completely different products. They maybe go one together when you build, but the swim lanes for process is going to be different. Okay. And essentially, yeah, that's it on Kanban and Lean. So hopefully this was helpful. And if you, why I like Lean, because when I was working in different type of agiles, frameworks, methodologies, right? And one of the problems when you have sprints, you if you fail to deliver, your stories kind of overlap and then go into the next sprints, and the workload increases. The date of the release doesn't actually moves, and by the end, closer to the release, you'll have like this craziness happening that there's so many work that overflown from previous sprints, and it was pretty hectic, right? With Kanban, everything seems very seamless. It's like a flow. It keeps on going in a pretty predictable pace. And because tasks are moving by priority, it's very visible what's been worked on, what is the top priority, how it is moving through the board. And the whole idea, it's just like continuous. Hey, there's a story here, moves here to done. And then again, moves here, moves here, moves here, moves here to done. Uh, those stories again, normally they're epic based, so they based on some larger feature. And once one epic is completed, another epic is started, and then again, stories from this epic they keep on moving like that. Uh, for QA, of course, for QA, the task of QA is testing, verifying, making sure that the requirements make sense. You know how to test it. If you find issues, opening bugs, and making sure that you're delivering quality software. And also, you make sure that the quality is built in. So you give your QA opinions on the tasks, how they're going to be tested, how they're going to be verified. So there's a visibility, and developers know what they need to look out for when they build. All right. So this is pretty much it on Lean and Kanban, based on my experience. So hopefully you enjoyed it. We're gonna have one more video on development methodologies, and then we're gonna get more in depth into actual QA stuff. Okay, this was Alex USA Days. Leave a like if you like this video, subscribe, and there's a link to the whole playlist on how to learn QA from scratch in the description to this video. Thank you for watching, and bye bye. What's going on? This is Alex USA Days. So today we're going to talk about shift left and shift right development methodologies. This is actually the last uh, video in the section for the development methodologies. After that, we will move from section 2 into section 3, where we will talk about types of testing, test plans, test creation, and overall, I'll give you my methods on creating test plans, test cases, test matrices, and approach to managing testing overall in general. I will mostly focus on what I've been using from my experience and types of tests are that are the most popular ones. Even though I'll probably list all of them or whatever is out there, but mostly going to focus on what is really hands-on and being used in different places. Okay, so but on the today's topic, we're going to talk about shift left and shift right. So essentially, if you take a look at this coverage, test coverage based on the approach, with shift left methodology, you just tend to move everything or shift everything to the left in terms of testing, and you want to start testing as early as possible. That's why you see it spikes here in the development stage, starting from the design, spikes into development, um, goes a little bit down in the test environment overall, and even less in deployment and maintenance stage, right? This is with a shift left. So shift left is moving tasks and activities closer to development. Emphasis on problem prevention. this is what is shift left all about. And then there's shift right. And this is not a concept where you actually move testing closer to production. So you focus on controlled production testing. So this way, you see there's still some tests happen in test environment, but a lot of testing happening on deployment, after deployment, in production, during the maintenance stage. So that's the core idea, and that's the core difference between shift left and shift right. Now, if we're going to talk about tools and the approaches and what is actually being used, so in shift left, we want to focus and work on early task planning. So QA and overall team is actually participating in customer, well, not exactly customer meeting or client meeting, but during groomings, you will talk with product owners or product manager, depending who's running in the team, running the whole the process of the moving forward all the features and everything that was on the plate for stakeholders. But essentially, you want to work early with the team and plan tests accordingly based on the requirements as the requirements being created. So there is this story or this feature we're going to work on. What kind of testing can we do on it? Like what kind of testing activities we can build into the story, right? So the creation of the documentation goes hand in hand with the ideas how it's going to be verified, how it's going to be testing. So this is why it is shifting left a lot, right? So work early on test planning. Then there's a lot of coverage that should be done with unit testing by the developers. So a lot of tests that nuclear tests, the atomic tests, very small tests that test just the functionality on the core level should be covered with unit tests. So a lot of emphasis here on actually development taking charge of a big chunk of testing here with unit tests and with integration tests. So if they have different microservices communicating with one another, or they have different components of the system coming together, all the integration testing also should be done with shift left early on during the development by the developer. So it covers a lot in the idea to prevent bugs, right? So it covers a lot of the functionality early on before the code is actually ready or it's in test environment. Then there's also focus on a lower level testing, on API testing. Could be here also like database testing and backend testing. So before there's actual UI, there's still some API and some other ways to interact with the system, not just through the user interface. So that type of testing also, prioritize and shift left. So essentially, you want to cover as much as possible to make sure you prevent issues before they happen, before they're discovered in the user environment, right? Within the user interface and the UI. So with shift left, quality is at the center of product planning, design, and architecture. A couple of things that are popular, the framework developments that are popular in shift left is TDD and BDD. So TDD is test driven development, where you write your tests first and then you build code for those tests. And BDD is a behavior driven development, which is came from TDD, but it's about putting the functionality in plain English, how systems should behave. Using like Gherkin language, and then essentially building the functionality around that BDD behavior driven approach, right? I will leave links in the description for shift left, for TDD and BDD, so you can read about them and learn about them, understand them a little bit better. But in a nutshell, this is what is shift left about. So testing early, a lot of testing activities happening and planning happening before it actually goes into test environment. I'm not even talking about production or maintenance stages, but even before test, even in development, right? In dev environment. So what is shift right here? Well, shift right, on the other hand, is actually tends to focus more on production post-production and maintenance. So what that means? Well, for example, you can do canary releases. So you do smaller batch releases and monitor system how the system behaves with the new code. Uh, so, for example, you will start using only 5% of the users with the new deployment, and you will see, you will monitor logs and whatever transactions are happening in the production to make sure there's nothing going wrong with a smaller batch. And if everything's confirmed okay, there are no regressions, everything looks good, then you're going to increase the percentage of users using the new production, new system, new deployment, and essentially you will increase until you have 100% there. So this is one of the approaches into testing in prod, right? The other approach, you can actually feature flag your code. So feature flagging in code means the feature that you release, you can essentially turn it off immediately. So if something's broken in prod and the feature is giving you trouble, and normally it is done, again, if you're doing CI/CD approach, so you're releasing smaller batches, you're not waiting 3 months to release like a huge build. No, you ideally release every week or so. And then you can feature flag, and if something's not working in prod as expected, you immediately turn this feature off without even user noticing that okay, something was there that was breaking the system, right? Also, idea of right is monitoring production logs for errors, response times, how is the production handling load, um, and creating automated regression suites in production. So large automated regression suites in production, end-to-end testing after deployment. So it runs through. Ideally, the scenarios should create data and then remove the data. So you're creating tests that are clean and they're not adding any extra data into production aside from the test phase while they're executing. Um, Shift left and shift right are mostly uh, DevOps terms, and a lot of talk about shift left and shift right in Agile and DevOps. But it is also part of QA. So if you work specifically in a team that try to implement one of those approaches, as a QA engineer, you'll have to participate and you'll have to bring testing either more to the left or more to the right. Again, all of this is more or less based on my experience. It might be different explanation in the place where you're going to work or implement it differently. This is fine. I mean, a lot of companies just implement things as they wish, as they desire, right? They just kind of take the core ideas and bend them. Also, shifting left or shifting right doesn't really mean that there's no testing in test environment. There's still going to be regression, end-to-end tests, acceptance testing on the UI side in the actual test environment. But the focus is shifted. My personal thought on either shifting left and right, I think you have to implement a little bit of everything. So you do want to shift left. You definitely want to have a lot of coverage early on the functionality. You want to have unit tests, integration tests. You want to have API covered in order to prevent bugs getting into test environment. You want to rule out all the bugs before they get to test, so the testing goes smoothly, and you don't have to open tons of bugs and send the tickets back for the developers to fix them. But you also want to make sure that your prod is stable and there are no issues in production after the release. You definitely, if your production is testable, you definitely want to do a regression in production. You definitely want to make sure your release is not breaking anything. So I think the ideal approach is somewhere in between. Of course, everything depends on the resources and time frame for the testing that is allowed. But the best case scenario where you actually have both shift left testing and design and approach implemented, some of the shift right as well, and also you have confidence and good coverage in the test environment. So whenever you're pushing something through the pipeline, you're confident that this build is not going to break anything, and the features, the code is everything's going to work as expected. Okay, so I will leave some links to all of those terminologies in the description so you can do some more research and read about them. Yeah, leave a like if you like the video, subscribe to my channel. I will post a lot more. And again, we're moving into more like actual test cases, test creation, and different tools and so on. So we're getting there. We're getting into the uh, becoming QA professional from pretty much from the scratch. Okay, thanks everyone for watching. This was Alex USA Days, and bye bye. Hello everyone, this is Alex USA Days, and we're continuing with our journey learn quality assurance from scratch. So now we're moving into a new module. Today we're going to talk about types of testing, but it also has a little bit about test plans. And with the last video, we actually completed the section on development methodologies. Okay, so there are about 100 different types of testing, even more than that. There's a lot. You don't have to remember all of them. You just need to be aware that they exist. We will talk about the main tests, main types of tests that perform during QA. It is really hard to cover in a short video everything. So I will provide links in the description to this video where you can read more about what kind of tests there are, what kind of tests exist. One will be to the Guru 99, the other will be to Atlassian website. Essentially, you will probably maybe use like 5, 6, 7 different types. What kind of tests what kind of types you will be running will greatly depend on the application you will be testing, customer, the end user, who it's designed for, by whom, and so on. So there are really a lot of variations. What kind of product you're testing, what kind of tests you will be running. But on the highest level, I think you can break it up into those categories. So you can have black box, white box, or gray box testing, where black box you provide input and then you get some output back. You verify this output. And you have no knowledge of the system. So black box term actually comes from programming, where it means exactly the same thing. You receive some sort of a system that you need to work with, but you have no clue how it works inside. You can't really look in the code. So black box testing is mostly like manual testing without access to the code. Then there's white box testing, and with white box testing, you do actually have access to the code. You know what's going on inside. You know the functions that are running, and maybe you even work in the same repository alongside with developers. Maybe you're doing some automation. So it involves a good extent of coding knowledge, understanding the code base of the application, what it's doing. And then there's a gray box testing where you maybe have some access to code at some place, at other places not. It's a mix of both, or maybe you're just testing something in between, so you don't really know what's going on the back end, but you do work with API. So gray box testing is essentially like mix of both when you're testing front end, back end, looking at the code or not looking at the code. So it's a mix of everything. Then you can break up all the tests in positive, negative tests, where positive tests they're also called happy pass tests. So you verify what user is supposed to do. So if user needs to log in or they provide proper login and password, they log in. If the user needs to create new account, they have to have certain complexity for the password, certain lengths, maybe certain symbols are not accepted. Negative testing is actually acting like a user that doesn't really know what he's doing and trying to kind of break the application or see what happens if you provide some invalid input, do some unexpected actions from the user, and see how the application handles it. So in our example of invalid login, like we had valid as a happy pass, and valid login, you try to provide an invalid password and verify that the actual error comes up. Or when you try to create an account in the password, you start typing out invalid characters when you're trying to create new passwords. So it also should gracefully handle it and show some errors to the user. Then there's functional and non-functional testing. So those also include a lot of different tests, different categories within them. But functional testing is the testing where you test against the requirements, and it is an acceptance criteria based testing. So you want to look at the actual functionality of application, what's supposed to do. It includes unit testing, regression, integration, user acceptance, localization. We'll talk about those types of tests later. And then there's non-functional testing, where verification of the system is more about the stability and performance. So it's including stress testing, performance testing, load testing, security testing, and so on. Okay, so this is like the highest level. Now we're going to talk about categories that are more popular, and you most likely going to see them almost in any company you work. Maybe a little bit less of those or more, but this is very close to like having everything that you're going to encounter throughout your career. Some of the things might not be here now, or you might work for some industry or startup that has some specific testing. So I definitely recommend going into the description for this video and checking out the links to other types of testing just to get familiar with them, so you understand there are more other possible test type that exist. Okay, one of the most common types of testing that you're going to see almost everywhere is acceptance testing. So acceptance testing is essentially verifying feature or features and that they are implemented according to business requirements. You might also have heard about user acceptance testing. So this is essentially the same thing. You have a story that's been in works, developers finish it, you do some verification of the story, and then you're okay to be released. It's acting as described in the acceptance criteria. Then there's regression testing. Regression testing, there are kind of two definitions. Some of the regression testing specifically evolves or revolves around bugs that you verify that nothing got broken after a bug fix. But I think in more recent ways, regression testing is like standard for rerunning through a set of scenarios after a bug fix, deployment, or release. If you're automating regression testing, those collection will be like the largest collection. So you'll have regression testing based on the priority, where you first will verify P0 test case, P0 being in like most important, then will be P1, P2, and P3. So regression tests, you essentially keeps on growing. You keep on adding testing there, making sure that you're covering most or all of the functionality that you want to verify once the application is released. If something gets outdated, your regression testing will get updated and some of the tests will get removed. But this is one of the most typical tests that you will be running, regression testing. Then there is API testing. Not all of the companies do API testing, or they do it in unlimited way. Some companies may be more API focused. So if you work as a manual engineer, maybe you'll not be touching API testing. But if you're looking to get into automation and grow, I think starting with API testing after manual testing is one of the great ways to kind of begin working in that direction. So API testing is mostly verification of communication between front end and back end nowadays, but also essentially API stands for Application Programming Interface, and it is a middleware that allows different programs to communicate to one another. So there's a layer communication, there's a communication protocol, and there's a layer application between front end, back end, or two different apps that will allow them to talk to one another. Okay, this is API testing. This is actually testing that part. Then there's exploratory testing, and exploratory testing is verification that relies on testers' bug discovery approach around application functionality. So you as a tester with some experience, you look at the new application and you start testing a little bit outside of your normal testing process, not your normal regression or acceptance testing, but actually try to navigate yourself around the application, see what things you can break, how you can interact with them differently. That would be exploratory testing. It is mostly based on the tester's experience. Then there's boundary testing. Boundary testing is also quite common, and this is verification of boundary values. For example, verification of accepted age. So a good example would be, for example, you can use some piece of machinery or some application only when you reach 21, but you cannot use it if you're older than 100 years old, right? So your lower boundary will be 21 is positive test, still accepted input. 20 negative should not be accepted. This is your lower boundary for the acceptance for the boundary testing, right? So if you can use a start at 21 on the lower boundary, you test 21 positive scenario, 20 negative. On the upper boundary, your positive scenario would be 100, and your negative scenario would be 101. So 100 should still be accepted, 101 should not be accepted. You can also throw in maybe a scenario in the middle. So let's say 50 is the 50 still going through. But typically you'd see lower boundary, positive, negative, upper boundary, positive, negative. There's also something called smoke testing. Sometimes it's called sanity testing. Sometimes they're different. Every place will talk a little bit differently about what smoke is or sanity testing for them. So through my careers, sanity testing is mostly just some developers having some build, they making sure that it still works properly before you handle it to QA. So like a very, very initial verification of, is my app still launching, kind of a thing, right? Smoke testing is preliminary testing where you verify major functionality of the application and that it works as expected. So you would load, you would log in, you would, I don't know if you're using some specific application, let's say YouTube app, you can post a video, leave a like, and stuff like that. Essentially, your smoke testing enables everything else. If smoke testing passes, that means all other types of tests, you can run those, you can schedule those, you can do whatever. But if smoke testing fails, means there's something wrong, the build has to go back, right? So smoke testing is required to enable all other testing processes, right? You don't want to start scheduling everything until you know that your build is pretty much stable. Then there is a type of testing called beta testing, and beta testing is early version verification in production environment. So the environment that actual users will be using on those servers and so on. There are two types of beta testing. There's closed beta, which is will have like limited number of users, and there's public beta that is going to be open to all. Beta is close to release application. It's very close to actually ready application, but it's not there yet. So the idea of the beta testing that you will have people try and test your system to find any extra issues or unexpected things before the big release. And if you're into gaming and you play games like I do, I play a ton of different games. There are a lot of beta testing. And you actually have to pay sometimes for it. So you would buy, not in terms of paying for the testing, but you would buy a game early release or early package for the game, pay a good amount of money. So also you can get a chance to participate in beta. So you can play the game a lot earlier than it's actually going to be released. Okay. Another common type of testing is stress testing. And stress testing is verification of stability, reliability, and performance of application under heavy loads or prolonged periods of time. So one example of stress testing would be, hey, what if I have this YouTube application and I'm trying to have millions or billions of users launch it at the same time on different laptops, right, machines and phones, and then or there's a video that I'm gonna try and play like for hours and hours, maybe 48 hours or 72 hours, and see how it behaves, right? Depends what we're testing here. Is it the app? Is it the system? Is it actually the phone? But stress testing essentially is structured around stability, reliability, and performance of application, and seeing the limit. How far can you push it to break it, right? This is stress testing. How long you can run tests, stress in the application. Then there's some more. So there's load testing. It's kind of close to stress testing, but load testing is measuring how a system will manage and perform under heavy load volumes over time within expected limits. So your goal is not to crash an application here, not to break it, but just to make sure that it handles the load properly, like it's doing what it's supposed to do. And if your website should handle 1,000 requests at a time, it should handle 1,000 requests. It should not decrease the performance, or the response time will only increase in a certain allowed amount of time. So it's not going to be 3 or like 5 minutes to load a page, maybe a couple of seconds, right? Then there's accessibility testing, and accessibility testing is verification of inclusiveness of application for as many people as possible. So it includes speech recognition, reading assistant, special inputs, and so on. You can read a little bit more if you're interested in that specific testing about the accessibility. You can read the web content accessibility guidelines. But essentially, this is kind of very focused on specific type of testing. There are certain tests like accessibility and localization where you can have a dedicated QA doing just that, right? Focusing on those specific features. Then there's localization, and it is verification of usability, accessibility, and content translation for a specific language region. So not only that it's translated properly, but it also makes sense. There's some maybe phrases that are common for the region and the overall application. So it's going to be different localization testing, for example, Spain. If you're trying to move application from England and create your branch in Spain, and then it's going to be different localization testing for Spain versus localization testing for Mexico, because the Spanish there is different, right? And there's different variations, different things, like a lot of things that specific to that region have to be verified. And there are also QA positions that just do that localization testing. Then there's security testing, and security testing is a search for system vulnerabilities and exploits so they can be fixed early. For example, penetration testing that use different tools to find weaknesses and imitate attacks. So there are tons of different tools to perform different types of security testing. And now actually you have a very specific branch of profession called cybersecurity specialists that do a lot of that. A lot of security testing falls under cybersecurity, and cybersecurity is actually designed to prevent infiltration, data leaks, and cyber attacks, where QA security is more into finding issues during development if there are security issues. And there are two other types of testing that you're going to hear a lot about, and they're very common, but they're not exactly QA type of tests. There is dev testing, where they do unit testing. Unit testing is verification on functional level, like the smallest functions possible that should be created by developers alongside development effort. So if you know, for example, that password field only accept letters and numbers and not special characters, a unit test that a developer might write alongside of the creating that function for the password input, that he'll try to pass along special characters, and the test should return some sort of meaningful error saying that they're not allowed. This is unit testing, so they create the tests around functions like on atomic, very small scale, right? And there's integration testing. Integration testing, when you have multiple functions, multiple modules, maybe multiple microservices that talk to one another. So developers would actually build tests that will trigger other services or other responses, where you verify multiple modules or functions combined, and you verify them as a group. So, it's not just A plus B equals C. You also do some other functionalities with C later on, involving other modules in, and, your testing becomes more complex. But you need to do integration testing because you need to understand that all of the components of the system are working properly. This could be integration testing on a functionality level. This can be also integration testing on hardware software level, when you try putting your processor in different motherboards, so you kind of already like on a system level now as a whole thing. So yeah, that's in a nutshell. I'll probably pick a couple tests specifically from this list that we're going to talk a little bit more about, and I'll have additional slides, ones that you will see almost all the time. And then from that, we will move into test plans, right? What they are and how you work with them, how you get them, how they're created. And yeah, that's pretty much it. This section is not going to be very long, but I definitely recommend you go into the description, and I have a couple links there to show more types of testing. Just read them, get familiar with them. You don't need to remember them. The tests that I list here, those definitely you want to research more, take notes. So like this whole list, because those are the types of tests you're going to be running most likely one or the other out of that list when you join a company, right? Those are very common. The rest, just get familiar with them. They're in the link is in the description, so you are aware that they exist. Okay, so this was Alex USA Days. Hopefully you liked the video. Leave a like and subscribe. Leave a comment if you want to talk about something, and you'll see more of those videos on how to become QA tester from scratch, from manual, and then maybe some automation as well. I'll keep on posting like every weekend, add more content. Okay, thanks everyone for watching, and bye bye. Hey everyone, this is Alex USA Days, and we're continuing to learn quality assurance from scratch. Today we're going to talk about test plans. So we are in Module 3. We covered types of testing. We're covering today test plans, and that's going to be the final video for this third section. And then we're going to move into section 4 on bugs and how to report them. Okay, so what do we know about test plans? So test plan usually is a high-level document that includes test strategy and description of required actions and procedures to ensure that product or system meets its design specifications. Test plan should be based on defined system requirements. So could be PRD, which is product requirements document, BRD, business requirements document, or SRD, system requirement document. Those requirement documents are normally prepared by a business analyst or product owner or product manager. Test plan may include authors, contacts, responsible parties, revisions, versions, table of contents. It also might include general requirements, compliance standards, defined scope of testing, definition of pass-fail. It may include strategy for each testing type, for example, like acceptance testing, regression testing, compliance testing, accessibility testing, and so on. And testing activities at each stage of the product's life, test objectives. It also may include described test environments, test tools, system test configuration, supported systems. It might include test diagrams, test flow, pass-fail conditions, and sometimes actual tests. So some test plans might be very detailed. I'm going to add some of the links that you see on the screen into the description. So there is an article on Wiki about test plans. It's a little bit outdated, and we're going to open up at the end of the video. And then there's a newer standard for testing and test plans, ISO standard, ISO IEC 29119. There's a link to that on the Wiki as well, and I'm going to open it and show at the end of the video. You also, if you really want to, you may purchase the newest standard. It's about from $70 to $120, depending on where you buy it. I'm going to have this link available in the description as well. But normally, if you're purchasing a standard, you will be using this for like a major setup, probably in a bigger organization where you want to follow the standard. Definitely, that's going to be done through your employee. Purchasing on its own, just to review it and look at it, I think it's unnecessarily, because it still has more of a kind of generic guidance to it. So it's not going to be like a very defined example that you can straight use for your system. It will always have to adapt to your actual product, right? So what is the purpose of the standard? The purpose of the ICO IEC IEEE 29119 series is to define an internationally agreed set of standards for software testing that can be used by any organization when performing any form of software testing and using any life cycle. So again, it's very high level, like generic guidance of how to create test plan. What happens in reality? So in reality, you will see test plans rarely. They're not always used. Test plans are mostly used in bigger companies with well-established QA processes. So there will be a QA department, the testing cycles, all of the processes are already established. Rarely you're going to just start on your own, go into the startup and, hey, I'm going to create this test plan for the company. It might happen though, right? Or it is used in regulated industries. So industries that have a lot of regulations, that have very specific set of tests. Your test plans for those industries are going to be based on the regulations. Sometimes the test plans are going to be provided based on the regulations, like by third-party authorities that oversee your industries. Okay, so you'll have to correlate your testing with those test plans. For agile startups, often there's no test plan per se. What happens with startups, you have to rely on project managers' client communications that are recorded and the requirements that are recorded within epics as part of an ongoing effort to improve product. So there will be epics that describe the new feature that's being built. Within those epics, stories will be created, or like so-called features, what have to be implemented with acceptance criteria, a very high level description of the actual epic, what needs to be done, why it needs to be done, and so on. So based on that, you will be doing your testing activities and like creating your testing approaches, how to test things. In that case, QA practices may be recorded and managed like through QA common knowledge space, for example, in Confluence. So there will be no test plan, but you'll have a reference point where all the best practices for QA is recorded on how to approach one thing or the other thing. So in that place in Confluence, on the Confluence page, for example, QA processes are modularized and recorded in different sections. So for example, there's knowledge base with bug template and how to file a bug, or how to perform regression, or prepare a test matrix, stuff like that. And I have a diagram from a test plan. So this is like the startup doesn't exist anymore, so this doesn't really matter. But you can oversee how it kind of looked here. So kind of starts here with a story completed by developers. Developers do their unit tests. There's some security verification in place, and goes into the stage server where the regression testing is performed. This is one pass, and simultaneously kicks off another pass where test cases developed based on the stories, or so-called, again, based on the epics and the stories within the epic. Then there's exploratory testing that happens right after the build is in the stage server and the stage environment. Then there is acceptance testing. This is for a specific browser like Chrome. Some of the tests are candidates for automation. There's feature testing, API testing, then cross-browser testing for multiple browser supports that happen. Then there's performance and stress testing. Then there's localization verification happening. And then it goes into beta testing and deployment, also plus security verification. And then the actual deployment happens. So if in any of those stages of testing there's a bug, it gets into Jira, the bugs is getting logged, it goes into the backlog for prioritization, then goes back to development to being fixed, then goes into regression testing, and the whole thing kind of starts over, right? If needed. I think this also can be bypassed with verification in the stage server and going then into the UAT, the beta deployment stage, and then again into the deployment. And then if the bug is found in the deployment, it's a production bug. If it's a production bug, it goes back into Jira, getting logged and getting fixed. All right, so that's just one of the examples for the flows you might have. There's so many different factors into what goes into test plan. It depends on the industry. What industry you're going to be work as a tester. Depends on the company size. Depends on the established practices. Some of them are using more like older versions and kind of structurized versions of testing plans. Others moving faster and doing agile kind of a thing. So, but it's just good to understand what it is and how it might look at the place where you're going to work. So now let's go to the actual wiki links that I was posting. So one of them is for the test plans. Let's open this up. All right. Yeah, so here it describes, this is older standard IEEE 829 for the test plan structure. So that was back in there is a date here somewhere. 2008 was the latest one. I think after that it moved to a newer standard, right? So 2008. So what stages are for the test plan here that described in the Wikipedia? Let me zoom in a little bit more. So test plan, identifier, introduction, test items, features to be tested, features not to be tested, approach, item pass, fail criteria, suspension criteria, test deliverables, test and task, environmental needs, responsibilities, staff and training needs, schedule, risk and contingencies, approvals. So this is per older standard that was back in 2008, like the latest version of it. Now, with the newer version, what you will see, let's open this up. So you'll see organizational test process for documentation. So there's a policy for testing, test strategy now. You will see test plan including test strategy, test status, test completion. So in the test management process and documentation, you will see also dynamic test process and documentation. So design specification, test case specification, procedure specification, test data requirements, test readiness report, test environment requirements, test environment readiness report, actual result, test result, execution log, incident reports. So it gets more complex. It's not an easy task to create a test plan and maintain test plan. Ideally, you want to have a generic test plan that does not change a lot. It covers a lot of stages and what actually happens, how to react and respond to certain things. But it's pretty. It can get pretty complex and can get a lot of parties to work on that test plan. So it could be a whole QA department that managing test plan, adding stuff there, making sure it's up to date, everything's covered, and it also depends on the range of the activities that needs to be done for specific product, like testing activities. Okay, so yeah, essentially this is it. Let me know if you have any questions. Hopefully, this was helpful, and you learned today a lot about test plans and how to implement them to your place, to your work. Yeah, this was Alex USA Days. Thanks for watching, and bye-bye. Hello, everyone. This is Alex USA Days, and we're continuing with our playlist, Learn Quality Assurance from Scratch. So today we're going to talk about bugs and how to report them. Now we're here at Module 4. After that, we're going to move into managing test cases and documentation. But this is going to be pretty much one video in the module where we're going to talk about bugs, and I will show you how to file a bug. All right. So what is a bug? Bug is an error or unintended outcome that is violating acceptance criteria, breaking expected system behavior, undermining integrity or stability of the system. So essentially, if you see something that is out of place, it's not acting as expected, this is potentially a bug, right? Now, it is impossible to have bug-free application because even if you freeze code for the most perfect application, the system it interacts with will change, right? So eventually causing issues and breaking application. So think about your new iPhone and the apps it has. And let's say you never upgraded your iPhone since iPhone 4. Do you think the apps that you're using right now, even if they're bug-free for your current phone, would be able to run on iPhone 4? Probably not, right? So everything's changing, everything moving. So many systems that apps interact with, it's almost impossible to have a bug-free application. It's actually going to be pretty expensive to have massive effort to release something completely bug-free. So what is the solution? Well, it's important to remember that product quality should be that the product quality should give competitive advantage for the product that's being developed. So it should be better than competitors quality-wise, first of all. Second, quality should be an integral part of development process. So, it should be built into the process. Everyone should be proactively looking for issues and trying, resolving them. And all issues that are reported, they should be assessed in timely manner. And if they're critical and important, then, they should be resolved accordingly, based on how severe the issue is, how many users impacted. When and for obviously for highly regulated industries, for finances or healthcare or other industries that have certain standards that they have to follow through, they have to abide uh, to certain regulations. All of those regulations and standards, they have to be matched, right? They have to abide with all of that. That is out of question. It's also a matter of quality control for abiding with regulations, definitely. But this is like, that part has to be perfect. Okay, I'm gonna give you a little homework. There are different types of software bugs. There are different classifications. Each company will have a little bit of a different classification, how they put each bug and how they classify them. Some companies won't classify the types at all. So I don't think this is essential, but I want you to do a little research and just Google and read about different software bug types. So you know that they exist, like what is a functional bug versus a security bug or some other types. Okay. Um, Now let's go to bug lifecycle. So something I want you to remember, that bugs that are open, they go through a certain process. So that might be a little different from place to place. Again, will depend on the company where you're going to work. But essentially, every bug is opened as a new bug. Then it goes through some sort of a triage or assessment. When it's decided, okay, is this a real bug? How critical it is? Who will work on it? If the issue is not a real issue or there's no intended fix that's going to be implemented, then it might just get rejected. After that, if it is decided that issue is real, they know who will work on it, what's the severity for the issue. It will be assigned to a developer. Developer will work of that on the issue, and after the work is done, it's going to be uh, marked as fixed and sent to QA, where QA will verify if the issue was actually fixed, and if it was, then the bug will get closed. If it wasn't, then QA will reopen it, send it back to development to get properly fixed. Okay, and what bug reports have? Like, what are the components of the bug report? So bug report will have a title, so name of the bug. Name should be short and descriptive. You don't want to have a couple sentences. You don't want it to be really long. Someone who's looking at the bug out of engineering, let's say from sales or some other person, or a QA engineer from another project, they just should read the title, understand what's going on. What is broken should be short and descriptive. Then there's ID. So ID is a unique identifier for ease of reference, and normally the system where you track and open your bugs should auto-generate IDs for the bugs. They obviously should be unique. Now, there's also a priority, sometimes severity. Priority is how fast the issue needs to be resolved. Sometimes it is measured in like P0, P1, P2, with P0 as being the highest, like a blocker. But other places just use blocker, critical, severe, or other methods, however they want to classify them, but from like the highest to the lowest. Then there's a summary. So it's an additional information in description if needed. So if you could not capture everything in the title, you can have a descriptive summary. Steps to reproduce. You can see I highlighted steps to reproduce. It stands out a little bit from other types, from other components, because steps to reproduce are important. One of the most important parts of the bug. It is exact steps to trigger the issue. Often you'll have an interview question where they ask you, okay, name several components of the bugs that are critical that you can't have a proper bug without. I would say that steps to reproduce is one of them, because if you don't know the steps to reproduce, you can't verify the fix, you can actually trigger the bug. So it's important to have them. Then there's expected results. So what should happen according to acceptance criteria or business requirement documentation. So what was proper behavior, what you should have expected. And then there's actual results. So description of issue observed, what happened. Another field that I highlighted is environment. And environment is system and conditions under which issue happened. So if you were using a specific browser where you were testing in test environment or it happened in production, um, though environment is important as steps to reproduce, because without environment you can't reproduce the issue. If, for example, your bug is happening only on iPhone 13 Pro is the latest iOS version, maybe on Chrome, on a uh, web browser Chrome installed on that phone. If you don't have those details in the environment, even when you have all the steps to produce and someone tries to follow them along, they won't be able to trigger the issue because they're using Samsung, and you were using iPhone. So it's important to have the environment description to understand where the issue happened, right? What was the environment when the issue happened? And the last thing is logs. I also highlighted as one of the most important parts of bug. In the logs, I mean screenshots, videos, stack trace, console output, whatever is the visual confirmation showing how the issue looks when it's happening. It is important to have logs so you can verify once you verify the issue's result, it is not happening, it's no longer there. And if it's not resolved, you can see, okay, this is the behavior, it's still happening. Sometimes issues could be partially fixed, so maybe you won't see the same exact issue after the fix, but maybe you will still see something else. You can add those logs as well. Okay, so this is all in terms of file and bug. So let's have a little demo. So here we have Jira. We will open it in this Jira, in this project. We will open new issue. And for taking the screenshots, I'm going to use Lightshot. You'll have the link in the description for this program. It's free to install, works on Windows, works on Mac, easy to take screenshots for your bugs. You can use it if you want to. And I'm going to use this demo, automationpractice.com. I'm also going to have a link in the description. And the issue I'm going to show you right now. So this is a web page. You can't really buy stuff here, but you can practice your automation, or in general, just do some QA practice. So I have this product opened and there's a quantity I can provide when I'm ordering the product. So for the quantity, I'm going to provide minus 199. So I'm actually given a negative quantity for the product, and then I'm pressing, even though quantity is highlighted red, so if I put a proper number, there's no error, but if I put minus, it is highlighted. It still allows me to add items to cart. So if I press add to cart, it actually was added. It just added 199 instead of negative amount. Well, I think the proper design for that would be not allowing a negative number in the first place. And let's say this is what our description says, our acceptance criteria say, okay, you can't really shouldn't be able to add negative amounts in here. All right. So then, okay, we have our issue. Let's maybe take a screenshot beforehand. Normally, you would want to avoid tabs. So if you have any other tabs open that not relevant, do not include them in your report. And then you want to highlight where the problem area is in the screenshot. So something like that. So I'm going to press Control C to copy this. So it is copied, it is stored. Then when I'm going to open my bug, I'm just going to paste it in the bug of the body, the screenshot. Then in Jira, I'm going to hit create. I'm going to select issue type bug. So this is our issue type. So here's a summary. So summary is exactly the title here, right? So name of the bug should be short and descriptive. So for our bug here, what can we name it? So let's think about. Okay, so quantity field allows negative input, right? So let's say product quantity field allows negative numbers. Okay. Or maybe we can be more sort of saying product quantity field should not allow. Let's put it like that. Should not allow negative numbers. Okay, so when you read this title, it's actually pretty descriptive, right? We know what's happening here. Then next thing, what we're gonna do, let's take a look. So ID will be generated with the bug being opened. Priority. For the priority here, by default, normally when you open a bug for the priority, you just open as a medium level, right? Unless something is explicitly like broken, the main pass is blocked. Let's say you're trying to load an application and it crashes, or you use a banking application and you try to send or receive money and it's not going through, or you're trying to post something on your feed in Twitter and you don't have a feed working. So whatever is blocking the core functionality of the application, and there's no way around it, is a blocker. When you have a blocker issue, it should be raised immediately. You should tell your manager saying, "Hey, this is a blocker. Let's get it fixed. Here's how you can reproduce this. Here's the devices affected. So here are all the logs." So blockers, it's important you have them visible right away. Everything else, I mean, you probably want to also communicate to the management like a high critical high issues like one above the blockers. You still want to communicate those, but everything else is open as a mid level generally, and then they gonna get assessed, triaged, whatever the process is gonna be. So in this our case, I think we can put this as a medium bug, right? So P2. Let's see if there's priority here. Okay, so we don't have an actual field, a priority field here for the bug once you open it. That's fine. That's okay. This board is not configured to have a priority here. You can select what it blocks, but no priority. Okay, it's fine. What is next? Well, now we have summary. Do we need a summary? I don't think we really need the summary for this, but maybe just for the case of showing it, we can say summary user. So user is able to provide negative number for product product quantity. Add the checkout at the checkout the negative is omitted and the value becomes positive. So I added like additional information explaining what's actually happening if if it wasn't clear enough from the actual title here. Okay, so we have summary. Let's go back here. So priority is not configured in our board. That's fine. Steps to reproduce. Okay, steps to reproduce. What would be the easiest, the fastest way to reproduce this issue? Let's think about it. Okay, so probably we can go directly to the product page and enter quantity amount here. Before I start copy pasting for the link, let me just paste the screenshot that I did before so I don't lose it. Okay, so here's our screenshot of the issue. It's just going to be directly in the body here. Okay, so steps to reproduce. Step 1, go to product page, and we're going to provide a link here. Step 2, enter -10 quantity amount into quantity field. Step 3 would be click add to cart. Something like that. Okay. So this is the steps to reproduce. If you go through those steps, you should see the behavior happening. Should be triggered. All right, we're good here. What else we have? Expected results. So we don't have an actual acceptance criteria. We don't know. So we're kind of trying to figure out what would be the expected results here. But expected. Okay, so expected results. Let's say expected results would be just should not allow. Quantity field should not allow negative input. Or if we want to be even more descriptive, if we have an acceptance criteria certain number, so should only allow numbers from 1 to, let's say, 100. Let's say our acceptance criteria for the quantity for the product only allows a certain amount. So should only, quantity field should only allow numbers from 1 to 100. And maybe should only allow whole numbers from 1 to 100. Just because I'm curious, let's say I'm going to put here 1.5. Yeah, that's actually also bad. So I'm going to buy a faded shirt, 1.5 of it. How it's going to process it. And when I'm trying to add to cart was this quantity. Okay, for some reason it did 200. So 199 plus 1, I think it rounded it to let's clear it out and add 1.2. See what, well, maybe 1.6. I think it just rounded out down to 1. Yeah, just 1. Okay. Should not allow in any case, right? So quantity field should only allow whole numbers from 1 to 100. That's expected results. And then actual results that happened. User was able to initiate was able to add negative number to quantity field and initiate add to cart. Okay. So we have summary, steps to reproduce, expected results, actual results. Okay, what else is missing? You might have an environment here that you can fill out, like a separate field, separate body. We don't have that, so we're gonna add it right here. Right? So environment, right? And then for the logs, we have the screenshot. So our environment, let's say we're actually doing, because it is a live environment, let's say we have an actual link the users can reach. So we'll say it's a production environment. Maybe we don't have a visible version for the application, but let's assume maybe we have something here. Um, in the test environment, you might have an actual build version or whatever the app version is. So, but let's say version, we're gonna put it just to see to show that it can be present. So version 110 or 120. Our browser is Chrome. I think. Oh, this is actually Firefox. So Firefox, and I'm gonna get the browser version. Uh, about Firefox. Okay, so here's a version of the Firefox. I'm gonna put it here. Different products will require you to put like different environments. So let's say if issue happens on a phone, you want to put phone model, what kind of operating system on that phone. Maybe it happens in a specific resolution, so you want to put that on top of like the browser. If you verified it in multiple browsers and you support multiple browsers, it happens everywhere. You can mention in the summary or add like comments here saying it happens in all of the browsers. If it happens only in specific, you mention like a specific one. So in our case, we're going to mention Firefox, but most likely that it's actually happening in multiple browsers. Okay, so I think we're good with this body overall, right? Let's double check. So logs, environment, actual, expected, steps to review, summary, priority. I think everything is there. Now, some other fields. Sprint is, if it's normally you don't put sprint because if you create a bug and you select sprint immediately, it's gonna assign it, put it within the sprint. But normally you want it to go through triage process. So if you don't put sprint here, it's gonna immediately go into the backlog here. It's like a backlog is like a collection of all things to do, right? Where you pull tasks from. Story points estimate. This is something that normally developers put for the stories. How long is it going to take them to fix this for the bug? We're not going to do that. Reported as me. We're not signing to anyone by default. It's not blocking anything. Okay, I think it's good. So we don't need a label. Labels could be something that project managers have for like a specific thing. Maybe there could be like a label bug that we can create just to show it is a bug so you can easily search it. Also, sometimes you would have tags like this. Let's say if issue happens only on iOS, you can have tags like this for ease of readability, saying, okay, I know where it's actually happening. But we don't we're not going to put it here. Okay, and let's create it. Okay, so here it is, was added to the backlog. It's not assigned to anyone. Um, it opened with to do. Then it can go in progress means in this particular setup for Jira in this board, it goes in progress, means developers working on it. Then it's in QA, you verify it was fixed. If you successfully verified the fix was implemented properly, the issue is resolved, and you're going to move it to done, and that's it. It's going to get closed. Okay, so yeah, this is it. We're getting closer to the next module. Hopefully you enjoyed the video. Leave a like if you did. Subscribe for more. All the links for this will be in the description for the video. Thanks everyone for watching, and bye-bye. Hello everyone, this is Alex USA Days, and we're continuing with Learn Quality Assurance from Scratch playlist. So today we're going to talk about managing test cases and QA documentation. We're right now at module 5. So after that, we will have module 6 with basic console commands and then Git introduction, slowly getting into more complex stuff, but we almost done with the theory. Okay. So what are checklists and what are test cases? Those are pretty much two main ways of how to run tests, how to structurize your test and create your tests properly. I would say checklist is more high level, but also is pretty efficient way of running coverage and making sure that your application works as expected. So essentially, checklist is a high level test document. Checklist should include a modularized list of expected verifications. Test list should include what needs to be tested, expected outcomes, results of verification, and checklists can be composed out of end-to-end flows for specific features. So, for example, if you're trying to verify if your application still works after an update, you can create a checklist that go through main functionality like end-to-end. So let's say you're working on some web page that is e-commerce and you can shop online. So you'll create a flow where you log in, you do search for certain items, maybe in different categories. You add them to cart, then you select payment method, address for delivery, and check out and get a confirmation email. So, and you'll have like a multiple flows where you verify that functionality that has to be there is still there and works as expected. So, a little bit more detailed than checklist is a test case, right? So test case is a set of steps to verify correct functionality of an application. It may have preconditions, test data, test case ID, test case description, test steps, expected results, pass, fail, and visual examples, right? So test cases are more detailed. So essentially, it's instructions on how to execute something step by step, with description of what results you want to get as a whole action goes through, what should be the end goal, what you should see by the end of execution of the test case, right? It is helpful to start working on feature verification by creating checklists first around core features or modules and then expanding this checklist to test cases. So you can create a checklist when you start working on an application if there's no test documentation. Talk to product managers saying, hey, let's talk about the core functionalities and modules. Let's create checklist what we should look for, like what should be verified. And once you have the checklist, you can start working on expanding this checklist and filling it with test cases. And you can track test cases and manage them in test matrix. So I'm going to give you an example of test matrix right now. So here's an example of test matrix that I created at some point. So you can use this to create your own, follow the example. Essentially, there is a high level for this test matrix where you have number of test cases executed, the date they were executed, pass, fail, some comments, overall just general high level upon all execution, right? You will also can add some KPIs here. So how many tests were covered, how many tests are automated, how many tests are failed. You can figure out what kind of metrics you want to track if you want to. Then there's a master spreadsheet, and within master spreadsheet, you will have all the test cases that you will be running through, and you can update the master spreadsheet and then copy paste it with a new date and run it, maybe for a new sprint or however you want to run it, right? So here, for example, we have a test link, and there's this for main section. So here's our module right here, main section. Then there is what test case title, what we're doing here. So we're recording uh, and trying to upload an invalid file, right? So there's test case ID, priority for this test case. So P0 is the highest priority. Then here's the test description. So verify invalid audio file upload failed was error message. Then there's steps to reproduce. So we open the audio block, we select upload an audio file, and then we upload a valid test data file. There is some test data which is attached in a separate tab here, which is an invalid audio file. And the expected result for this test case, it should throw error message. Please choose valid file type, right? Time for execution is around 3 minutes manually, so you can kind of start collecting data, how long it's going to take you to run the whole end-to-end regression spreadsheet, right? or overall just any set of test metrics and set of test cases, how it's going to take to execute and what can be and should be automated, right? Status, and then story, test link, some comments. So this is my layout. You can edit it, you can update it, you can create your own based on this. And then here is an example where the master spreadsheet was copied and this was actually run like yesterday, right? So the same thing here, everything the same except there is status with a bug. So it's red, it means it failed. There's a bug ID straight away that's going to take you to Jira, and some comments saying that invalid file was uploaded and there was no error message displayed. So the system should have recognized this file that you're trying to upload is actually not an audio file, some other file, and should have thrown an error, but it never did this. And here's some test data. So you can have a link where this invalid file is stored, test case ID associated with this test data. So this is one of the easiest and uh, efficient ways of managing test cases for free. You just create a spreadsheet and start creating matrix, right? Adding test cases to the master spreadsheet, copying it, and then running on specific dates or whenever the execution needs to happen, filling out what is passed, failed, opening bugs if needed, right? After you have have a checklist, or you create a test case and put them in test matrix, you have to have some other place where you can manage documentation, right? Where you're going to link to them, where you're going to store all the relevant information. And for managing test documentation, normally you will have some sort of documentation space. So it could be Confluence if you're working in Jira, it's very popular, or any other team documentation tool. So usually QA will have its own space, right? Where QA engineers will store test plans, information for new QA engineers on how to get started, bug templates, a bug life cycle, diagrams on test flow, and list of tools used. One of the popular tools is Confluence, but it can be anything, even shared QA Google Drive. So it can be just a folder with set of files. Every place is different how they manage things, so it's going to vary greatly from place to place. But I do recommend having some knowledge base where you can go and figure out things and put some references on where to go to find things and so on. So it's going to be helpful for seasoned QA engineers because if something gets forgotten, there's a quick reference for that. And it's going to be helpful for new hires, new QA engineers, because they always will have a place where they can go and read upon before they start asking questions or Googling for answers. Okay. And at some point your company even might spend some money, or you maybe already have that, but you'll have some sort of a test management tool aside of a test matrix, right? So that could be test rail, test lodge, or any other test management tool. So instead of test matrices, companies might have dedicated test management tools where Q engineers can add test cases, create test runs, and link them to specific stories in Jira or in other project management tools. Test lodge, or you can check out and download for free also TestRail. They're pretty similar. I'm just going to show you Test Lodge, but the idea is the same with TestRail and Test Lodge. So you have a project that you create, right? Let's take a look what I have here. So I am a member of one project I just created today, test project. Okay, so within this test project, we have some overview, some test plans, some requirements, test suites, and test runs, and so on. So go into test plan section. You can add a new test plan here, and I just added one, and I named it test all things, right? This test plan can be specific on what data you're trying to test, what you will be verifying, what kind of parts of application, or is it specific functionality you're testing here? So let's go into the test plan. Now, under the test plan, we have some suggestions that can go into the test plan, like introduction, test items, features to be tested, features not to be tested, approach, pass-fail criteria, suspension criteria, test deliverables, test and task, environmental needs. All of those points, they were added automatically, so I didn't add any of that. It just suggests you how you can structure your test plan efficiently. Now, within the test plan, we have associated test suites, so we can view the test suites. And I just created the test suite called Verify Login. Before we actually go there, let's take a look. There's also requirements, and then I created a requirement document, and I just named it all things have to pass. But within the requirements, there are going to be more specifications, how things should be executed, right? What are the acceptance criteria? And this is linked to the requirements itself, actually not linked to anything. So there's really no requirements. I didn't add anything. So, but there is a place for storing them here in test management system. And then there are test suites and test suites. So this test plan is actually associated with a test suite. And within test suite, you will have a set of test cases that you're going to run. So I just created 2 test cases. Simple example with login, but let's take a look. So called verified login, this test suite is called. And I have 2 test cases here. So you see the ID automatically assigned, test case 01, test case 02. So one test case is valid username and password. And here's our test case. So first step, we go to this page, open it up, following through steps. Okay, so we're on the page. Then step 2, enter Tom Smith for the username. Here's username, we enter Tom Smith. Then enter super secret password for the password. So we enter password here. And then step 4, click login. We click login. And we should see this secure area message. And expected results should take user to this page. So .com secure, and we're here. Okay, you can add screenshots, what actually is expected outcome. You can add more details and what you want to see here. So, but that's our test case 1, right? Then there's a test case 2 and the invalid login. So essentially, we go in through the same steps, but instead of valid password, we actually provide invalid for the password. So put an invalid, log in, and we should see your password is invalid. Expected result, your password is invalid. Error message should be displayed. Okay, perfect. So now we have those test suites under the test plan and then test runs. So you can start new test run. Let's add test run 2. So test all things test plan selected. Okay, let's add some test cases. So we're going to add this test suite. Both test cases are added. Close it. Okay. And all right, let's add it. So we have 2 test cases that are not were not run yet. So let's start it. Run all tests. So let's say test case 1 passes, and you can attach test pass. You can attach screenshots confirming it actually passed. You can mark it that it passed. And okay, so this was test case 1, and then test case 2, test case failed, right? And you can attach a video or failed screenshot, whatever, of the test case actually failing. And then based on the failed test case, you can link this with automatically with a story associated with this test case, or create a bug in Jira and then associate it with this run and saying it's failed. Okay, so and this is pretty much like a high level, or not high level, like a more complex way of managing test cases that allows you to create test plans, add test cases, rerun them on demand, mark what's pass and fail, add logs. And this is essentially your proof of execution, right? So if there are any questions, was everything executed properly, why issue were not found, or how many issues were found, you can refer to this and share the data on what was executed, what passed, and what failed. Okay. So yeah, this is in a nutshell what we have here on managing test cases and QA documentation. So hopefully this was helpful. Check out the playlist for more videos on the topic on how to become QA engineer. This was Alex USA Days. Thanks for watching, and bye-bye. Hey everyone, this is Alex USA Days, and we're continuing to learn quality assurance from scratch. So today we're going to talk about basic console commands. Right now we are in Module 6, basic console commands. Uh, we This module will have two parts. We will talk about Windows commands in the first part today, and in the second part, next video, we'll talk about Linux commands. Why we need to be able to work in the console, right? So as a QA engineer, many times you will work in the systems that have no graphical user interface. So unlike Windows or MacBook, all you're gonna have in front of you is like a terminal. In that terminal, you'll have to gather logs, you'll have to navigate, you'll have to maybe configure network. So it's very important you at least get familiar with them, right? Uh, Over here on this visual presentation, we can see how the systems evolved. And you see from Unix, a lot of the modern systems coming from Unix. So the commands, basic commands in those systems that are coming from Unix, going to be very similar, and some of them going to be the same. So if you're using MacBook and you open Terminal, and you start typing some commands in your Mac system, and then you open Ubuntu or Fedora or Android and start typing those commands in those systems, they're going to be very similar or the same, right? A lot of the manufacturers use their own limited versions of a Linux or Unix on their system to run their devices. So, for example, if you have a modem or router at home, if you have some GUI, sure, you can log into the GUI as a user, but the configurations there are limited. So, but the actual system itself probably is running on some sort of a Linux system where if you have access to the console, you can gather logs, you can maybe have admin privileges to configure your device differently, and so on. Um, for Windows devices, we have different commands because Windows did not start from Unix. It started from MS-DOS systems, and a lot of commands that were in MS-DOS kind of carried on, new were added. So if you work in a Windows system, you'll have a different set of commands. Now, maybe Windows is not often used for like embedded systems, but still, as a QA engineer, many times you will be building test beds, or like you will be setting up different test equipment, and it's quite common that you will have Windows machine to managing those, or like your main access machine where you will have access from that machine to other devices on that test bed. So even though you might not have as many embedded devices with Windows, right, or any implementation of it, it's mostly Linux, but still Windows is still popular for like a management machine management system. Plus, if you work like with Windows servers, right? Okay, so here we have the history of it. You can study it and look at it, pause the video, just kind of see how it branched out and developed. Now, here we have a list of commands for Windows console that we're going to practice. Only 9 of them. There's really not a lot for like basic starter for Q engineer. And you have some links on your screen. So the first link is the page where we're going to practice. You can load an actual Windows system in your Chrome browser. You don't have to install anything if you're on Mac. You don't need like a virtual machine. So we're going to practice in your browser. So you can do that. You can go through that link. One thing though was the link. Um, it's a little bit slow on loading, so it will take some time. Mine is already preloaded, but I will show you that it actually takes some time when you load it from for the first time from the very start. So don't worry about it. It's taking time. It's fine. And then there's also a link to GitHub where you have like a list of commands. Almost all of the commands, a lot more than I have here on the screen. You can go there and practice them as well, or just kind of get yourself familiar with. And if at some point you start working in the command prompt on Windows and you need to look up some commands, that's going to be a good place where you can just go to and refer to commands that you need to. Okay, so here is this link. it's available in the description for GS Linux. So over here, we already loaded Windows 2000. Now, if you go to this link, you'll have a list of virtual interfaces, user interface. So if you click on Windows 2000, start loading it, you'll see it's booting. You'll have a whole Windows system in front of you loading. I'm not going to wait because again, it will take a little bit of time. Here, I have one that is already loaded. So in order to get to your command prompt, you can just go to run, or on the modern system in your search, you can type CMD and it will show as a command prompt. Some of the commands might require to have an admin privilege, so you'll have to run it as admin. If you right click, it doesn't show here, but let's see. If you own like Windows machine, a newer Windows 10, and you type in search CMD, you can right click it and then there will be like run as an administrator, but this is not necessary. So you can also run it as a user, not as administrator. Okay, so here we are. So let's take a look at the list of the commands here. So let's start with ipconfig. So this is very first command. It is different in Linux. It's ifconfig in Linux system, but if you're in Windows, you can do ipconfig. And what it will do, it will list all of the networking devices that you have, their IP address, subnet mask. Um, you can do also ipconfig all to have like a complete information. So this will also give like physical address. If you don't really understand what it is right now, don't worry about it. But just remember that IP address is an address how you can reach a system when you connect something. Uh, when you communicate with a system, if it has an IP address, it's on the network. That means you can actually talk to that, right? To that system. So, for example, here we don't actually have anything connected to it, but I can issue ping command, the number 3. So if you have multiple devices connected, you can verify that they're actually online and they can talk to one another by issuing this ping command and providing the IP address of the device that you're trying to connect. So we can do ping, and in this case, I'm going to pin myself, essentially the same machine. So this is IP address, so 10.5.65.141. So if I'll do 10.5.65.141 and I'll issue ping, and now I can see that it is replying even though I'm talking. The machine is talking to itself. You can see it's actually connected, and if there was multiple machines and they will be on the same network, they have same configuration, they're under the same subnet mask, they'll be able to talk to one another. Like the IP also has to be unique on the network. You can't have two same IP addresses on the same network on the same subnet, because otherwise they won't be able to communicate. There will be conflict of the address there, right? Okay, so I can ping. Another command that I have here is netstat, the second one. So let's try that. Netstat. All right. So we can see there are really no active connections or anything like that. But what netstat does, it displays all open network connection and listening ports. So if you have some ports open and they're listening for connectivity and something is actually connected, you can do netstat and it will show a list of things that are connected. The other command is CD. So CD is essentially how you can navigate around, the same way how you go into a folder and move around. Like you can go into My Documents, and then navigate to another folder within My Documents. You can do the same thing with a CD command. So let's see if we can grab this address here. Can we grab this address? It is convenient in Windows 10 if you just click on the address, you can actually copy the path and go there, but we can't do that. So let's start with dir. So dir command number 6, it will show content of folder that you're currently working in. So by doing dir, we can actually see uh, where we at. So we're in the C drive, and by doing dir, we can see what we got here. So let's say we're gonna go from the root of the C drive into documents and settings. So let's do cd, and then you start typing. You can start just typing do and press tab. Okay, probably not in this console. Okay, documents. On a more modern system, you can just press tab, and it's actually gonna fill the remaining part of the command for you if that directory exists. Okay, now you can see now we're moved from root directory from the C. Now we're in C documents and settings. So actually, by using cd command, we're navigated within this folder. So where I am right now, so if you take a look here, local disk C. So here's documents and settings. So essentially by issuing the cd command and the name of the folder I navigated was in here, right? So let's do dir. And we can see here that we have multiple folders. So all users test one, all users test one. There's a default user that's hidden. Okay, so now we navigate inside. If we do cd dot dot, we actually gonna go back and we navigated back from where we came from. So now we're back into the root. And if you move up and down your arrows, you can see the command line saves history. So you can actually go and reuse the commands that you issued before. So let's go inside documents and settings again. Okay, so we're here. The next command that we're gonna look at is okay, let's do system info and display Windows system information. System info. System info. Okay, so looks like this Windows 2000 doesn't have system info. Or yeah, I don't think it does. But if you're on Windows 10 and if you go in your command terminal, command prompt, and you issue system info, it will show you all the information about your system. So like the name of your machine, your operating system version. It will show your processor information. I mean, like if you're working on Windows-based machine and you need to get some environment information about the system. Let's say you're testing different drivers or you're testing different video cards with a specific like motherboard and processor combination. If you want to get this information out, you can just issue system info and it will display everything for you. Not on this Windows because it's a little bit outdated, right? Okay, what else? Let's take a look. So here is how we can create file with specific text. So we can issue echo command, then type text that we want, then point and like an arrow and then file name.txt or whatever file name we want to have. So let's try that one out. Echo test, let's say test and then test file.txt. Run this command. Now you see this test file appeared right here. So when you need to gather a log and you want to pass some information inside of it, you can do this. And if we open it up, we actually see the word test inside. Okay. If you want to read the information within the file, you can do this command, more and then file name. So let's do more test underscore file.txt. Okay, and it prints out what is inside the file. So if you need to get some logs out and or find some information within the text file without a graphical user interface, you can do more test underscore file or more file name, right? And the last one is delete. So delete and the file name. So let's do del and test underscore file.txt. Okay, and now if we're going to do there, we will see that file is actually gone. Yep, was deleted. All right. You can issue help, and help will give you a list of commands that are available for this specific system. So, and again, there is this link for GitHub, where there's a great variety of additional commands that you can just kind of go through and practice for yourself. Just be careful, like don't read what the command does so you don't mess up your system. Or if you're going to practice, you can practice just here in GS Linux, so you don't mess up your actual Windows machine. Right. Thanks everyone for watching. This was Alex USA Days, and in the second part of this video, we will talk about Linux commands. Hey everyone, this is Alex USA Days, and we're continuing to learn quality assurance from scratch. So today we're going to talk about Linux commands. Right now we're in a basic console commands section. We already finished Windows commands. Today we're going to talk about Linux commands, and I will do very brief intro into the networking. Also, a quick announcement. I actually created a Patreon page because some people asked me about that. I will have now link in description if you would like to support this channel, if you would like to support this effort. I would really appreciate that. So let's get into today's topic. So we're going to talk about all those commands. We're going to practice them hands-on, and I will also provide a link into the description to an actual a list of commands and materials that we talked about today. So you have them handy. Why do you need to know Linux commands, right? Many times as a Q engineer, you're going to work on devices and the environments that do not run on Windows. They will have their own version of Linux built in on the embedded device, like, for example, your modems or routers. Behind the scenes of the graphical user interface, there is some system that's running the whole thing. As QA engineer, many times you'll have to access it, config it, grab logs, maybe do some IP address configuration, stuff like that. So it's important to know at least some basics of it, understand it, and if you're faced with that when you work, you can actually go ahead and Google and search for something and understand how to navigate in a console. Because those environments, they don't have, might not have graphical user interface as you used to in Windows, right? So you'll be in the terminal navigating folders, creating files, grabbing logs, and so on. So let's go briefly through the commands. PWD. This one will display the current working directory. And we will go through them also in the console in practice after the introduction. Make dir, so, and then name of directory. This will create a new directory in Linux. CD. This will allow to change to a directory or get out of the directory. Touch will allow to create new file. ls will list the content of a directory. lsa will list everything including hidden files. Cat, that will display the content of a file. vi is an editor. Using vi you can actually get into the file and update file content, and we'll do that. Grep will search for a pattern in a file. I'll show you how to do that. Tail, display the last few lines of a file. So if a long file you want to kind of read what is it all about, like get the last of it, you can use tail command with a file name. CP will copy a file, so you can copy one file into another, or create a new file as a copy of a previous. Diff will compare two files and show the difference between file 1 and file 2. Um, Here's my address for the Patreon created, Alex USA Days. And this is the page link to actual system that will bring up the Linux system. You don't have to install anything. We just go to this web page and we'll open a console. We'll have a Linux running in the browser. RM. This is a command that will remove files. So you put RM file name. Chmod. This is to change file permissions. So sometimes you want only certain access to a file, so you can do that by changing file permission. Or sometimes you're trying to access a file and you can't, or you can't execute the file, and that means maybe you have lack of permission, so you'll have to update the permission in order to be able to do that. Find all files with a certain extension and directory and subdirectory. So essentially, it's like a search command. Ifconfig, this will display network interface information, and using this command, you can also configure your network interfaces. Ping, this will test network connectivity. So when you connect a couple devices and you want to make sure that they can communicate, you will use ping with the IP address to make sure there's communication happening. Netstat, so this will display network connections, routing table, and interface statistics. Netstat-A. There's an extra command that I'm going to show you how it works if you need to kill process and you don't want to go through searching of the process ID. Let's say something hangs or you need to, something's, you don't want to remove your system, but there's some process that maybe taking the port or something's not running, you need to restart it. First, you'll have to stop the process. So this command, kill-9, will actually kill the process, but it's expecting the process ID. And in order to get this process ID, you can run this little script right here. So ps aux will get list of all processes running. Then you have this pipe. That means the result of this command is passed along through this pipe into the next command. Then grab my process name. So essentially, you will provide name of the process, and it will grab it out of all the list of processes. Then again, using pipe, it's going to pass it along to awk print $2. So this will grab the ID. This means it's going to be second column, and the second column will be ID for the process, and it will grab it and pass it along back to the kill command, essentially saying, hey, this is the ID of the process based on the process name. Please stop it. Here's the link for the document with the list of the commands. Again, will be available in the video description. And the last page is networking introduction. So when you work with devices, you most likely will have to configure the IP address to connect them so they can communicate, right? There's something called MAC address, and MAC address is a unique physical address assigned to a network interface or a device. If you ever worked at home and maybe your router was not working or modem, you could talk to tech support. They would ask you to provide MAC address that will be written on the box. That's like a physical address of that device, right? On top of MAC address, there's IP address, and IP address is a unique identifier assigned to a device on the network. So one device on the network has to have an IP address so other devices can talk to it. An IP address consists of 4 numbers separated by periods, which with each number ranging from 0 to 255, for example, 192.168.1.100. And then there's netmask. Netmask is essentially your network configuration. Devices with the same netmask are considered to be on the same network, while the devices with different netmask are on different networks. That's important. So if you will be setting up some sort of a test network and you want your devices to communicate, you want to make sure first that they are on the same network, on the same subnet, same netmask, right? And that they all have different IP addresses. Otherwise, there will be conflict. There are different types of netmasks. There's Class A, Class B, and Class C. For the test settings, most likely you're going to use Class C, so 255, 255, 255, 0. This 0 is determining the last 3 numbers here that are responding for the address of the device. That means that Class C network will have fewer than 254 hosts or fewer than 254 devices, right? So first one starts with 0 and then the next 254 devices. You don't need Class B and Class A if you have a small test network. Class C is enough, okay? That means you will have your IP addresses from 192.168.1.0 to 192.168.1.254, right? So there's essentially no need to add more devices if you're testing only 3 or 5 of 6. You don't really need to any other netmask classes. Okay, so let's go to our console right here. This is the web page. We're going to use Fedora right here, and we only need console, so we're going to click on this. You can follow along or just rewatch it, kind of practice on your own using the document. And it's loading. The console normally loads faster than a whole Windows system. That was in previous video, so let's expand this. All right, so, yeah, it's already loaded. Okay, so let's start with our Linux commands. So the first one we did is pwd. This is displaying the current directory. Now we want to make a directory where we're going to work and create like test files and stuff. So we'll make there and the name of the directory. So let's call it test directory. Okay. Next command, we want to change into that directory. So cd, name of the directory that we just created. And if you hit tab once you're typing, it's going to autocomplete for you. Now you can see we actually moved into this directory. So if we'll do pwd, before we were in the root directory. Now if we'll run this, you can see we're actually root and then in the test directory. Next command is touch. Or we can create a file using touch command. So let's name this test.txt. We created just a test file, and let's do ls. ls will show us the content of this directory, and now we see the test file exists. It is empty, so if we do cat on the file, we'll see there's no response. So let's use vi editor, vi, name of the file, and now we're going to open the file. In the file, press A. So A, you can start inserting text. So this is test. Let's do this is test file. Enter to get to the new line. I'm going to put banana here, and then enter Alex USA Days. Has Patreon now. Okay, cool. So if you hit shift and hold it and then press Z twice while you do that, it's going to save it and exit. Shift. You have to press escape first. So you quit insert and now do shift ZZ. Now it saved it and exited. All right. Now, once we did this, we can verify with cat command that actually now there's content, right? And you see all this stuff was added. We can also do clear to clear the console. And if you now move your arrows up and down, you can see you can go through the list of the previous commands, which is very helpful if you need to rerun stuff. All right, so using grep, we can search for stuff. So grep, then let's say we're going to search for banana that we added, and then name of the file, test.txt, and it found it. If we're going to search for another word, let's say test, you see it returns the whole line. So essentially, the whole line of content where the match is found will be returned. This is helpful when you gather some logs and has tons of data and you need to retrieve logs specific to some date or something. You can search using grep and just get this out of the file. If you want to look into last 10 lines, few lines of a file, just to make sure like this is the file you're looking at, you can use tail. So tail and name of the file. Here we display everything because we have really small files, so not a lot of text, but it just returned everything we got inside. Let's do another clear, so we have a clean console. Now, if you want to copy a file, you can do cp, the name of your file, and the new the file name that you want. So let's do test2.txt. So we're copying content of test.txt into test2.txt. Let's do that. And let's update test2.txt using vi. Get into the file. Let's do, instead of banana here, let's do pineapple. All right. So let's save this. So escaped, shift ZZ, we exited and saved it. If we do ls, now we see we have two files. We have test file and test2 file that we created. That's great. Now, let's say we want to know what's difference in two files. We can do diff and then files that we're trying to compare. And we can see that second line banana in the first file and then pineapple in the second. So there's differences showing to us, right? If you want to remove file, you can just do rm and file name. So that's going to delete it. So we're going to delete the second file that we created, do ls again, and only one test remains. Now, if you want to update access of a file, you can do chmod, name of the file, permissions, and then name of the file. I have a link in the document on permissions. So essentially 777 would be read, write, and execute available to everyone. So if you need some file that everyone can access, you can do that. But normally you want to consult with your IT department if there's some files that you want to provide access, kind of permissions you want to set, then name of the file, and the permissions updated. If you want to, for example, have permissions where file cannot be accessed by anyone, can be executed, only read, you can't edit it. So 600. This gonna do only the owner of the file will have full read and write access. No one else will have to be able to do anything with it. Normally, the most common set of permissions you will see is 755. Again, about permissions, I have a very good article in the document I'll be sharing in the description. You can go and read about it. All right, let's clear console. If you need to find something, you can use find command. So you can use find. Let's get our directory here, pwd. So find root test directory. So you need to provide where you're searching. And then let's say name, and we want to find a specific pattern. So we want every file that ends with .txt. So you put star, that means everything, and then the pattern here, .txt. If I'll do search like that, get back all of the files that match in this .txt pattern. Every file that ends with .txt will be returned, and we got it back. Sometimes you'll have tons of files, you need to do search in it. There's also a way to do search with grep, and a lot more efficient way. So I guess easier way to implement. Also, I'll have a link for that, how you can use grep to search for files. And this is coming from Stack Overflow. Stack Overflow going to be one of your best friends when you need to, you have answers. You will always have questions like you're trying to figure something out. You can't remember everything all the time. So you're not using Linux every day. You maybe after a couple of months you get back to Linux, you have to grab some stuff. You'll have to Google for things. So Stack Overflow will be your friend. You can do grep -ril and then the text you want to find. So let's say test. We're looking for test. And then where you want to start the search from. So this is going to mean that's going to start from the root. So the very top. All right, so this did not work. How about root? Here we go. And it found a file that contains word test, right? So let's do test.txt. Let's say, is it going to find banana? right? So we want to find a file that has word banana, and it finds it and returns. So there's different ways how you can achieve things in tech, in different languages and different systems. You don't have to know of them. Again, you'll be doing Googling a lot, but just something like quick. I'm trying to show you that something you can use. Now we're getting into kind of networking stuff. So if we do if config, we will see the list of interfaces, and here we have our interface ETH0. So it's actually like the networking card, right? There is our IP address, and here's netmask address. If we do if config -a, it will give us more details. Show all interfaces. This is like local, your address that is not configured like your home address. Let's pin. Let's see if we can reach. I'm not sure if this machine connected to the internet, probably not, but let's see if we can ping a domain name, google.com. Okay. Address family is not supported by protocol. Okay, so and actually we are connected to the internet. You see, Google is now responding. So it was able to find this domain name, and then here's the IP address. It's coming back. So we are connected. That's awesome. If you do, if you want to do netstat, it will display network connections, routing table, and interface statistics. If you do -8, it will provide more information. Um, you might need some of those commands, like if you will start working and again building like your own testbed connectivity. One thing that I wanted to show was if config, you not only can view interfaces, but you can actually configure interface. So let's do if config ATH1 and see if it will be able to create an interface. Okay, device not found. So if we do maybe like a virtual ATH0 one, and it created and like a virtual interface based on this one, right? Now if we do if config, can we see it? It doesn't show. Okay, that's fine. So let's do maybe reconfigure ETH0 and give it a different IP address. 168.1.1 and update the net mask. And you can see the IP address was updated and the net mask was updated. So I just want to show that using ETH command, if config and name of the if config command and the name of the your networking card, right? You can update IP address, netmask. You can, this way you can, if it's connected to a certain network, you can update the netmask and IP address and actually start communicating within that network if it's different from the network you're connecting to. And let's do list all processes. PS aux. PS. So this way we can do the extra command that finds and kill process based on the name. We're just gonna find a process that we want to kill. So here is second column. You see there's a process ID. All right, let's kill crypto. I'm not sure what it is. Let's kill PID 12. The name. Maybe. Okay, that's fine. So see if we can kill crypto. So kill -9 $sign PS aux. So this is the same command that we just issued. It's going to display this table, right? And we put a pipe. grep, name of the process. So let's kill DHCPCD. So you actually, by killing some processes, you can like crash the system. Oh, again, kill 9 -9 $, PS grep name of the process. So DHCPCD. Another pipe here, AWK. And now we need to say grab the process from the second line from here. So print $2 and then close this. All right, execute it. 185, no such process. So I didn't find the process. Let's remove this. Quotes, run again. 189. No such process. So process wasn't found. I wonder why. It's actually killed it. So I guess it killed it and then returned that there's no such process. That actually indicated the process was killed. You see that it was running here. And once we do PS hooks again, it's not here. Okay, so hopefully this intro helps. Hopefully you found this educational. Again, you don't have to remember all of the commands, right? You don't have to know all of this stuff. What you want to do, you want to practice the commands a little bit in the console. You want to get familiar with them. And maybe you want to read about networking a little bit. You just want to have general knowledge. Once you start working, if this is something that you will need, you will be able to pick up quickly. If not, that's good. You can always come back to it once it's needed. Okay. This covers like a broad spectrum of different generic QA knowledge that you need to start working as a QA engineer. It doesn't mean you will use it. What you will do at work will greatly depend on the product that you're testing, because most times QA is about understanding the product and understanding acceptance criteria, business requirements of the product, and making sure that this product behaves as it's supposed to. So QA in a way serves like a gap between development and product management, where you are the one who is responsible to making sure that, okay, whatever software is coming out is doing what it's supposed to do. The tools, the technologies, the languages, or how you're going to test it, that's going to greatly depend on the product, on the stack, right? So you can't learn everything, but you have to be familiar with some concepts. Okay. All right. This was Alex USA Days. Thanks for watching, and bye bye. Today we will have video on Git introduction. So we already covered quite a lot. So we're halfway through. We're at module number 7. Before that, we had basic console commands, some Linux and Windows commands. Next module, we will have SQL introduction, but today we're working on Git. So what is Git? Git is a distributed version control system designed to help developers track changes to their code over time. With help of Git, teams can manage and track changes in code, have efficient collaboration, version control, and conflict resolution. Git is installed on a local machine. So, in short, Git is used to track changes and manage code. Git provides several features that make it powerful and flexible, including So collaboration. Git allows team members on the same code to work on the same code base. It is used almost everywhere, so you will have to work with it at some point. So it's important to understand the tool. If you're going to tech, you, even as a Q engineer, will have to deal with Git at some point. Uh, Git provides version control. So Git track changes, and if something breaks really bad, you can revert and don't have to wait for a fix. You can actually immediately go back to the previous version and to fix your build. Traceability. Git provides a detailed history of changes made. Branching and merging. So Git allows to work in parallel without affecting the main code base. So multiple developers can work in parallel on the same product. There are some visual tools for Git that will use GUI or UI, like source tree. I'll have those tools in the description so you can check them out, but I suggest you learn just the console commands first to understand what you're dealing with, and then get to the UI tools for Git. A link to get Git is git-scm.com. It has both installation instruction for Windows and for Mac on the web page. Now, there's another tool called GitHub. Git and GitHub are related but different tools. So Git is installed on your local machine. GitHub is a web-based platform that provides hosting for Git repositories and additional collaboration features. Many developers use both Git and GitHub together to manage their code and collaborate with others on their projects. Here's the page for the GitHub, also will be available in the description. So github.com. In short, GitHub is a website to store projects so others can also work on them. There are other platforms that allow hosting Git repositories and work on them with a team, GitLab, Bitbucket, SourceForge, etc. All of them, they're very similar. So once you learn how to work with GitHub, you will get familiar with others really fast if needed. Okay, so there are a couple ways we can start working with Git. One way is to actually initialize Git on your local machine with git init command. So you'll go to a folder, open console, type git init, and then it will create .git hidden folder where all the git config will be initialized and stored. The other way is to actually create a repository on GitHub first, and that's the way we're going to use, and then clone that remote repository to your machine. So then it will actually add this repository to your folder on your local machine to specified location, and also will add .git hidden folder with all the configs. The typical flow when you work with Git are in these commands. So first you do git pull, and this will get the latest files from remote repository to your local repository. Then you will work on the code, add some changes, and all of those will be untracked in the files folder. So those changes are not tracked by Git yet. Then you will do git add. This will add the changes from the untracked stage into a staging stage. So now they're ready actually to be moved further, right? Then you will do git commit with a message. Now the files that were staged will be now added to the head. So essentially to the latest committed version of your code. And then you issue command git push. That will push your changes to the remote repository. Now we will work through all steps, so you'll kind of get familiar with what's going on. It's going to be very hands-on. Now let's talk a little bit about branches. So branching helps to work on different features without interruption. So multiple developers can work on a project, have multiple branches. A command to create new branches to do git checkout. So you switch one branch, then -b, and then provide new branch name. This will immediately switch from your branch and switch you to the new branch that you create. In work environment, you will normally see a master's branch, or that will be like a stable branch with all the latest code that actually works. And you will see also a developers branch. So developers branch is going to be where developers work actively. Then out of those branches, mostly out of develop. There will be checkout of new branches where developers work on the feature, make sure that the feature work, and they will merge back into the main branch or the developer branch. So essentially, you'll have one branch that is stable with the latest code. Maybe you will have continuously like working branch that developers work all the time in that branch, like develop, and then out of that branch they will create like temporarily made branches to actually add some features. On this image here, you just see one branch, master branch. So developer checks out feature B, works on that branch, and then merges that branch back into the master once it's ready. And another developer at the same time check out feature A, work on that feature. Once the feature is done, they check it back in and merge it into the master branch. So this way, it's easy to keep your master branch up to date with all the latest changes without introducing any issues or bugs, possibly without introducing any issues or bugs. So what we will do now, here's our action plan. We will create a GitHub account together. We will create a repository in GitHub. Then we will install Git on a local machine. Then we will clone repository from GitHub to local Git. Then we will set up credentials for GitHub so you can actually update local repository and push it back. And then we will cover some basic commands, git flow. So let's get started. Go to github.com and click sign up. Then in the sign up window, provide the email address you're going to use for your GitHub account. Create password that you will use for that account. And create username for account. Okay, click continue. No updates, thanks. And okay, solve a puzzle that you're a human. Okay, once you prove that you're not a robot, click create account. It will send a code for your account created. Copy paste the code. Okay, perfect. So just me, continue. So here it is suggesting some features. I'm not gonna actually pick here anything, but if you find something that you like, you can check mark it and choose it. Just continue. I'm gonna use the free version. No need for the paid version for this. Okay, and here we are starting with GitHub. All right, perfect. So let's create a repository. Let's create a public repository. So Alex USA Days is the account name. Let's name our repository test, or let's do learn Git, or let's do learn Git. Learn Git repository. Create repository. Repository is created. So you can save it into the desktop, or you can use HTTP link to clone it. We're going to use that. So let's keep this link around. So we're not going anywhere right now. And go to the page where you can actually install Git on your local machine. So git-scm.com. If you're on Windows, you can just do download for Windows. If you're on Mac, there's some additional instructions. I suggest you install with the Homebrew. So you have to have Homebrew installed. So first step for you will be to go to this web page, copy this link, issue it in your terminal. This will install Homebrew, possibly asking for your password. Then go to this page and issue brew install git in your terminal, and then that should install Git, and now you can use it on Mac. For Windows, you just hit download for Windows over here, and at the top you will have the latest version. So download for Windows, it will recognize what system you have. Click here to download, and just let's download it and then install it. Okay, so here's an installation window. It will ask a lot of questions, but most of them are just going to be default. Not going to really choose and update many things here. Okay, installation started. All right, so I don't want release notes. Let's get git bash, launch it, and it is now installed. For all the options, I recommend just use the default options if you're using it for the first time. The whole idea is to get to this window as soon as possible. Okay, so now we are here in Git bash. This is actually a terminal where you can start issuing Git commands and work with Git commands. So let's do this. We will go to the repository that was created on GitHub and grab this HTTPS link. So we can just copy it right here, go back to the terminal and do git clone paste. Okay, here we go. So we will do git clone, and we're cloned an empty repository. So there was actually nothing within this repository. So there was no README file, nothing, but we're going to work in that one. Perfect. Now let's do ls. Here is our learn git. So we can actually move inside that. So let's do cd learn git, do another ls. And now we are inside of the repository. Let's clear out the console. Okay, so what are we going to do? You can see there's some commands that are given here, but we don't need to do that because we already cloned it. What we need to do now is to set up an access token. Otherwise, if we will add any changes, we're not going to be able to actually push it back to GitHub. So for example, I'm going to create a file here. So the command for that, touch, let's do text.txt. So I just created a file. Let's do ls. We can see the file was created. And let's do vi text.txt to open editor and add some information. Inside the text, let's press A, so we can now insert new text. This is new file. So I just type some text out, press escape, and then press Shift and Z twice to save it and exit the editor. Okay, so now if we'll do cat txt, text.txt, we will see that this was added, the text that we just added. So now if we will do git status. Okay, so we're right here. So this text file is just in the repository, but so we're right here. For the typical Git flow, we're at step 2. So some changes were added to the code and the file is untracked. You can see it's in red. Okay. So next thing that we're going to do here is we're going to stage it. So to stage it, we can do a git add space dot, and this will stage every file that is untracked. But sometimes you don't want to do that because maybe some files, are not ready. So you want to stage, let's say, only file that you worked on. So you can just type the file name text.txt. Now, if we will do git status, we will see now it's in green. So what does it mean that it's in green? That means it was added to the staging, and from here we can actually commit this file. So let's commit it. Git add, git commit -m, and we need a commit message. So added new text file. So this message will go with the actual commit. So you can take a look at the message and understand what you were trying to achieve with this. Okay, let's commit it. The new file was added to the main repository because we only have one, to the main branch because we have only one branch. So git branch, and you will see if you'll do git branch command, we are on main. There's only one branch. And then we can do git push. So when we're doing git push, you see it says invalid username or password because we clone the repository using HTTPS method, but our GitHub repository doesn't actually have a token set up yet. So in order to do that, just go to your account on the right, go to your settings, and then go to developer settings. Now over here, you can give a personal access token, go to classic token, right? And when then just click generate new token. We're gonna generate classic token, and when generating token, just mark here at the repo so you have full control of your repository from your local branch. You can set an expiration in however many days you want. You can have no expiration even though it's not recommended. But I'm gonna set 7 days, and I'm gonna actually delete the key at once I'm done recording the video so no one else can use it. But just an example. I'm going to have it for 7 days. I'm not going to do any other privileges for this token, no other permissions, just to work with the repositories. And let's generate it. Okay, note, we have to leave a note. This is temp token. Okay, let's generate token. Copy the token over here. Now this token will be used for your configuration of the credentials with your local Git. So now it actually can push your work from the local machine to the GitHub. Okay, let's go here and let's try another Git push. The window is up. You can go and sign in with a token. Provide the token that you copied here, sign in. And now you see that we successfully pushed from local main to the remote main. Now, if we're going to go back to our repositories, so let's go your repositories. Here's our learn Git repository, and it says updated now. If we click on it, we see our commit message, added new text. We see the text message here. So let's say someone does some changes. I added some changes on GitHub, right? Or someone from another QA or developer worked on that, added some changes. Let's do git fetch to get updates if anything changed on the remote. So we just changed some updates. Now if we're gonna do git status, we will see that our local branch is behind origin main. Origin means that it's on GitHub by one commit. So we're behind. So in order to update our file, so let's do again ls, we see the text txt. If we do cat text txt, we will see this is a new file, so our change is not in. So in order to update this local file, we need to do a git pull. So normally this is how you're going to start working on the repository. You have to get the latest code on your local machine first, and then start working on it, or get the latest code, and then check out new branch, work in that branch, and then merge it back into the main branch. So we're going to pull. Now we're going to do cat text txt to see our file update. And now we see that this message, I added some changes, was added. Perfect. So let's take a look at our flow here. So we did git pull, we added some changes, we did git add, we did commit, we did git push. Perfect. And let's take a look at our action plan. So we created GitHub account, we created repository in GitHub, we installed Git on local machine, we cloned that repository from GitHub to local machine, we did the credential setup with the token, we updated local repository, pushed to GitHub, and actually we pulled update from GitHub to the local repository. Perfect. So there are some commands that we can use here, some commands that are basic commands that used often. So here's git status. Git status. So this command will tell you what's going on right now, and it says branch is up to date with the main. So git status looks good. Another command, so git push when you send your changes from the local branch to the remote branch. Then there's git pull, so when you get latest changes from the remote to your local repository. Git add space dot. So git command that adds all changes in the current directory and subdirectories to the staging area. So we actually use that for the file, right? Then there's git checkout to change branch. We don't have any other branches, but we can do git checkout -b and a branch name. This will create new branch and we'll switch to it. So let's do git checkout -b, and let's call this branch develop. Now you see the message came through with the we switched to new branch develop. Let's get git status. So we're on develop, and let's do ls. So we see the file is here. We actually grabbed the latest from the main and we checked out, and this is right now exactly the same as the main. But we can go and maybe add another file, touch. Let's do touch develop txt. Okay, clear the console, and let's update develop file, add some information. So let's do add some info, press A to start adding. You will see there's an insert at the bottom. So added some info, again escape. Now you can save and exit, press shift and press Z twice. So it will do that. And now if we're going to do ls, we will see there are actually two files. Okay, so now we have develop.txt and text.txt. Develop.txt exists only on branch develop. So if we'll do git branch -a, that will list all of the branches available. You can see that there's develop branch, local branch that we're currently on. There's main branch, and then there's remote's origin main. So what will happen if we will try to push, right? So we just did a checkout. Let's do first git status and see what do we have. Okay, so develop.txt is actually untracked. So we want to do a git add to put it to staging. So I'm gonna just add everything. Now let's commit it, git commit -m, add a new file, and then now look, git status. Okay, we're on develop, nothing commit, working tree is clean. Why is it saying clean? And we're not behind or some branch, or actually ahead of some branch, because there's no remote branch. There's no remote develop branch on GitHub. So if I'll do, now let's do git push. And you see it says current branch develop has no upstream branch. So that means we actually don't have a branch to send it to. And it gives us a command to create that remote branch in GitHub. So it says git push set upstream origin develop. If I'll go to GitHub now and look at my branches, there's only one branch. Now over here in the console, I'm going to git push and set upstream origin develop. So let me copy this and issue the command. You can see that it actually created a pull request for develop on GitHub by visiting the link, created new branch, and now branch develop set up to track origin develop. So our local develop now tracking remote develop. Let's refresh the page, and now we see two branches are here. There's develop, and then there's main. So if we go to our repository, now we can switch between develop and main. And you can see on main branch, we have only one file. On develop branch, we have two, develop and our original file. So now, let's say you wanted to add your work back to the main from the develop. What you can do, so you can do merge. So in order to do merge, first you have to check out. So let's check out to the branch that where we're going to be merging our work into. So let's go to, let's clear the console. So let's do git checkout and then name of the branch. So we're going back to the master branch. Git, was it master or I think it was main. Okay, git checkout main. We're switched to the main branch, right? We're back on the main. If we do git status, we're on the main. Now let's say we want to merge develop into the main. So we can do git merge develop. Okay, so now if we'll do git status, we actually have our branch ahead of the remote one. So let's do git push, and then we will introduce the changes that we originally had in the develop to the remote main, because our local main is already updated after we did the merge. So git push, and now it was pushed out. Let's switch from the develop branch back to the main one. And now we see both files are here, text file and develop file. Okay, so that is it. Essentially, that's the basics of the Git. As you progress your career, you will definitely meet with Git, GitHub, or some other repository management tool. And you will have to work with the tool. You'll have to understand. Maybe you will be fixing some of your test code or updating test cases or even automation. So this tool is definitely really, really helpful and widely used. So knowing it will be very beneficial. What's going on, everyone? This is Alex, USA Days. So today we're continuing with Learn Quality Assurance from scratch, and we're getting into SQL Introduction. So this topic is a little bit more complex, so I'm gonna break this video in parts, in shorter parts, but the plan is we're gonna learn about SQL in general, what it is, and we're gonna practice. So this is gonna be hands-on during the video. Just follow the links that I have provided in the description, pause the video, type out the commands yourself so you can actually practice and learn SQL this way, because really the only way you can learn this stuff is by doing. All right, so we are pretty much at section 8 right now, so it's been a journey, quite a journey. So we covered a lot of topics already. We introduced the basics. We went into some commands that you have to know through Git, console commands, how to do documents, how to file bugs, different types of testing, all of that. So right now we're in SQL introduction. This is a basic SQL. This is not advanced SQL, but this is going to be enough to get you going with your testing. You will be able to retrieve data from database using SQL commands, analyze this data, test this data, and maybe even update some values in the database if needed. After that, we're going to proceed. Next section will be into the API testing. All right, so let's get into the SQL. So what is SQL, right? What it is, right? Pretty much it's a programming language that works with a specific SQL-based databases, right? And what is database? Well, anytime you're on a web page and you reach for some information, let's say you're in Instagram and you're opening your friend's profile page and your friend uploaded some new photos. So those photos, your phone, your app reaches the server talks to the database, database sends those files to the server, and the server transfers them to your phone. So basically, the data that is stored in different databases, right? Databases are organized collections of data that can be stored, managed, and retrieved in various ways. There are several types of databases, each designed to serve specific purposes and cater to different data management needs. You will mostly find SQL and NoSQL databases. So SQL databases are the databases that use SQL language that we're going to learn today, practice today. NoSQL databases are databases that don't use SQL language. SQL stands for Structured Query Language, and SQL databases are relational databases that are structured using tables with rows and columns. They use an SQL language to manage and query data. Examples of databases that use SQL, and you might have heard some of them, MySQL, PostgreSQL, Oracle Database, Microsoft SQL Server. Now, if you think about SQL database and you think, okay, what can I imagine in my head? Like, okay, how does it look like? What is it, right? Where's the information? How is it stored? You can think about a spreadsheet or a payroll or like a schedule, right? Where you have columns that define what sort of data is stored with within those columns, and rows of data for each record, pretty much like a spreadsheet. Uh, just that spreadsheet has multiple tables, not just one table, multiple tables that store different data. Then there are NoSQL databases. So databases that do not use SQL, and they are designed to handle large volumes of unstructured or semi-structured data and provide greater flexibility and scalability than traditional relational database. For example, Amazon DynamoDB, MongoDB, Cassandra, and many, many more. You can think about NoSQL databases in terms of like Word documents. So SQL database is like a spreadsheet, Excel spreadsheet. NoSQL database is more like a Word document, right? SQL database is structured. It is relational. NoSQL database, more again like a storage where there's not a lot of relational, less relation. There are advantages of disadvantages using one versus the other. SQL is still very popular, and often companies might have different projects that might need different databases depending on the project. But SQL is still a preferred choice, like for startups, small project that needs an organized, manageable database. So we're going to go with SQL. We're going to learn some SQL commands. And by the end of the series of the video into SQL introduction, you'll be able to use and read SQL. It's pretty much like you can read an SQL command. You will be able to read SQL command like you read English sentence, pretty much, right? So a lot of professions use SQL on an advanced level. While you starting as a Q engineer, you're not going to be on that level, right? For example, there are backend engineers or data analysts. They can create a whole set of databases. Within those databases, have multiple tables with different relationship between those tables. For a QA engineer, starting QA engineer, what you really need to do, you should be able to retrieve data from a database, look at the data, and verify that it is correct. For example, there is a price on a web page, right? And the price seems to be a little bit off. So you'll go and check out the database to verify that the price is actually correct. Or maybe some values on the page that are not what you think they should be. So you can go in database and verify, okay, is that section is pulling correct values? Are those values correct? Okay, so something like that. Also, a lot of SQL interview questions for QA engineers, unless it is database testing specific position. So database testing specific positions might have like an advanced SQL level take-home tasks where you have to create like multiple different SQL requests, structure them, might be a little bit hard. But most of the QA engineer interview questions that include SQL questions are really simple. They will sound something like this. So how do you retrieve all customers that are from United States from customers table? which department has more than 100 employees, things like that. So you will be able to type out commands like this and do requests like this after the end of the series of video for SQL introduction. Questions like this are really easy to prepare and answer. So we will be practicing during this video, and I'm gonna use two web pages. So https www.sql-practice.com. That's going to be the first one, and we're going to use the www.w3schools.com SQL section. So the links for those web pages will be in the description. You don't have to install anything on your machine. You don't have to install a database. You can just practice online. You can follow along with me, pause the video, type out commands yourself, try to solve the task, or additionally practice more on those pages on your own after introduction. Okay, so how does a database looks like, right? How does it look? So here we have two tables that are coming from a database. We have a customers table and we have an orders table. So here you can see customers table at the top, and at the bottom you can see orders table. This is how it looks like when you retrieve data from the table. In the customers table, you see there are multiple columns, so customer ID, customer name, contact name, address, city, postal code, and so on. So those columns define what sort of data will be stored within them. And then you see records. So each row is a record of some information. So here's customer number 1, all the information about that customer. Here's orders table, order ID 10308, and all information about that order. And you can see there are primary keys. So primary keys are unique identifiers for each record. For example, for customers table, primary key would be customer ID. So each record that is added to the table will have to have a primary key. It can't be null, has to be unique value, because let's say there are twins. They have same name, first name and last name, same address, everything is the same about them. They're twins, they live at the same apartment, right? And both of them are customers. So how can system distinguish one from another one, right? Well, it's done by using this primary key. So for example, if you go and shop in Costco, you have a Costco membership, right? So that Costco membership would be your primary key for your as a Costco customers. So let's say you and your twin, you have different memberships, you have your own cards, you can live at the same address, but the system will know you from your twin, right? So this is what that unique identification is. This is what the primary key is needed for. Another example of a primary key in real life, a value that is unique and belongs just to you. So like your taxpayer's ID number, or if you're from the United States, like your social security number, just unique identification that belongs to you, no one else has it. So this is the role of the primary key, right? To identify a record, to give it like uniqueness. And then there's something called foreign key. And foreign key serves a connection because foreign key references primary key in a different table. So here we have two tables, customers and orders. So let's think in terms of like Costco member and your check. You just went to Costco, you did some shopping, and your check, your receipt has a transaction ID for all the purchases you had, like your transaction ID. That would be your order ID. Your transaction ID is the primary key in the orders table, right? It may have the details on how many things you purchased, how much it costed, who was the cashier or employee who registered you, and it has your Costco membership number. But there's no other information that your Costco membership number. So that Costco membership number can point back to customers table for your Costco ID that will have all the information about you, like your first name, last name, address, how long you've been member for, and so on. So this is how it looks here. So visually, you can see customers has its own primary key, which is customer ID. Orders has its own primary key, which is order ID. But then look, there is a customer ID column that is referencing
customer ID column in customers. So you see in orders, there's a customer ID column that is referencing customer ID in customers. So if I'll ask you, if you have access to orders table and to the customers table, if I'll ask you, so who bought order 10355 and order 10383, you can take a look into the foreign key, into the customer ID column. You can see number 4 for the customer. So there are two transactions that that customer did. So foreign key doesn't have to have uh, all values to be unique. Like one person can have multiple purchases, right? So primary key has to have unique values. So you can look at customer ID column, find ID 4, and then go back to the customer, find primary key number 4, and find all the information about the customer, right? So foreign key serve to connect tables, and they can reference primary key in another table. Primary key is a required column that will be present, or sometimes set of columns, that will be present in each table, and values within the primary key column all have to be unique for each record, because you can't have a record without identifier. They have to be unique. You can't have repetitive identifiers, and they can't be null. So you can't have a record without a primary key, right? Okay, so this is how it looks when the table is returned. Remember, there are primary keys, and there some tables will have foreign keys that allow connecting multiple tables. Now, then there's one more thing that I want you to know that exists in SQL tables, and it's called schema. So schema is a logical container or namespace that holds a collection of database objects such as tables, views, indexes, and stored procedures. You can think of it in terms of database foundation. It's like map of what should go where and how everything is connected. So this is a diagram, an example of a schema we will work in this table today, in this database, in these tables. So here is a schema, a diagram. So we have 1, 2, 3, 4 tables. You can see 4 tables. We can see how they're connected here. Some of the schemas will even have like a little golden key for a primary key column and like a silver key for a foreign key column. So for example, here is a patients column. Within that column, there are here's patients table. Within that table, there are columns: patient ID, which is a primary key for patients; first name of a patient, which is varchar. So that means this column stores text values, and this 30 for the varchar means the text values cannot be longer than 30 characters. So there's a column last name with varchar 30 also that stores up to 30 characters. Gender, char, that stores only one character, so male or female. Then birth date column that stores date, data type. City column that stores again varchar 30. Then there's a province ID, and that's a foreign key, and you can see it is connected. So one to one to many connections, so it or many to one. It's connected to province names table where province ID is a primary key. And I will also show you how this looks when we'll be doing like join statements. But essentially, through that province ID, you can go into province names table and get a province name instead of the ID from using the join statement. Then there's allergy columns, height columns, weight columns. You can see there's different data types. So height and weight are in decimals, right? Then other tables that present in this database. So doctors, also doctor ID, that would be a primary key. First name, varchar 30, so stores text values up to 30 characters long. Last name of doctor, again, varchar 30 stores text values up to 30 characters long. Specialty, varchar 25 stores text values up to 25 characters long. Then there is admissions table. You can see it has also patient ID, attending doctor ID, admission date, discharge date, diagnosis, all they have different data types. Each column have different data types. So schema is essentially your foundation for your database. Schema tells how many tables there are, what kind of columns in those tables, what data type was in those columns, how those tables connected, what are the primary keys, what are the foreign keys, and so on. Okay, so let's start practicing with SQL. We will start with some simple commands. So I'm gonna exit this view. So I'll be switching to like a smaller view, slide view like this, and actual window that we will be practicing in. To start practicing, you can go to sql-practice.com. Again, this link is in the description, so you can access it there. Let me zoom this a little bit, maybe. Okay, so let's go and start with simple SQL commands. So one of the first commands that we can try, and you can try in any table, is let's just get everything that we have. So you want to get all columns and all records from patients table here. Here is our database. So let's look at the schema. Here we have patients table, we have doctors table, we have admissions table, we have provinces table. Province names table. So we can start by saying select everything from patients. So if I'll do that, if I'll run this command right here, there is a run button, you can see I get back a table. Down here, now there's a response, there's a table. Those capitalized words that are in blue called SQL keywords, and they essentially tell SQL what to do. Here we're asking SQL to start selecting something. Let's grab some data. This asterisk is saying I want all of the columns and data within those columns that exist in the table. So you can see there's column patient ID, first name, last name, gender, birthday, city. So just like in the schema, patient ID, first name, last name, gender, and so on, right? This is patients right here. So asterisk is easy to use because you can get all of the columns and you can know them immediately. You don't know the table, you can get all of the columns, you can see all of them. Now you can get, instead of asterisk, you can get specific columns. You're still going to get all of the records. It's still going to be 4,530 results. So that's the amount of records that's coming back. But let's say I want to have only first name column and last name, right? So you can separate them by comma. Here I selected two columns. I'm only getting first name and last name of patients right now. Run it. Here we have first name and last name. Same amount of records returned, just showing two columns, right? So let's get back to getting everything. So use an asterisk, run it again. Here we have all the information. Now, from is a pointer, again, another SQL keyword that tells, okay, SQL, you have to do something. So here it's actually pointing to some place. And in our case, we're pointing to patients table. So you can see, you can read this in English, and in English it says, select everything, select all of the columns and data within those columns from patients table. That's how you can read it. That's what this command means. So you can go ahead and type this out and try running it under this link, so sqlpractice.com. You can also try and grab everything from doctors. So let's go and select everything from doctors. And you can see it suggests you, okay, doctors table. Okay, here I selected doctors, run it again. And now you can see it change. So we got doctor ID, doctor first name, last name, and their specialty. You can also see that aside from the keywords that like they're highlighted in blue and they're capitalized, SQL doesn't care for new lines, right? So this is still going to work. And SQL doesn't care for new additional spaces. You have to have initial space. Additional spaces doesn't matter. So I can go back to patients table. It can look like this. I can still run it and it's still going to work. Why is it done? Well, because you can structure your statements that way that it's easier to read. Like I prefer to put new keywords on a new line. So select keyword, my first keyword, so select everything, and then new keyword from, and then patients table. Sometimes you will see a semicolon at the end. So this is just an indicator that it is end of your statement. If you have a semicolon, make sure you have it once at the very end of your command. If you put it somewhere else, like here, and try to run it, it says syntax error. So you're going to break your request. So if you use semicolon, use it once at the very end of your statement. Okay. All right. So we just grabbed everything from patients. Now you can get specific columns, right? As I said. So for example, we can get first name and last name from patients, right? And what do you see here? This table, right? We actually did not change anything. This table that is returned is a result table. That's a temporary table based on your request. Nothing gets changed in the database. You just retrieving information. And doing select everything from patients, you just retrieved all the information that exists in the patient's table. Now, if you want to get like first name, last name from patients, those columns, you can type that out too. So just get first name and last name from the patients. All right, perfect. Let's move to the next one. So retrieving all data is nice, but you also want to start searching for specific data. And you can do it using where keyword. So our statement kind of grows in complexity. The first part stays the same. So we say select everything from patients, right? Run it. We get all of the columns, all of the data. Now we can say where, that's our new keyword that starts the search. Then you need to provide the column name. So for example, gender, and then you need to provide value. So equals and some value that you're searching. So if you're searching for a text value or anything that contains letter, you have to put it in quotes. Double quotes or single quotes, doesn't matter. If you're searching for an integer value, you can put it without quotes, just like that. Now, if you're going to put text value without quotes, so for example, you're searching for all the patients where first name column, right, has name Donald. Donald is a text value. It has an equal, so it looks for an exact match. So it has to be capitalized, starts with a capital D. So if you're going to have it without quotes, it's not going to work. It's going to think it's a column. Because it's a text value, you have to put quotes on each side. Run again. Now we have all patients whose first name is Donald. If we were looking for a number value for integer, so we can say patient ID is number 777, right? Because it's an integer value, column contains integers, you don't have to provide quotes. Okay, so just be aware of that. Looking up text values, make sure you have them encased in quotes. Single quotes or double quotes, doesn't matter. You have to open with the same quote and just close with the same quote, right? Either single or double. So here we have an example where we're selecting, and by the way, you can go into here we have questions. So you can go into questions and you can select different types and questions to solve. So for example, let's go all keywords, difficulty easy. And here's our question. Let's read it. Okay, it has. So show name, you don't have it solved, so you're just gonna see the question itself. So it says show first name and last name and gender of patients whose gender is M. So let's get all of the male patients, right? We can start with requesting everything. So select everything from patients. So let's just select everything first. We did this before. We got the patient's table back. Now we can say delete the semicolon. We can go to a new line and say where, And then gender, so we're looking into the gender column, equals to male, capital M. Run it. And now we have all of the male patients coming back. Now it says incorrect solution because in the question it asks show first name and last name and gender. So instead of getting all of the columns, we want to get first name column, last name column, and gender column. Run it again, and we got a correct solution. Perfect. Okay. So this is when you need to get some specific value. You know the exact value you want to get. It's going to be an exact match. So you will use equals, right? Now, when you have a missing value, value is null, you have to search a little bit differently. You have to provide is null instead of equals something. It has to be is null. So some records might have like no first name, no last name. Maybe the date of birth wasn't entered. So maybe some information is missing. And you want to find those records that have an information missing. For maybe you need to add this information like allergies, right? Allergies, some of the patients have no allergies to any medicine. You want to find those patients. So in order to do that, you will have to say where. Again, we started our search with the where keyword. Then we need to provide the column that we're searching in. So allergies, that's the column name. And then we have to say is null. So, and run it. And now we have all of the patients that have no any allergies to any medication. If we go into the questions, here is, it's also one of the questions, one of the tasks. So on easy, you have show first name and last name of patient who does not have allergies. So first name, last name, patients, allergies is null. Run it. And here we have a list. Here we have a solution of all the patients with null allergies. If you want to see all information about them, again, you can put asterisk after select instead of column names, run it. And here we are. Okay. Now next slide. So here you can use different operators. Not only equal, you can use larger, larger or equal, smaller, smaller or equal, and even between keyword to find different range of values. So for example here, let's find all the patients whose height, where height, so if we put equal, we can find one parameter. So equals 191, right? Run it, and we have now all patients with height 191. Let's find 250, if there's anyone 250. Okay, no one is 250. Okay, let's find everyone whose height is larger than, let's say, 200. Run it. We got 315 people. Okay, let's do 230. Run it. No one. 220. Okay, couple people. 24. Okay, we got 2 people. So you can see height is larger than 224. So 226, 225. You can say is smaller than 224, and then you'll get everyone else, right? Who is smaller than 224 in height. You can find between. So let's say we want to find people with a specific weight. So we can say select first name and last name columns from patients, and also let's add weight so it's visible. From patients table where weight between 100 and 120. So between those two values, run it, and we got 952 people. So let's say, what is the highest here? Let's do 19. Okay, still a good amount of people. Select all of the columns. So the highest is 120. So we got 119. So including 119 and including 120. So 119 and 120. That's all we got here for the weight. So when we have a value that we want to search between, we can use between keyword. Another way to do it is to do with operators. So larger, larger equal, smaller, smaller equal. We can have the same exact request, but just instead of using between, we can use larger or equal to 100 and weight smaller or equal to 120. So let's do, instead of 100, 119. And again, we can just read this as we would read it in pure English. So let's do select everything, select all of the columns from patients table where weight is equal or more than 119 and weight is less or equal to 120. Run it, and here we are. This is our table that's coming back 120 and 119. All right. The next one, let's do the next one. So sometimes you want to exclude some value. So we're going to use not keyword. And you also want to find multiple values in one column. For that, we're going to use in keyword. So let me show you how it's done. So for example, let's go back and get everything from patients. So select everything from patients as your first step. Now let's exclude everyone who is male. So we can say select everything from patients, and let's say where, then we want to put not, then the name of the column where we're doing search, gender, and then equals to male. So not gender, or gender is not something, right? Run it, and we get back all of the females. Okay? So that's if you want to exclude something from your search. The next keyword is in. Now in, pay attention, instead of equal, we will use in. And then in parentheses, you'll be able to provide multiple values. So let's say we want male and female. And remove not. So in will be used instead of equal because you can't do equal and do a multiple search. It's going to break, right? Equal is expecting only one value here. So we're going to say in, and then you have to put your values in parentheses. Still have to have them in quotes. Still have to have them separated. So let's get all patients that have allergies to, let's do penicillin, for example, and sulfa, right? Run it, and we have penicillin sulfa. So 1,200 patients have allergies to penicillin sulfa. So we provided multiple values here, right? Okay. So the next set of keywords is and or keywords. So first one is and using and keyword, you can provide multiple conditions for your search. For example, here we have select everything from patients where weight is more than 130. Okay, we sorted by weight, so everyone is higher than 130. Then we can add another condition. Let's say and height is higher than what we got here, 213. 213, right? Run it. We got 3 patients back. You will get response back only if all of the conditions are true for a record. So in order for the system to show something back to you, your weight have to be, the weight of the person have to be more than 130, the height have to be more than 230. So this and this, so both of the conditions, they have to be true for that record. And there are only 3 records where both of those conditions are true. So patient 2466, weight is 132, so it's higher than 130. Height is 213, is higher than, so have to be more than 213. Height is 224, so it is higher. So only when both of those conditions are met, the value will be returned. So and helps you to narrow down your search, have like multiple criterias for the results to be returned. You can add another and let's say and city have to be, and let's add Waterfall, right? Another condition. So when this is true and this is true and this, let's run it. And we got now one record that matches all of those conditions. So by using AND keyword, you can narrow down your search, you can specify multiple columns and provide like specific details to get the result back. Okay. There is another keyword though, and it's called OR. So you can use OR to return any record that is true to either of the filters. So either of the conditions. And let's take a look at this request. So again, select everything from patients where weight is 300 or height is where weight is more than 300 or height is more than 225. Run it, and you see there's only one patient. So weight, is the weight more than 300? No. Weight is 121. Height is 226, and the requested height was more than 225. So the height is okay. So it found one criteria in a record that is true, and it returned that record. So for the OR record, if either this or this is true in a record, this record will be returned, right? If I will put here and, for and both of the conditions have to be true. So weight have to be more than 300, height have to be more than 225. There will be no such record. There's no such record. If I'll run it now, it will say no rows to display. So essentially, it didn't find anyone that has weight more than 300 and height more than 225. If I will put OR back and run it again, you will see it returns patient 773 because its height is higher than 226. So this was true for that record, and the whole record was returned, even though the weight was false. So true, if one condition is true in OR, it will be returned, right? In the case of AND, everything have to be true for the record to be returned. Okay, let's go to the next one. So here we're gonna practice probably the most useful search that you'll have to remember. It's partial search. So now instead of equal sign, we're gonna use like keyword. So no more equal. So here we said everything from patients, where let's say gender equals to M. The thing is, was equal. Equal is looking for an exact match. If I have, instead of capital M, you see in gender capital M, if I'll have instead of capital M, lower m, and try to find it, it won't find it. Because equal is looking for an exact match, right? Now with like keyword, it's not the case. So instead of equal, we're gonna use like, that's not a keyword. And I can search now and still get value M back, because a like does ignore capitalization, right? Now, another thing with the like keyword, you can use wild characters, so percent sign and underscore. So you can use it with where, with like, percent sign and underscore for partial search, right? For example, you can use like and underscore wild character to find match with partial value. So here we're gonna find, let's find all patients whose last name starts with K. So select everything from patients where last name like K percent sign. So K have to be first character, and then here's a percent sign, mean anything goes here. Let's run it. I think it doesn't like this quotes. Let's run again. Okay. Yep. So you can see last name, all of the patients is starting with K. K, K, K. We can say we wanted KO. So now it reads like select everything from patients where last name of the patient starts with KO and then anything goes. So because there's like and the percent sign, any KO pattern will be matched. So let's run it. Co. Let's say KOW. So at least first three letters have to be KOW. Run it. Last name KOW. I think it should find this record. Okay, here we go. Kowalski. And then this percent sign means like whatever is there will be included. So all of that part came from the percent sign, Alski, right? You can reverse it and say, hey, it can start with anything, but let it end with a special character. So let's find all of the patients whose last name ends with K. Run it, and you see back or bank. Let's say Bach. So let's find all of the patients where last name like Bach, like percent sign Bach. So can't start with anything, have to have Bach at the end. Run it, and here we have callback. Now, what if I want just a particular set of things included, right? Somewhere in the middle, not at the end, not at the start. Then you can incorporate values in the percent sign from each side. So let's do birth date. Birth date. So select everything from patients where birth date like percent sign 986-10-2 percent sign. So can start with anything, can end with anything, but must include 986, 10, and 2. Let's run it, and here we have it. 4 records that include this pattern. So any pattern, if you want to match any pattern, like if you want to match a pattern that you provide, encase it in the percent sign. You can also find like separate words and spaces. So what if I want last name that has 2 words in it? So where last name like percent sign space percent sign. This can be a whole word, this can be a whole word, and there have to be a space in between. Run it. Okay, so there are no double last names. What if it has a dash in between? Okay, here is a dash. All of last names with a dash. All right, so we know how to find records that start with a specific character, end with a specific character. We can find characters with a specific pattern. So let me just copy this. By the way, 2 dashes over here, this is a comment, right? SQL ignores comments. You can say this is bananas. SQL gonna ignore it. So developers leave comments in their code so they can know what the code does. They can come back to it, read it, and understand what they were writing. So the comment is going to be ignored by SQL. This is for us. But we look in any last name of a patient that has RL anywhere in the name. So percent sign, RL, percent sign. run it, go to the last name, Arlie, Pearl, so Arl, all of them have it, right? And then with the underscore, if you play like Wheel of Fortune or saw it on TV, right? It's just one character that is missed. You can have multiple underscores. So let's say um, something like this. Select everything from patients where first name like G underscore A. So first name have to start with G. Second character can be anything. Third character have to be Y. So if I'll do a search, I have all the first names where the first name is Guy. So this one character, one underscore, was filled. I can have underscore underscore Y. Now I have Amy, K, so two first characters can be anything. The last one have to be Y. I can have just two underscores, so any first name with two characters will show up because it has two underscores. If I have one, well, no rows found, so there's no match. Okay. All right. And you can also combine them. So here's an example where we're searching by city. So select everything from patients where city like R underscore D percent sign R underscore D space percent sign. Run it. So it means that city have to have two words. First word have to start with R. Here's R. Second character can be anything. So here's E. Third one have to be D. Here it is. Then have to be space. There is a space here. And then anything else after that. Any other thing. And we have Red Deer and Red River. So bunch of cities, bunch of patients from Red Deer and Red River. So it can be river here, deer, or anything else that it is in the table. All right, perfect. Now we can also order by specific order in ascending or descending order. So here is one example where we can select all the patients or select all of the columns from the patients table, and then we can order by height in descending order. Let's run it. Now we have the patients from the highest to lowest, from 226, 225, 224, and down to the smallest height. So we can order by descending order, or we can order by ascending order. So that will be ascending. Why is it not working? Ascending, run it. Okay, here we go. So by ascending order, select everything from patients ordered by height in ascending order. So from the lowest to the highest. 25, 26, 27, and so on. See, it goes from the lowest to the highest now. So you can order by specific column in ascending or descending order. All right, perfect. Now, this one we will practice in another table in W3 Schools SQL insert. You can have this link in. You can find this link in the description. But we can insert information into a table. So let's go here into this W3 School insert to. You can see here there's also a bunch of keywords, and all of them have description, introduction. So if you want to spend some time, additional time reading about different keywords and practicing them, you can do that here. So let's go and click on try it yourself. All right. Gets us to this SQL statement. So I'm actually gonna go probably to the shippers. So shippers has only 3 columns, and 3 records. It's kind of easy to see the impact. All right, so um, we're in this console, same console as here. You know, this console talks to the database behind the scenes. Right now, we just selected everything from the shippers table. We can add insert info. So for example, we can insert info without an ID, right? There's always have to be an ID. And ID is a primary key. If you don't provide it, it will be auto-populated and it will be just incrementing. So from 3, we're going to go to 4. In order to insert value into a table, you have to type insert into name of the table. So shippers, that's the name of the table right here. Then you have to provide column name and corresponding value. So shipper's name will be Alex USA Days, and then column name phone, and the phone number going to be 888-555-9831. So in the first line, we here provide insert into shippers and the columns, and then we say values, and we provide values, and the values will be corresponding in order with the columns that you have. If I run it, I did not recognize this comma. Okay, updated the comma. Run it again. Changes have been made. Row affected 1. Okay, let's get shippers one more time. Now I see that new shipper was added. Alex USA Days was added into the shippers table, right? Now we didn't provide shipper's ID, but because it's a primary key, it was automatically generated. I do not recommend it, but if it is absolutely necessary and needed for your testing, you can even insert with an ID provided. So you can say insert, so insert into shippers. Now you can say shipper ID and then the provide ID that you want to insert. So same thing, insert into shippers. So that's the keyword. That's the name of the table. Shipper ID is the first column. Shipper name is the second column. And then this is the third column, phone, right? Let's insert this. 10, Alex USA Days, and the number. Again, I have to update this quote. Okay. Open shipper. So now we have record number 10 added. One more record was added. Was the primary key that we provided in the request. Okay, perfect. Well, sometimes maybe we don't want to provide any values, just one column, one value, and you can do that. For example, you added something for testing, how the data gonna come back where there are null values, maybe on the front end from the back end, right? So you can say insert into shippers, and I'm gonna just insert the shipper name. This is crazy, and nothing else, and run it. Go to the shippers. You can see, the primary key started incrementing from the last value. So from 10, from the value that we manually provided, it was added 11. Here's our this is crazy value that we added. And then there's null for the phone. So no phone was provided. Nothing was populated here. Okay. All right. And then there's update. So you can actually update specific records. So let's say also you can do it for testing, for SQL testing at your work. You need to update some test values to be whatever. So for that, you have to go with update command, and you can issue update as your first keyword. Then you have to provide name of the table, so shippers. Then you want to say set a column, set shipper name column, and then value, what are you updating it to? So we're going to update something in the shipper name to we updated this. So some of the shipper's name will be updated to the we updated this text. Where, now here's your condition, where shipper ID is equal to 10. Where is our shipper ID? Here. So shipper ID 10, this shipper name will be updated to we updated this. Let's run it, get the shippers, and look at this. Shipper ID 10, shipper name, we updated this, and a phone number. Okay? All right, so now we get we get to the most hard part, joining multiple tables together. Now, we talked about primary key and a foreign key at the very beginning of SQL introduction. So let's practice join, how we can do this, right? So in order to get join request, you need to add another table into request using join keyword and then specify primary and foreign key connection. All right, so for this, I'm going to go back to the Learn SQL here. And this is the statement. Seems a little bit crazy first. Let me comment it out and kind of dissect it. What are we doing here? So I'm going to just put comments. So this will be for reference for now. So very first thing, let's do this. We're going to select everything from patients. Let's run it. We did this before. Here's all the patients' data. Perfect. Now, I want to have some other values showing. I want to show the province the patient is from, but not with ID, but actually a whole name. And we're here in the schema. We can see there is patients. We're in patients right now. And it's connected. The province ID is connected with the province ID in province names. So as I said here in the slides, first we need to join table and then we need to provide connection. So if I'm joining patients with province names, I need to do that. I need to say join province names, right? Province names. Okay, I can run this, but it's going to be a mess. So this is not it, right? Yeah, I think it even hanged. Yep. It actually hanged. So because when you join it without providing any details, it's gonna create like, okay, what is going on? It's gonna create a record for each table, for each column with another column. So that is not gonna look pretty, right? And when you have like multiple records, it's definitely can break your response. So let's do select everything from patients again. So we just requesting everything from patients, run it, here we are. Now we're joining, join province, province name, names table, right? Now we need to provide how they're connected. In order to do that, we start with on keyword, and then we need to provide table name column equals to other table name column. So if we look at the schema visually, we need to say, okay, we just joined in province names, but we need to say patients dot province ID is actually equal to province names dot province ID. So we need to specify this relationship. So let's go and do that. So we type just the name of the table. So let's do patients dot province ID is actually equal to provinces names dot province ID. Okay, so we specified this connection now. We can run it, but because we have asterisk, it means it selects everything. All of the columns from one table and all of the columns from the other table. We don't really need this much information, right? So I only want to know first name and last name And how I want to make sure it's coming from the right table, I can specify table name before the column name. So patients dot first name, patients dot last name. If I run it, now I have first name and last name. So those two columns are coming from patients, but I also join provinces names, and I can say provinces names dot province name column. So this column, province name, will come from province's name table. Run it, and here's province name. We can also have patients, and let's add province name, province ID. So you can visually see the ID. So Ontario and so on. So now we join two tables together and got columns from different tables. One thing though, you can see how you start typing out table name and then column name. It can get a little bit long. So first time when you pull a table in, you can have an alias. You can say as to make sure it is an alias. Give it alias. Let's give alias to the patients. Give it P, and then let's give alias to province names column, province names table as PN. Now everywhere else you use the name of the table, you can substitute it with an alias. So everywhere else you can use, for patients you can use P, not where you pull it, just everywhere else. And then for province names, you can use PN. So the alias that we give here. Now it makes your statement a lot shorter. So delete this comment, so run it, and here we are. So we're selecting from patients table column first name. Here we're selecting from patient table column last name. Here we're selecting from province names column province name. Here they are, they're all showing. Now here we're saying from patients as P, so patients table is pulled in and alias P is given. Join province names, so province names is pulled in and then alias PN is given. And then on, we're providing this referential integrity. We're telling how those two tables are referenced, how they're connected. So patient's province ID values column is actually equal to province names province ID. All right, we can put a semicolon at the end. Here's end of our statement. We did our join. And that's it. We're done. So how QA engineer, what kind of testing QA can do on database? You can ask, right? Okay, what do I do with all this information? Well, when you work with database, you can verify database design and schema in documents versus actual return values. So you can take a look at documentation of whatever for the test scenarios, right? For the business case, you can go to schema and say, okay, so patients have to have patient ID as a primary key, province ID as a foreign key, and province ID have to be char 2 and maybe it's char 3. You can verify all of this, like you can verify the schema itself. Is this schema correct from what is actually existing in the database? You can verify columns and data types and what are primary key and foreign key. So you can verify all this within database, right? In documentation versus actual implementation. You can verify tables, data type in the columns, rules set in columns. You can verify if the data coming back is correct, right? There are no typos. Unique values are unique. Null values are there if they're expected or not expected. You can verify how invalid data is handled. So there's a bunch of things that you can do with SQL. Now, at the very end, I'm going to give you a very good life hack. If you have a specific task on SQL, maybe it's in the form of a test case, how can you actually use ChatGPT to help with your SQL needs? So let's go ahead and grab a question. So I'm going to hit view questions in sqlpractice.com. Let's say here is Here's a task. Show first name, last name, and the full province names. Okay, we have this completed. Show first name and last name contained into one column to show their full name. All right, let's grab this request. Let's go to ChatGPT and let's ask it. We can specify, that it is SQL, but it knows, right? It already knew. So we can grab the response from ChatGPT, go back here, issue it, let's run it, and here we have it. So what ChatGPT did, it grabbed your question, analyzed it, understood it was SQL, generated a response, and you just grab the response, put in console, and says select, and then concatenate first name and last name columns with a space in between, and show it as the alias as a full name, right here, full name from patient's table, and it returned. Instead of last name and first name, 2 columns, it concatenated them and returned them here. So ChatGPT is a pretty good tool in terms of helping out you with building SQL queries, solving like SQL tasks, building SQL test cases. So yeah, make sure you use it. Okay, so that's it. One small announcement. I updated my Patreon page. I'm gonna also provide it in the description, updated tiers. So you will see, okay, here we go, tiers. So you will see multiple tiers. Now I got 4. So quality cadets, just for the support. There's like early access, behind the scenes constants, when they're polls exclusive with Empower. There is assurance gurus for 5. So this will have live Q&As when I have those, and work in progress updates. So if you want access to the slides, that's going to be with this subscription in Patreon. So link in the description. There's also $10 a month and credits QA. So I will include whoever subs for this. I will include your names in post credits for the video as a thank you note after each video. As long as you stay here, I'll add your name at the end of the video. And then at $25 is quality assurance one-on-one, so we can have like a 30 minutes call, talk about QA career, go over interview questions, talk quality assurance. So a call once a month, but you have to be sub for a month. All of those higher tiers subs include all the previous benefits. So yeah, link to this also in the description. That's it. Hopefully that wasn't too much. Thanks for watching. This was Alex USA Days, and bye-bye. Hey everyone, this is Alex USA Days, and now we're getting into API testing. We've been through a lot already, so we've been through 8 modules so far. We finished with SQL Introduction in the previous module, and now we're in module 9. We're getting into API testing. Now, this first video is going to be more about theory and kind of introductory how it works, and then in the next video we're going to get hands-on into actually doing some testing for the API and learning the tools how to do the testing, right? Now, what is API? So API stands for Application Programming Interface, and an API is like a contract that allows different software programs to communicate with each other. One software asks another software for specific information or actions, like asking for data from a website. API is like a conversation between 2 software programs that follow a set of rules that both programs understand. Most common API you probably end up working with will be Web API, right? Web API is a set of rules and protocols that allows different software applications to communicate with each other over the internet. It enables one software system to access and interact with the services, data, or functionalities of another system, often on a remote server. And in this diagram, you kind of see how this interaction happens. So a client, which would be like a browser or on your computer, or let's say your device, your handheld device like a phone, that would be a client, sends a request to the server. Now, this request is structured within the API. So the API is this kind of communication, right? And then the server gets your API request. It knows how to transform that, interpret that, and then based on the request, it will send back API response that your client will understand. So this communication is happening between client and server because of the API that is set in place. All right. Now, one of the most popular API approach is REST. So you're most likely going to be dealing with REST as a tester, and REST API stands for Representational State Transfer. So it's a type of web API that follows a set of architectural principles and constraints. It is designed to create a simple and standardized way for software systems to interact with each other over the internet. If API is using REST principles, this API is considered to be RESTful. So REST APIs use standard HTTP methods to perform actions on resources, and HTTP stands for Hypertext Transfer Protocol. It's the language that web browsers and web servers use to talk to each other on the internet, right? And we will get into more examples, and we're going to get into like hands-on stuff later on, but just for now, the theory to understand how everything works, right? So the primary HTTP methods that are used are GET. So GET will allow a client to retrieve data from a server. POST, this method will allow to create a new data on the server, so create a new resource. PUT, it will allow to update or replace an existing resource. Delete will allow to client to delete something from the server, and patch that will allow partially update a resource, right? So if you don't want to completely replace all the information, you want to update part of it, you'll set like a patch request from your client to the server. Now, once the request is sent, server will come up with a response, and this response will include a status code, right? So let's take a look at those. So with an API request method, there is a response with a status code. HTTP status codes are 3-digit numbers returned by a web server in response to a client's request made to the server. They provide information about the result of the request and help both the client and server understand how to proceed. So for example, if you get some sort of 100 code, that means it's informational. Common 100 codes would be just plain 100, which means continue, or 101, which means switching protocols. The most common response code that you will see will be a 200 something. So 200XX, meaning like any 200. If you get just plain 200, that means the response is okay, you successfully retrieved the resource. If you were doing a post request, creating something, you'll get back like 201, for example, saying, confirming that it was actually created. If you'll get back a 300 status code, that means some sort of redirectional action happened. So for example, 301 means that resource was moved permanently. If you get back a 400, that means some sort of a client error happened. And one of the most common ones for a 400 would be 404 not found. I mean, probably all of us at some point dealt with a 404 error when you try to access a web page and you get it like, okay, resource is not there. And then the worst one that you can get is 500. 500 means that some error actually happened on the server and it wasn't handled properly, and the server actually returned that error to the user. So 400 are kind of more acceptable errors. 500 means something's bad happened on the server. For example, 500 means internal server error happened. Maybe something crashed on the server, right? Okay. Now, within the request, you'll have requests headers, and request headers are included in HTTP request that made by the client to the server. They provide information about the request, the client, and data being sent. Some common request headers include user agent, so it describes the client application such as web browser's name and version. Host, so specifies the domain name of the server being requested. Accept informs the server about the media types the client can understand, like specifying that it can accept HTML or JSON. Content type indicates the format of the data being sent in the request, such as JSON or HTML, XML. Authorization contains credentials or tokens for user authentication. Cookie carries information about the client's previous interactions with the server. You also get a header in response. So response headers are part of the HTTP response sent by the server to the client in response to the client's request. They contain information about the server's response and how the client should handle it. Common response headers include content type, so specifying the format of the response. Status code, indicating the result of the request. For example, 200 OK for a successful response, right? Location, if redirected to tell the client where to find the requested resource. Cache control, provides instructions to the client regarding caching, helping with performance optimization. Set cookie, sends cookie to the client for storage, allowing the server to maintain stateful interactions. After the header, you might have a body of the actual request over response or response, right? So HTTP headers provide additional information about the request or response, while the HTTP message body contains the primary data being transferred. So when a client wants to send data to a web server or a server wants to send data in response, they include a payload in the body of the HTTP. This data can take various forms such as HTML content, JSON data, XML data, file attachments, or any other information exchanged between the client and the server. But we will look at JSON as QA engineers primarily, because that will be like most common data type that you will be verifying. And JSON stands for JavaScript object notation, as it is a widely used format for encoding data and it's particularly popular for web-based communication. So now this diagram will look something like this. So we'll have clients sending a request. Now this request will be an API right in between, and it will have a header and a body in this request. And then the server gonna process that request and will send a response back also with a header and a body. So some of the resources that I want you to check it out. So about HTTP request methods, I have the link in the files. Files are these slides are available with Patreon. So if you want to check the actual and download all the slides, you can get to my Patreon, and they're available like with the basic level. But essentially, I want you to check out methods. I want you to check out page on the status codes, and I want you to check out this page on working with JSON. Now, the JSON payload, how you're going to recognize the format, it will be within the parentheses, and you will see key value pairs, kind of, right? So you'll see first name, for example, and then Alex, and then last name, and like USA Days, and you'll see them in quotes, right? So now let's take a look at some request response briefly. Let's say we're on this page, and this is the page that I'm recommending you to read. So let's say working with JSON, right? I'm gonna clear everything in the console and then refresh the page. As soon as I refresh the page, the browser, the client will send a request and the server will send a response, and we will see in the networking tab all this communication happening. So let me refresh the page, and you can see a bunch of 200 status codes. Some 304s happened. There was no was blocked here. So let's see methods like get, post, different methods coming out. So let's see one of the requests right here. For example, who am I? That's like a very specific endpoint to who am I endpoint. The request was made here. And now we can start looking into it, get some more details. So here is our request header, right? Here is our response header. But then within the response, you will also have a body. So here's our JSON body. And I can take a look, say, within this JSON body, there is specified details about the country and an actual country abbreviation, so US, right? Now, I can switch the view. This is kind of structured properly, but I can say raw and kind of see the raw file, and you can see this is this JSON, the same JSON, the payload response is coming back just like that. And here we have geolocation. Within that geolocation, we have country United States and country ISO United States, right? And some other details are not filled, like username, no authentication, no email. You see there's email and there's null for email value. So that means there's like no data. So what QA engineers will do, they will actually verify API. They will do requests. They will look at the response. They will look at the response payload, and they will compare the request and response structure against the actual API documentation to make sure that everything is correctly structured, everything is coded correctly, you get the proper responses, the proper values back. If you try to trigger a specific error, you get the correct error message back. So we will be doing that in the next video. So this was like an introduction, but then we will learn the tool Postman, actually how to do some API testing. All right. So this was Alex USA Days. Hopefully this video is helpful. Like and subscribe for more, and bye bye. Hey everyone, this is Alex USA Days. So we continue with API testing. We already did a lot. So we in section 9, we already did SQL, Git, basic console commands. So we're getting more and more into API testing. Today we'll do introduction of Postman, and then as we move on, we can expand on that introduction. So Postman is an API platform for building and using APIs. Postman is also great for API testing. Now, what we will be doing, we will be using the request that we used before, and we will copy that request using curl. Curl is a command line tool and library for transferring data with URLs. Now, we will import this curl request into Postman, and then the imported request in Postman will have the same details as original curl command. This includes the HTTP method, headers, body, and other relevant information. Postman will handle the conversion process, and then you can use Postman interface to further customize and manage your API requests. The links that you'll see, the links we're going to use today in the video, and they also are available in the video description. In the last video, in video 19 for the series on becoming manual QA engineer, we talked about API in general, we talked about payloads, and today we're kind of continuing and moving to learning Postman as a tool designed to work with API. Now, if you remember when we went to the developer.mozilla.org to the working with JSON section, there was who am I request and response that we're looking at. This request response had some payload that was carried. So we're going to work with that payload and we will start doing some testing with it. Now, this is kind of introduction on installation and doing some basic tests, but as we move along, we're going to get more information about testing with Postman and how to structure it. Okay, so what do you want to do? This link will be in description, so you want to go to developer.mozilla.org webpage. Now, I'll provide this link in the description, and then once you're on the page, you want to do inspect, go to the network, so right click, hit inspect, and then go to the network tab, and once you're here, you can clear it out and do refresh. Now you will see this who am I request and the response, and it will have a body that comes back with the country, right? So when we will be testing this request. Now the tool that we will be testing is called Postman. There's another free tool that also has similar capabilities called Insomnia. So if you want to try that instead, like and explore it on your own, you're more than welcome to do that. So I'll have both tools in the description, the link to them as well. Now, once you're at Postman, the web page might change over time, so it might look different for you. So you can go to product, download Postman, or just type out postman.com and then downloads. Now, once we're here, click download, you'll have to sign up with Postman. I'll show you after the installation how to do that. So let's do download. We will see the download here is completed. So we can just click on the downloaded file. And there will be a pop-up asking for permission if you're okaying this action. Now you should just hit OK. Now if you don't see, that's fine. So once you downloaded Postman, it should start, right? You'll have, this is the Postman tool, this is the window. Now the thing is, there's limited capabilities with this window without signing in or creating an account. So what you want to do, you want to create an account. So hit create account button, and you will see a way to create an account here. So you can sign up with Google, right? So hit sign up with Google and it is loaded. So it is important with Postman to have an account, otherwise you're not going to have all the capabilities. So, okay, your name, Alex, USA days, let's do that. What is your role? Let's do quality engineer tester, continue. This is fine. And now we're here. So this is the home page. We have the account here at the top. So account was created. We have more capabilities now. All right, there's get started. If you're interested to, get started with the API and stuff, the overview page, we can just close it all out. The first thing that you want to do when you hit on the collections, you can see it's empty. You want to create a collection. That's going to be our first step. Let's hit create collection. And you want to give it a name. So let's give it first collection. I'm going to give it name first collection. Very, very basic. All right. So now once we have the collection here, we want to add a request. So we can hit add request. And it's asking, okay, what kind of request do we want? Now, one of the ways to actually have your requests, and this is one of the things that you might be using a lot as a tester, like you don't have to type everything out. If you're testing a web application that does some requests to the backend, you can go into your web app. So just like here. So you can go to your web app and you can right click on the request that's coming from your web app to the server. So let's right click it, go to copy, copy as curl bash, let's do that, and then paste it into Postman. All right, so our request was copied. So the link was copied, right? This is your endpoint, how the browser is reaching the link. So the link was copied. The method was set. So this is your get method. It also set all the headers. So all of the headers that you see in the request that are happening here, they were automatically set in the Postman. Okay, so now we can say, let's send it. And we get the status 200 back. You can see we got a reply back. And because all of the headers set the same way they were set in browser when they were copied, we also got back the same response with the United States that you have in the browser. Okay, we can save this request. Let's hit save. And you can select collection when you want to add it, save, and here it is. Let's delete this new request. We actually don't need it because we copied one from the web, right? And you can rename this request if you want. So let's just say, who am I? Who am I? Just that, nothing else. Okay, so we have get method that asks this link, this endpoint to get the information, and the information is based on the header information, right? We got geolocation back and the United States. So this is your first request within the tool, the same thing that the browser does, we just did in Postman. So let's add some basic testing to it. Okay, so back to Postman, there is a little tab called tests. You can hit on it, and a lot of like basic tests, which Postman is great with it. Like allows you to learn pretty fast. So a lot of like basic requests are right here. So there are snippets that you can click on and it will generate code within the tests. One of the things that you might want to confirm if the status of the response is fine. So you want to have a test case when you're doing a request to an API endpoint and you verify that status is actually coming back as an OK status, so 200. So we can say status code is 200. So when you click on this, you can see a test automatically added. So pm.test. So this is where the test starts. Then there's a test name, status code is 200. And then there is a function within the test that actually executes what the test is. So pm response to have status 200. Now let's run it. And you will see there is test result right here. There's a tab now in the response that is showing if the test was successful. So status code 200, that's the name of the test right here. And it actually says pass status code is 200. Now you can update this name of the test. Let's say you want to say is the status 200. So this is just the name of the test, and then this is a function, right? That this code is getting executed here. Let's run it. And you can see the name updated. So what if we're expecting a different status? Now I can go into the response here, and I can see that the status is 200. Okay. So what if I was, let's say, instead of getting, let's say I was creating some resource, and a code that you would expect when the resource is created would be 201. So I say that I'm expecting 201, right? And let's update the title of the test as well. Is the status 201? Let's send it. And now we can see that the test actually failed. So we're expecting 201, but we got 200, right? So application still doing the same thing, right? For us, what's important here is that we're doing some casting. We're expecting a specific response, but the response is not there. Okay, so let's delete the whole thing. Let's add it one more time. So status code is 200. The test is added. Let's run it. Perfect. So status code is 200. This is our first test. So let's add another test also using one of the snippets here. So response body JSON value check. So with this request, we're actually getting a response back, right? So, and there is location United States and country ISO. So we can do that. We can actually add the test. Let's hit response body, JSON value check. So here is the new test, and it asks to create a name. So let's verify country in response, right? So, okay, this is going to be our test name. This variable, it will store the response, and here we're looking for a specific data to come back, right? So, okay, what is that? Like, how can we actually find this data, the country data, within the response? So, in order to see what is stored in JSON data, let's comment this out over here. So we can say console.log, and let's type JSON data. All right, let's run this. And now there is a little console at the bottom. Right here, you can see it. So it's up. I'm going to clear the console, and let's run it again. Send. Here is this JSON data coming back, like this file, this variable that the response where was stored. We printed out into console, and here it is. Now I can see the structure. So there's geolocation, and then within geolocation there is country. So you have to kind of dive down, right? Dive deeper into your response to see what's coming back. So let's say I'm going to put JSON data and then dot geolocation. So let's run again. Actually, let's clear the console. Run again. And now you see, instead of getting all response, I kind of dive deeper into the JSON, and now we're here in this section, and only this section is stored. Okay, so here there are two options here, country and country ISO. So let's say I want to verify the country is United States. So what else I need to do? Well, I need to dive even more deeper in JSON file, right? So let's put another dot here and say country, right? Let's clear the console, run it again. And here we are. So we're getting back United States. So this file, right, we can say, okay, I want to store a specific response, right? Let's maybe store this as a separate variable. So let's say var country data. And then country data will be equal JSON data.geo.country. So this was stored first the whole response, and then we kind of dived inside the response all the way down to the country to here. So this variable, the data is stored for the country, United States, right? So we confirm that using the console. Here's coming back. Now we can add our test saying, okay, so let's PM expect, and here for the country data, so we expect country data to be equal to, and what are we looking for? We're looking for United States. Copy, so highlight, Control C or Command C if you're on Mac to copy, go to the test, and Control V or Command V if you're Mac to paste. So I just pasted this value, and let's run it again. Okay, now look at that. I'm going to close the console. I'm going back to the test results. Now we have two tests running. Both of them are passing. One is we're verifying that the actual response code is 200, and the other one is verifying that the country is correct. So let's say we're going to say verify country. Let's rename it UK. Country UK is in response, right? So let's say I want to see UK back, and instead of United States, I'm going to put UK here. So I update the whole test. I update the test name. Send it one more time. Verify country UK in response. Assertion error expected United States to deeply equal UK. So it was looking for UK, but actually got United States back, right? Because our request, there's nothing changed here. So same data is coming back. We updated test. So let's update the test name to get a proper response. So verify country United United States in response, and expect country data is equal to United States. Okay, so let's run one more time. Okay, test is passing for the code, test is passing for the value within the body, the response body. Okay, so I think we're good. So this is our first couple of our tests based on the API request that we already seen before. So what we're doing now, we created a request. We copied actually this request from the web. We pasted it here, imported here in Postman. We did the request. We get a specific body back. We get some status back. We get information back, right? And now we added two tests around this request. Perfect. You can save it or Control S to quick save. Save it. Request is saved. Great. Last thing that you want to probably have if you're doing requests and you know that they're working properly is to save the response as example. So you can kind of come back to it. If something stops working, you can actually see what was in the response. So I can say save as an example here, or I just right click it, add example. But let me just save it. So save as an example, and the example is added. Okay, that's it. It's actually just saved. So I can rename it, say example response. Who am I response. Now, anytime, let's say I run request and I get something else here, and I'm not sure what I want to see here, I have some stored data that I can reference to, and it will show an example. That's actually what was coming back. Okay. All right. Perfect. So thanks everyone for watching. This was Alex USA Days, and bye bye. Hey everyone, this is Alex USA Days. So we're continuing to learn Postman and API testing. Uh, we already covered a lot. We're in module 9 right now. And if you're interested in other videos, just go and see the playlist in my channel, Learn QA from Scratch. Now, also, I'm going to update this PDF file and add it in the Patreon, so you can download it if you're part of the Patreon, and so you can have all those slides available to you. Now, in the previous video, we talked about Postman introduction and overall installation, how to use curl. Now, today we're going to move with testing with Postman section. So we're going to talk about authentication. So when performing API testing, authentication is a crucial aspect to ensure that the requests are made by authorized users and that the responses are accurate. You'll have to check with the team on how to get to your API. Here are some common methods of authentication used in API testing, and I'm going to show you where it is located. But most likely you can get to your API using API key authentication, right? So you'll have to include an API key in request header or parameters. Um, or you might do it with basic authentication. So that means you will have to include a username and password in the request. Or you might use tokens, so you'll have to include a token, and I'll show you how it kind of looks in Postman. Today we will also talk about testing in general and how to perform testing of API. Some things you want to consider when testing API. So you want to make sure you do endpoint testing, right? So you want to verify that the API endpoints are accessible and respond with the correct HTTP status codes. For example, 200 is okay, 404 no found, 500 internal server error. You want to test different HTTP methods such as get, post, put, delete that are supported by each endpoint. You want to also verify request and response. That means that you want to make sure that parameters, headers, request body, response body, everything's correctly formatted, right? You want to verify the response contains the expected data and it's formatted correctly. You also want to verify that authentication is proper. So test various authentication methods to ensure secure access. Verify that unauthorized requests are properly rejected with the correct status code. So, for example, 401 unauthorized. And you also want to verify that error handling is implemented. So you want to test error scenarios by providing invalid input or triggering error conditions. Verify that error responses include error messages and appropriate status codes. So in this video, I'll guide you through the process of initiating API tests using Postman, building upon existing collections, right? We're going to use templates. Don't forget to check out other templates, especially in the roles quality engineer section for more insights. Remember, repetition is the key to mastery. Take the time to play with the application, experiment, and iterate through the process. Each repetition brings you closer to understanding how to use Postman, so just spend some time with the app. There are some websites I'm going to use in the video. You can see them on the screen, but they're also going to be available in the description for the video. All right, so check out the description and let's get into the Postman. In the last video, we did request to who am I. This is from developermozilla.org, and we got back country. We created verification for the status code 200, and we added verification that we're actually getting back United States in the response, in the body of the response. Okay. So in real life, when you will start working with an API and verification of API, most likely there will be an authorization that will be required in order for you to work with the API. So you have to log in, kind of a thing, right? The authorization might be provided here in the header, or it can be specifically provided here in the authorization tab. Now, for example, on this web page, there's a login form. So I'll have all the links in the description for the web pages. So here we have a login form. Let's say we're on a real website. This is like a test website, so it's not going to generate an access token for us. But if we were on a real website and I would provide like username and a password, this credential is going to get sent to the server. Server will verify the credentials are legit, and then the response will come back with the token. Now, next time when I'm on the page, I don't have to log in anymore unless I got like timed out or lagged out. The token that was provided by the server will be used to access all the functionality, right? So this is the same thing with the API. You can actually grab that token and use it in the API. Now this page is like a test page. There's no actual token here. It's just HTML. But if we go to this page, and I'll have this in the description as well. So this one is actually generates a token, but for a different reason. I think it's generating token to track each user that accesses the page to create like sales lead. But if I'll do a refresh, you can see there's a bunch of requests coming, and one of them is track right here. So track has a token, this right here, bearer, authorization bearer, and then this whole thing is a token. So at work, when you will be testing, you can log in the UI, and then you'll get a token, authorization token in response, and use that token. Or there might be some other forms, right? So if we use a bearer token, I'll just paste the token here, and now I can use this token to log in if I'm at work, right? Some other types of login that you might have is like basic authentication. So you just provide like a username and password to log into your app, right? So like test, whatever that might be, right? Or that could be API key. So like a specific API key that allows you to access the API. So in order to get the access, you'll have to talk with your development team or with other testers, with QA manager to understand how actually you get access to your API. Okay, so with that being done, let's move along a little bit into our testing. So we got our first collection. Now we're going to add some more stuff, and we're going to hit on this little plus, go to view more templates, and over here, let's click on all templates, and we have a regression testing. Okay, so let's click on the regression testing. We can use this template, and it loaded. We got a new collection created. You can see there's a bunch of requests here. So we have our status code verification. One thing that you might notice, there is this link. There's no full link here. In the new generated request, it says get, and then there's base URL. So this comes with the collection. This variable, it comes with the collection on the collection level. Why is it done? So you don't have to retype it. You can use variables in Postman as well. So behind this variable, there's actual value in the collection scope, right? So if we right click it, we'll go to edit. There's okay, so collection details, there's like variables here. So you can see this base URL variable stores this link. So every time you don't have to type the link, you can use this variable here in the request, okay? So same thing though, it's just a request to a specific URL. Now the only reason why we have a variable here because this collection comes with it, okay? So I'm doing a request. So this request goes to http postman echo.com/get, and I got a response back from Postman. So there's some headers, this is the response, and there's some verification happening. So we have a test that verifies status code. Here's another example. So here we're doing post. So we actually, with this test, we're passing along all of this information and we create something. So post means this request is creating something, right? If I'll send it, I'm creating a user and I get a response that user was created. And in the test, now we see a little bit different verification. We see a schema verification. So schema verification is essentially verifying the contract. And what it means is this data, for example, type of this value is array. So like collection of things, right? In this particular case, items. And then now what kind of items are there? So properties like title. Is this data type of this property is a string? Yes, that means text. So that's not a way of testing. So you don't directly verify information. You verify how it's stored. Is it properly stored, right? Now, or format of it. Now, here's a request that we're interested in. So post custom response validation. So let's click on that. So here we're also sending a creation request of one user or one book here. Let's run it. But in the response, we have a bunch of tests running. So we have verification that the title property exists, so this thing, that the author property exists, this thing, that it is published, it is exists, right? Property. Then the data type of this value. So this is a string, so that means text right here. Title is text. Here's author right here. Author is also the string, which means text. Here's published. Type is number. And then here's another test here. So correct details. We're verifying that title is actually equal to Sapiens right here. Author is actually equal to Yuval Noah Harari right here. The actual value for published is 2011. So now what we want to do, I'm going to use all this and we're going to just test some other stuff together based on the test created right here. So hit in the corner on this menu right here and select File, New Postman window. Okay, so this will open another Postman window. So we have two windows now. So this here we have our response validation, all the tests that came with it. In here, we're gonna add another collection. So create new collection, more templates. Let's get all templates. And over here, let's go to human resources, payroll API, use template. All right, so now the template create. This one doesn't have any tests, but it's actually, it's pretty kind of fairly simple to understand what's going on here. So here's one request that gets all employees, right? And we get all the employees information coming back. And here's another request, get an employee detail. So based on the employee ID, which is passed on here as part of the variables, right? At the bottom, we get details about only one employee. So let's send it. Okay, and we're getting back employee 1, John Doe, and so on. All this information coming back. But there are no tests. So let's create very similar tests based on this example right here. So very first thing that is being done here, we're getting get data variable, and there's a function that just gets response JSON. So it gets all of the body first, right? And then it goes into that data. So it gets just this back. So this little piece of information is stored in this variable. And then it's passed along in each test. So let's do this. Let's create a test script. So let's say, what are we going to get back? An employee, right? Const, or let's do a response. Let's name it response. So const response equals, and here we have an example of code how we get the whole body. So pm response.json without the .data, because .data is this little part, right? So we don't need that data because we don't have any .data here. So we're gonna just get the whole object back, the whole response body. Okay, so let's see if it's actually being passed along. So let's do console log response. So this response will get into the console. At the bottom, we have a little console right here. Let's click on that. We have everything that's going on. Let's clear it and send a request. Okay, so what happened now, this code ran. So it printed out in the console did this response. You can see there's ID, everything's here. Okay, so we were able to store response in this variable, and we were able to verify that it's actually stored. We printed it out. Perfect. Now we don't. We can leave it. It's fine. We don't have to delete it. So let's just have the console is good for debugging, right? So let's start with the first test. So first set of tests, we're verifying the actual object. So PM test return a book object. So we're not actually returning a book object, right? What we're looking at right now is a patient. So is it patient? No, an employee, right? An employee object. We don't need to use const data get data because there's no, this function does exist. This variable is not here. We're using response, right? So we don't need this. We stored everything in this variable response. Okay. What we can do, so PM expect response. We don't have data anymore, right? Response to have property ID, right? So that's going to be this property. I think we can, okay, I'm going to delete the other test for now. And then check the value of the expected type. So let's also do this. So PM expect response dot ID. So because it is in quotes, you can see it means it's a string, to be a string. So two tests. We're going to verify that it exists, the ID property exists, this thing, and it is a string. Run it. Okay, our test pass. So we verified within the employee object a couple things here. So we verified that the property ID exists and verified that the ID is a string. All right, let's take a look at our other properties that's coming back. So we have a name here, right? So we can, next one, I highlight the whole thing, press Control C to copy, go next line, press Control V to paste. Okay, now we're not going to verify ID. Next one is name, right? So we can put name here, and name is also a string, right? So response.name is a string. Yep, still passes. Everything looks good. Now we can add, let's see what's here, an email. So expect response to have property email, right? Okay, does have it. And email to be also a string, right? So you can see how you can go line by line, everything here, and just verify it. So let's add a property job title, and then job title here is also a string. Okay, so now there's a little bit of a thing happening. We have a salary. So let's expect that we have a salary in response, but what kind of type is it? Salary doesn't have quotes, so the data type here is a number, right? Number. Okay, and that would be response.salary, right? Let's run it. Okay, number is not defined. Okay, we had over here. So what was the data type that we were looking at in this PM test? Okay, number. Okay, it is number. So why it aired out? Well, because number, it's because it didn't have any strings, any quotes around it, it actually thought it is a variable like this one, right? This is a variable, and it has some information stored in it, and it said, okay, there's no such variable. It's not defined. It doesn't exist. So we need to put it also in quotes, so it knows that we're actually saying, okay, it's actual number data type, not a variable. Okay, run it. Okay, it passes, so it is a number. What if I'll put string here, right? For example, same thing that we had before. Run it. Okay, expected 5,000 to be a string, but it's not a string, right? Because the data type is a number that comes back. So we're actually making sure that assertion is working as expected. Okay, so we verified a lot of things here. Now there's deductions. So how can I verify deductions, right? Well, that's interesting. Well, in order to verify deductions, I can dive deeper. I can say const deductions actions is equal, so response dot deductions, right? And let's print it into the console. Let's open the console, clear it out, run it one more time. Okay, so uh, there are two things here, right? There's the first deduction and the second deduction. Two deductions, one is tax, the other is insurance. All right, so two objects in this array, right? So what we're going to do, let's verify. So we can say, let's verify the first one. So PM expect, and PM means like Postman, right? Postman expect deductions, and we need to provide which one, the first one or the second one. So in programming, we start counting with 0, not with 1. So 0 is the first number. So deduction 0 to have property deduction ID. And then same thing here. So expect deductions dot 0 dot deduction ID to be a string. So this value is a text value. Let's run it. Okay, still passing, right? Looks good. Same thing for the name, for the amount. Let's say we want to verify this deduction ID, the second one, that it also is there. So we can say PM expect deductions. Now instead of 0, instead of going in here, we need to say 1. You see this little 1 right here? So deduction 1 to have property deduction ID, and deductions 1 deduction ID to be a string. Run it. Okay, everything looks good. Everything's passing. We have some other things if you want to add it by yourself, like the other properties. So like in deductions, if you want to add name tax and the amount, you want to do that, yeah, you can. So this returns an employee object. So we verified that employee object returned, we verified properties, we verified the types. Okay, so let's minimize this. So what is the second thing that we can run? The second test that we can kind of copy and work on is verifying that the data that is inside is correct. So return correct details for employee one, right? Employee one. Okay. So how we do that? We have a response already stored, so let me close the console. So response is stored. We all using this. We're still referring to, we can use this variable, right? It defined at the very top. So we don't need this one. We already have response stored in here. Expect values are present. So PM expect response dot ID right? That's going to be our first one. And what is our ID? Employee 1. What if I'll put employee 2 here? And run it. Test 1 test fails. Correct. Details for employee 1. Assertion error. Expected employee 1 to equal employee 2. So it says, I expected this to be equal to this, but it's not. So it failed, right? What do we need to do? Let's update our test. So employee 1. Run it. Passing. Perfect. What else can we do? Same thing. Like we're just following along. The next property is name, right? John Doe. Let's do John Doe right here. Run it. Okay, still passing. Then email. Email. johndoeexample.com. Okay, good. Job title, salary, all of that stuff we can add. So let's do salary 5,000. Response.salary to equal 5,000. So 5,000, it's not a text, right? It's a number. So you don't have to have quotes around it. You see there's no quotes here, so you don't have quotes here. Okay, great. So what about deductions? So a very similar thing, like we got into deductions right here through this variable, we can do the same thing. We can say PM expect deductions dot, so we have to provide which one, first one or the second. So let's say the first one. The amount is 1,000 right here. Run it. Pass, right? So let's verify second deduction. So the second deduction, the amount is 500. This is for insurance. So what if I'll do 600? Run it. And you see one test failed. Expected 500 to be equal 600. So we need to update this to 500. Okay. Here we go. All right. So this is how you start building your tests, right? There, we can add more verifications here. We can add where so status code is 200. Another test, right? We can check other things like response time less than 200 milliseconds. We can see that the response time here is 210. So let's do 200 less than 200. Run it. Okay, this fails because we see that our response time is 203 milliseconds, but we expect less than 200. So like, let's say you're pretty fast. API is pretty fast. So this takes a little bit longer than we expect. So let's bump it up to 1,000. So 1 second, at least within 1 second, we should get our response back. All right, perfect. So we have all those like blocks of tests running. Now, every time this is executed, the test is going to run and you'll see if it's passing or not. So you start building up your collection like that, right? Adding more data, more data, more data. Then you can actually automate stuff, right? So your collections, you can run the tests and have a test runner. But I think we're going to get into that next time. So we kind of covered a lot. What we're going to do next time, there is a web page called recres.in. It's online. It's a public API. So it has all of those requests and what kind of response it provides. There's different, so like get, post, put, patch, different requests, right? You can get data, you can create data, you can update it, you can delete data. So this is like following an API documentation. What's going to happen at your work, you're going to have some sort of API documentation. This API documentation will tell you what requests are available, what data is expected based on those requests, right? What kind of responses you can get. So you will be looking at the API doc, you will be creating the tests based on it, and you will be verifying that correct data types, correct responses are coming back. So we're going to do this in the next video. I think we covered a lot. And I will show you how to create kind of based on this web page. Again, this is going to be in the description. Based on this web page, we will create another collection. We will just start hitting this endpoint, getting this data back, verifying it, and we also will create like an automation runner. So how you can execute it, your automation in the Postman, right? So you don't have to run it manually every time, or you can just launch it. It's going to run the whole collection. Okay. That's it. Leave a like if you liked the video. Subscribe for more. Um, this was Alex USA Days. Thanks for watching and bye bye. Hey everyone, this is Alex USA Days. So today we're getting into advanced API testing with Postman and a little bit of automation. Those are examples that you can practice along the way with me. You can just pause the video and type things out, and then it's gonna give you like a general understanding on how to build and structure your collection and tests when you will be testing your API. So we covered a lot. This is actually last video in section 9, API testing, and the next section we're gonna get into automation introduction. Now, Postman automation, when you test API, you don't test it just randomly, right? You test against the documentation that will be provided by your company. So when conducting API testing, it is common to refer to the API documentation. It's advisable to coordinate with your team to obtain access to the API documentation. Swagger is a service commonly employed for API visualization. It can conveniently function as a plugin within your integrated development environment. The link to Swagger, I have it in the description, and also you'll have it here in the slide. Now, Postman has a way of organizing your requests into collections. So you should organize your API and test into runnable collections. We will see an example of this happening in the following in this video. So there's also something called Postman environment, and we will be setting Postman environments today. Postman supports the use of environments which are sets of key value pairs. This is useful for managing different configurations such as development, testing, and production environments. Postman also allows you to set variables. So Postman variables can be reused across requests, can be used in different environments. This is helpful for dynamic values such as authentication tokens or dynamic parameters. There's also a doc I have in the description and reference here in the file where that will allow you to actually have dynamically generated variables for your requests. And we're also going to talk about Postman prerequisite script. So in Postman, a prerequisite script, often referred to as pre-request script, it's a script that is executed before the actual HTTP request is sent. The script allows you to perform actions or set up conditions that should be met before the request is made. It is written in JavaScript and can access various variables and functionalities provided by Postman. And we're going to take a look in the end at the Postman collection run. Postman Collection Runner is a feature in Postman that allows you to run a collection of API requests in a specific sequence. It's a powerful tool for automating the execution of multiple requests and testing the functionality of an API across different scenarios. Also, during the video, I'll give you an example on how to generate schema based on the response body and how to validate that schema in your testing. All right, let's get right into it. During the previous video, we did create a bunch of tests for regression testing. We copied some from the payroll API collection. Now, today we're going to get a little bit closer to the work environment. So at work, you're not going to be testing some random API. At work, you will have an actual API that your company uses. This API will have documentation, and you will be testing against that documentation. Now, we're going to work with recres.in webpage. It has an API available that we can use in Postman. And when you're going to be doing API testing at your job, you will take your API file that describes the doc file and probably going to open it with a Swagger or some other tool where it will show you what the API endpoints are, what kind of requests you can do, what kind of response is going to look similar to this. So you'll have to ask your developers where's the API documentation, how you can look into it in order to start testing API. You will be testing against the documentation. So if there is some discrepancies in what API does versus what documentation says, you bring attention to that. You might need to file a bug or talk with a developer or a project manager and so on. Okay, so at this page, just go and follow to recres.in and you'll see a bunch of APIs. So we're going to take a little bit of APIs here. Maybe let's take 4 different methods like get, post, put, and delete. So if I'll click on this, I can open a new link. So here is the link for this request specific. So this request, and it shows what it will do, right? It will get a response of a single user. So let's grab this endpoint. Let's go to Postman. We're going to click and create a blank collection. So let's name this collection as request response. You need to provide a URL for the request. So in our case, it's going to be recres.in API users and user number 2. Let's save it and send the request out. Perfect. So we got a first request and the response from that request, and we got status OK. So we can add some tests here. We can verify that indeed status is 200. We also need to get some data. We need to get this response back and verify some of the data that's coming in, right? Okay, so we can say JSON data from the response. Let's get the JSON, this response, and verify users data, something like that, right? So here we're expecting a JSON data dot data, and then over here dot ID to be equal to 2. So this is what we're requesting, right? What else can we add here? So we can add all of that. So email, that particular email, name. So pretty much just going to go line by line, verifying here all of the values, right? Last name, Weaver, and then avatar. Okay, so what else we're looking at? So we can verify here the support right here. So we verified inside data, let's verify inside support. So instead of data, let's do support and then URL. So this is the URL. And then text. Now you can break your tests as you want. You can have like per one test case, one particular verification of a response, some data that's coming back. You can verify data types per test. So however you want to structure it, it's up to you. You can use this as an example or just find some other examples online. You can talk with developers, or maybe if there is already something in place, you just follow along whatever is used in the company and just structure it the same way. Okay, so let's save it, run a request, everything passed. So user data is correct, status code is correct. Perfect. Also, let's name our request. So a single user. So the request that we're doing now, we're getting a single user, right? So let's rename this and name it single So let's do get single user. Okay, send it out. Perfect. So we got one test in, okay, or we're verifying one response, one endpoint. What if I'll do user 3 here? If I'll run user 3, now some of the values are starting to fail. You can see that we expected user to be equal to 2. This is our test right here, but we actually got user 3 back. And it didn't even go to any other tests. So it didn't even say, the email is wrong, the first name is wrong. As soon as it failed on one of the values, it pretty much failed the whole test. This whole thing just failed, was the first error coming up. So if I'll update this, you will see now it goes to the next error and so on. Okay, so but we're still going to work with user number 2. Okay, so what else we can do? Remember we had a schema validation before, so there was an example of a schema. What kind of data types and how it should be structured, what should be coming back. You will be able to look in documentation and see what data type is expected. You will be able to see if the fields are required or not, and so on. But what we also can do with our single user, because the structure for each user, the layout and the response body going to be the same, it doesn't matter which user we take, we also can add a schema validation, right? So here in schema response validation, we know that we need some place where we need to store schema. So let's just grab this as a placeholder, put it at the very top. Okay, so this is going to be our schema. So how do we get a schema for this response, right? You can grab the whole response, then go to free online JSON to JSON schema converter, or you can grab your schema from your API docs, but I can just paste this here. Not robot, generate schema, and the whole schema generated. Now you'll see a bunch of values that marks as required. So whatever your API doc says should be required. You should verify that it is required. So let's grab now this schema. Let's place it back here. Okay. So one thing that we don't need is this first line that says schema. So starts with type object and everything goes in. Now the next step, what we need to do is we want to get a test that verifies schema, right? So let's add this test right here. So response matches JSON schema. The response to have JSON schema, expected schema. So expected schema is stored in this variable, and then JSON schema is going to be taken, generated by Postman based on your response. Let's run it, and the schema passes. Now, if I'll comment out this user verification, okay, so I commented everything by pressing Control/, highlighted the whole line, Control/, everything's commented out, so the code is not going to be used. So everything commented out. Now, if I'll change user to 3 now, so I'll get a different user back, ran it, and it still passes. Why does it still pass, right? Because the schema that we're testing against is going to be the same for each response. Doesn't matter which user we're getting back, it's still going to match the schema that we're testing against, right? So some of the tests you can structure against specific data, other tests you can structure against the schema, making sure that all responses validate to that schema. Okay, let's update this back to user number 2, send it out, perfect. Now let's grab something else. Let's grab a different request. So let's get post. So this will create a user, right? So we can just grab the link that we already have here. So we can right click, duplicate. This will be different. We will be doing post create user. So change this to post, and the endpoint API users, just API users. So API users, just like that. Now, one thing that you need to provide, and we can delete all of the tests that we have here. One of the things that you need to provide in this request is a body. You can't create a user if you don't have a body, right? So if I'll send this out, it just gave an ID without any first name, last name. Based on documentation, we need to provide name and a job. So let's add a body. So we can click row, then what kind of body we're providing, JSON, and we can paste this here. All right, perfect. So a user was created. Now, one thing that you can do in Postman, you can have dynamic variables. So every time you run a request, the dynamic variable will be run. Let's do dynamic variables, Postman for name. Okay, there's a good bunch. I'll provide this link in the description. So there's a good bunch of dynamic variables that you can have. And this is how it can be used. So let's grab random first name. Okay, so name, and we're going to have a random first name, and you have to include it in double parentheses like this. All right, so now if I'll run it, every time you can see it generates a random response. So different names on each request. Perfect. So over here in the tests, we still can add, so 201. So the status code is different now. It's 201 for a created user. So let's add 201. And since the name is different every time, so we can't really, verify unless we pass a specific name. Right now, it's going to be randomly generated. So for that, we can just verify a specific data type, right? So how we had it here. So here we had a data type validation. So let's just grab this. So returns name as a string. We would need to grab response body. So JSON data and just a string, right? So what do we get? JSON data, and then dot name to be a string. Let's run it. Okay, so one thing that we need to update, we updated in test name that status code is 201, but we didn't update it in the test case. So let's update it, run it again. Perfect. So what else we can verify? So we verified the name is there and it's a string. The next thing that we're getting back is job, and job is always the same, so it's always leader. Kind of similar thing that we already did here. We can just grab this, copy and paste it. And JSON data dot job is equal to leader. So in quotes leader. ID will be different all the time, and time step will be different. Okay, perfect. So this is working as intended. And the last one, let's add a deletion. So the last one will be, let's add a delete. So 204 will get any response. And then same endpoint for the same user, number 2, but we're just deleting it. So duplicate. Let's rename this. Delete user update request from post to delete. And then you have to provide user. There's no body for the delete. Right, save it. And the only thing that we need to confirm, like let's say 204, right? So it's actually deleted. So let's run it. Okay, 204, we get no content response. It is there. So we're good. Okay, so we created like a bunch of tests here, a bunch of requests with different tests. We can add more. We can think about other scenarios. So you can see how you start building a collection based on your API documentation, right? One thing that you also might want to consider is adding an environment. Configure different environments, and you can have variables that correspond with those environments, and it is going to be a lot easier for you to switch between like development, production, and test. You can have one collection, multiple environments. So we can add a new environment. So let's add, for example, there's a global that can be used by everyone. For global environments, for example, here HTTPS is going to be our protocol, right? So we can set it as a variable, set new variable, let's say protocol. There's HTTP or HTTPS, and then the scope. So if we're going to do it in the global scope, anywhere this variable is used, it will be understood. It doesn't matter what environment you're in, if it's in the global level, your request will talk with that environment, with this variable. So it knows HTTPS is behind this variable. So if I'll hover over it, you see HTTPS. It's still going to work, right? Now let's create a variable for ID. So ID, right? Now for the ID, let's actually set it like this, set as a variable. Set new variable, so ID, and then let's have different scope. For, okay, we did not create an environment yet, so let's create an environment first. So add environment, and let's call it test. Okay, and also let's add another environment and call it dev. Right, so we got two environments now set. So for this single user, we can also set the ID as a variable. Set as new variable, name ID, and we can have a specific scope. So it doesn't allow us to select on the environment level because no active environment selected. So let's change the environment to test. Okay, so highlighted, set as a variable, set new variable, ID, select scope, test. Okay, so now in test, we see it's always going to be value number 2 set here. So if I run it, we get our 2. But if let's say I'm in dev, I can in dev also add a variable ID, and I can say the current value is 3. Okay, save it. So what will happen now when I switch between environments? In test, it's 2. If I go to dev, it's actually 3. So based on the environments, you can configure your test to run in different environments with different variables to have different outcomes, right? Now, if I run it in dev, it will fail, right? Starting failing on the ID that comes back. So instead of 2, we get 3 back, and it's failing the test. So if we switch from dev to test environment, run it again, we're looking good. Okay, so one more thing that is available to us, it is a prerequisite script. So this is more of kind of, a development thing here, so closer to automation, but you can actually execute scripts before you get into tests. And those scripts can be different things like getting a specific token back or setting some variables, generating numbers, and so on. So in the prerequisite script, let's set a different global variable. Let's set a name, right? Let's actually go to the post, go to in prerequisite scripts. So here we send job out as a leader. So actually, in prerequisite scripts, let's create a collection variable that will be used here in the body. Instead of leader, we'll place something else into the script. So set a collection variable. So PM collection variable key, and variable value. So let's call it job title, and let's set it to QA engineer, right? Okay, so this variable was set. If I run it, and I'll go into the collection variables right here now, job title, QA engineer. So it was set using prerequisite script. So before it runs this request, it will run this script. Now in the body, we can actually now use this variable. Let's have a variable here. Job title. Need to use double parentheses. Okay, let's run it. And here it's using QA engineer. Just double parentheses and the variable inside. Okay, here we go, QA engineer. So this comes from a prerequisite script. The prerequisite script runs before the request. It creates a variable. All right, so with that being done, we looked at the environment variables. We looked at generating random values. We looked at prerequisite script and saving variables. We looked at different types of tests that we can do, and now we have this collection. So what would be a last step once you went through your documentation, you created your API tests based on your doc? Now you can actually run collection and do a collection run report. So if you see here, there is run a collection button. So like if you click on this hamburger menu, also if you want this collection to be at top, you can mark it as favorite. So it's going to be first. Run collection. It asks you for order and what request are we running. We can schedule runs in a specific environment. We can run manually. So let's run manually first. So one iteration, we're going to run it once, and then here we go. 3 tests passed, 3 tests passed, 1 test failed because we did not update our post. So go back to post tests. It was looking for a leader, but now we actually inserted the QA engineer. So let's update it to QA engineer, send it out. Okay, perfect. Let's run our collection again. Okay, here's our report. So 7 tests pass. Everything looks good. Iteration environment was test. How long it take to run? 1 second. 138 milliseconds. All tests. Response time. Average response time here. Okay. You can view summary of the run. So like, I guess visually it's easier to read the summary here. And also if needed, when you run collection, you can also do scheduled run, right? Daily, let's say daily, or every day, right? Every day at whatever time you want to run it at 7 a.m. So before work starts in a test environment, you run it one time, and then you'll get an email notification if to your account email, and you can schedule the run. So now when it's going to run, whatever email was associated to your account here when you were signing up for Postman, you'll get the report once it runs to your email with the results. Okay, so there is automation you can actually build in, easy kind of automation that you have here with Postman when you test API. Okay, so that's it. Hopefully this video was helpful. This was Alex USA Days. Thanks for watching and subscribe for more, and bye bye. Hello everyone, this is Alex USA Days. So here we are starting automation introduction. Now, even though this course is about manual QA, you will have some hands-on practice writing automation with one of the most modern tools for web automation called Playwright. So we're going to do installation, we're going to do simple automations, and if you like it, that means you actually can start moving on and progress in automation, not only doing manual. So if you actually try and do it and it will work out for you, that means you can build upon it. Now I'm planning to record its own playlist on Playwright that will be more comprehensive, but here we will get a short introductory. Now we are already in module 10, so we're done with API testing using Postman in the previous video, and in this video we're going to do some things in order to get us going. So first we're going to install Node.js, and this is something that we need in order to run installation process on our machine. This is for Mac users and Windows users, same thing. There is a link in the slides. Also, link is available for download installation under the video description. Now, we're also going to install Visual Studio Code, and this is actually pretty much like your source code editor where you will be working and creating the tests. Also, link is available here, and it is also both for Windows and for Macs, and it also is free. And after that, we're going to install Playwright. So Playwright is a modern automation tool that enables reliable end-to-end testing for modern web apps. It is cross-browser, it's cross-platform, it's cross-language, and it also can do auto-wait, so asynchronous testing is a lot more easier. Now, there are two links. One will be installation and documentation, which is playwright.dev. And the second link is their GitHub repository. If you know what it is, if you don't, it's fine. But this tool is actually is open source and done by Microsoft. So it's pretty cool. It is one of the fastest growing automation tools. And I think a couple of years down the road, it's going to be more popular than Selenium, and it's going to be pretty much everywhere. All right, so let's get going. Let's get started digging into automation. Now, all of the links that I'm showing here are going to be available in the description, so go and check them out. So to learn more about Playwright, you can go to playwright.dev. And using Playwright, you can do cross-browser automation. You can automate API. It's cross-platform. You can do a lot of things. It has auto wait. So for those of you that are just starting automation, you might not appreciate it. But if you've been doing automation for a while and you had to deal with asynchronous applications, like having auto wait is really a game changer. It is very lightweight. It is very fast. So it has a tool to record your code, your steps. You can generate code. It has a built-in inspector for the elements. It's very easy and it works in browser context. So it doesn't launch your browser, get connected to the driver. It works in the context. So it's very lightweight, really fast. Like I can be running tens of parallel tests across different browsers without any lack of performance. Now, Playwright supports multiple languages. You can see there's Node.js, Python, Java, .NET. So we're just going to do Node.js. And Playwright is supported by Microsoft. So here is their GitHub. I'm going to leave that link in the description as well. So before we get into the tool and we start doing anything, we need to install two things. We need to install Node.js and we need to install Visual Studio Code. Now you can do it on Mac, you can do it on Windows. Let's start with Node.js. Okay, here's the download. It's in progress. Download is almost complete. And then installation window comes up. So next, accept, next. Default installation folder is fine. Next. All of those things are auto-selected, so you don't have to add to pass anything. It's just gonna install everything. Okay, do it. If there are tools installation necessary, so sure, I'm agreeing to install the tools, and the installation process started. All right, so we installed Node. To check if your node is installed, I actually got a pop-up here was the installation. Okay, so some additional tools are being installed in the PowerShell. All right. Upgrading my Python version. That is fine. All right, so all other necessary packages were installed. Now, how do we check if the node was actually installed? So go into your search and type terminal. It will bring command prompt in Windows and terminal in Mac. Once you have your terminal available, the window, you want to type node-v, and you will see the version of the node coming up. So that means your node was successfully installed. Perfect. So after node installation, you want to install Visual Studio Code. So this is going to be our development environment where we create our tests and write our scenarios for verification automation. So let's do download. Okay, here we go. It's downloaded. Accept the terms. Next. Again, default path is fine. Next. Let's create desktop icon. Add to the path. Good. All right. Perfect. Install. Installation started. All right, great. So installation is done, and we can now launch Visual Studio Code. So this is how Visual Studio Code looks. It has some notes. Okay, let's exit out. Let's exit. In the welcome screen, you can actually start a new file, or we can open a new folder and then start a file. So let's do this. Create on a desktop a folder, USA days underscore Playwright. Okay, here we go. So now in Visual Studio Code, we can open folder, go to desktop, and then here's our USA days Playwright. So this is where we're going to work. This is going to be work directory, trust the authors. Okay, perfect. This is going to be directory where we're going to install the Playwright as a tool. So one of the learning curve that is kind of hard with auto automation tools like Selenium, or I mean, most of the older automation tools is actually getting the tool going. So you need to install the tool, you need to configure the environment. After environment configuration, you need to install drivers. Like this is really kind of hectic process that can get newly testers that go into automation discouraged because I mean it can take a little bit while to figure things out. Nothing like that is happening in Playwright. So Playwright has pretty comprehensive documentation in all the languages that it supports. So right now we're in Node.js and we can just hit get started. And here we are. It's very easy. So we have NPM. NPM comes with Node. So let's open a console in our IDE in this Visual Studio Code. So there's at the bottom, there's like little exclamation mark. You can click on that and it's going to bring up a whole set of tabs at the bottom. So you want to click on the terminal. Okay, here we are. This is our path. So in order to get started, very easy command, right? Install in Playwright. So just pretty much one line. That's it. All you need to do. So you want to say in the command line that opened up npm init Playwright, and then add the latest. Add latest. Okay, so it's going to install the latest version of the Playwright. Asking to download packages. Proceed. Okay, yes. Let's do yes. Here we go. Do we want to use TypeScript or JavaScript? Let's use JavaScript. Where we want to put our tests? In tests folder, sure. Are we adding GitHub? No, we're not adding GitHub right now. We're just going to add practice like with the basic installation, no GitHub, just some basic tests. Should you install browsers with Playwright? Yes, you should, because it's going to save you a lot of time. So true, let's press enter. Initialize the project. Okay, so our project is being initialized, install modules. Here we go, downloading. All right, so that's it. So everything is being installed right now, and there's even a test that you can immediately run. Okay, so let's run the test and see what happens. So to run the test, you can do npx playwright playwright test -- headed. Not npm. npx playwright test -- headed. Okay, so it's running 6 tests using 6 workers. So it is actually, because of the config right now, I believe it's doing multiple different browsers. Yeah. It ran actually in a bunch of different browsers really fast, so we don't want to do that. It auto generates report, so the report was generated. We also can take a look at the report, but let's change some things in the config. So it has a bunch of, so you see it has project major browsers, so WebKit, which is doing Safari, Firefox, all of that stuff. So in config and Playwright, we have projects, and with the projects, we have multiple browsers: Chromium, Firefox, WebKit. So we don't want Firefox, we don't want WebKit. So highlight those, press Control backslash or Command backslash. So this symbol, right, was your control to comment it out, and then save it, right? Press Control S or just save. Now let's do it one more time. Let's have the test running one more time, but not multiple of tests. Now it's just going to execute only in one browser, in Chrome, because that's only one thing that we have in the config. And so it doesn't close right after the test. We can say here await page dot pause. Right, so this will actually stop right here in the UI. The test execution will stop here for this particular test case. And then we will add another pause right here in the second. So there are 2 test cases. What it's going to do, let's see. So first test case will verify that the page has title, right? So it will go to this link, to actual link of the Playwright documentation, and then it will expect a title to contain substring Playwright. Okay, and then it will pause. So we'll have a pop-up window, and we can continue execution from that pop-up. The second test will also get to this page, and what it will do, it will verify that there is a link get started, and it will be clicked on right here in this line, and then it will verify that there is installation in the heading, and it should be visible, and then it will pause again. So one more time, we're doing npx playwright and then test, and put dash dash headed. So we want to actually see the browser coming up. One thing also in the config, let's do this. Playwright config file over here. It is doing parallel execution. So let's do a parallel test 1 undefined. Okay, so let's do just 1 HTML reporter. First retry. Okay, I think it looks good. This is fine. 2 retries. So we're executing npx playwright test in the console, right? Let's hit enter. Running 2 tests using 2 workers. Okay, so here is test 1 and it's paused. And then here is test 2 and it's paused. So I have 2 windows popping up. They are paused right now. And as soon as I hit next, it will verify the last step and it will close the application. Okay, fully parallel is true. So I don't want to right now, for an example video, I don't want to run tests in parallel. So here we're going to do false. We still have 1 worker, so I think it should launch 1 test 1 by 1. So let's try and run 1 more time. And here we have the first test showing up. So it has the test here, and here's our pause, right? It pauses right here. The line is highlighted on line 10, and the step right before. So expect page to have title Playwright. So if we're here on that page, we can right-click it and do inspect. And now we're in elements. So if I'll press here, Control F, I'll open a search. Let's type title. Title. And let's see specifically title tag, right? So when I'll hit continue, if I hit resume right here, it will actually continue the execution and it will go to the next test case. But if I want to, I can actually do record. I can hit record and I can start clicking on other links. Let me click on something here. Let's go to getting started, test configuration. And now you can see all my actions are actually recorded right here. So I can also, using this pause method, I can actually do some additional steps and kind of add more to my test immediately, like really fast immediately. I can grab those, let's say, and go back to Visual Studio Code, tests, example, and add it right here, right after pause. So if I'll do Control C right now, it will stop the test, terminate batch job, yes, and let's start one more time. So npx playwright test, had it, and let's take a look. Okay, so here's the page. Let's load it up. We did not see any of the action happening because the pause was after the whole action was too fast. So let's do it one more time. Control C to stop the test. Terminate, yes. Saved it. Okay, file save, and let's run one more time. npx playwright test dash dash headed. Okay, so first it already asserted that it has title playwright. Here's this window, execution, the pause window. Now we can do next step over. Okay, so get by text cross browser click. So it just clicked on cross browser, and right, you see it's highlighted. Then I can do another next step over. It's going down and clicking on getting started. Next step. We're in getting started, and then it's clicking on test configuration. So as fast as like that, you can just start immediately creating tests. Very easy to install, very easy to set up. We're gonna do additional videos aside from that on more like creating some tests with Playwright. But here is the second test kicking off. So after the first one is complete, again, we're in this window. So what did it do? The test went to the page playwright.dev. So then it went to link get started. It clicked on the get started link, and then it verified that in the heading there's name installation. Okay, let's terminate this last job. So now we're gonna remove those. So we go into tests, example spec. We're gonna remove those pauses, remove, so it doesn't stop. Again, save with Control S or file save, and then execute one more time. npx playwright test headed. All right, here it is. 1, 2. So it's open in another window, but you can see it's pretty fast. The test runs pretty fast because it's a short test. Okay. So this is it. We just installed Playwright and did some execution of our beginning tests. Next video, we're going to get a little bit more into automation with Playwright. Hopefully you enjoyed this video. Leave a like and subscribe if you did. And check out more on my videos on QA. Thank you. Bye-bye. Hello everyone, this is Alex USA Days. So today we're continuing with Playwright automation. Now this is going to be last video in module 10, so automation introduction. After that we're going to move into mobile testing. Now in the previous video we did some Playwright installation. We did run the test that was provided by the Playwright. Today we're going to focus on generating Playwright code using CodeGen, and then actually retyping this code ourselves and kind of creating the script ourselves. Now, this is very important. The video is not about manual testing. This is introduction to Playwright, but I want you to get started now. Playwright as a tool gets very popular. I think a couple years down the road, it's going to be more popular than Selenium because it's very easy to install, configure, get started with it. So please take time with this video. If something is unclear, pause it. Take notes, rewatch fragments, slow it down. Kind of follow along, make sure that you are following along, typing things out. Now, if you don't understand something, that's completely fine. If you're going to repeat it a couple times, it's going to become more clear. Always also spend some time on your own to do additional research, try things out, read about it. Okay, so we will start with Playwright CodeGen. So we will use Playwright CodeGen to create automation test case. This is done with this command npx playwright CodeGen. The HTML structure, we're going to go then into actually creating our own locators, or grabbing locators by ourselves that are based on HTML structure. And a lot of people kind of confuse, okay, when I never worked with automation, how do I grab an element, right? So the general structure of HTML, you'll have an opening tag. Then within that tag, within the opening tag, you'll have an attribute, and then you will have a value assigned to that attribute. Then you'll have some content that is displayed to the user, and then you'll have closing tab. So there are different ways to get to those locators based on this structure. You can use XPath, you can use CSS. So I'll show you different ways how to do that. Now, if that's too much for you, this is fine. You still can do CodeGen without getting any tags by yourself and using the tool that I provide to grab those elements, locators, right? Also, English is not my first language, so I always confuse names of some of the elements, so I'm gonna just provide them here. So there are parentheses, this is how they look. Then there are curly brackets, they are angle brackets, backslash. So if you're having trouble confusing those like I do, so here they are. In Playwright, you can use or get locators using different methods, right? You can do it by property. So here's an example of getting locator, and we're getting the same locator here, the same one, just different ways to do it. So by property, so ID equals username. So that would be your attribute ID, and then value that is within this attribute, right? So we're getting it by property. The second way would be by CSS. So here we have input, and then the input is a tag, and then username is your ID. So this this hashtag here It means that it is an ID. And then the last one is XPath. So you provide pass, //, then tag input, then you put at ID, and then you put value, username. Okay, it's 3 different ways to get the same element. Also, Playwright has built-in locators like this one, for example. So await page get by role. So role is button, and then within this button you have type, and the type is equal to submit. So that's another way to provide like more options to get those locators, right? Within the Playwright, and I'll have all the links for you available in the slides and under the video description. So here we have other different Playwright locators. So get by role, get by text, get by label, get by placeholder, get by alt text, get by title, get by test ID. Ideally, when you work with automation, you want your elements to be accessible and you want unique test identifications assigned to them. This is normally done by developers. So once you start getting into automation, this is something maybe you can discuss with your team. So the elements the automation interact with, it does have unique IDs assigned to them. All right, and some links that we're going to talk about in the video. So we'll test on this webpage, herokuapp.com login. I will show you the docs on the code gen. This one is selected Python for some reason, but just updated to JavaScript for the view for display. Here's doc for the locators. I recommend reading intro to HTML right here to understand a little bit more about tags, about properties, about locators in general. There will be a link to XPath cheat sheet, so you can kind of use that as reference if you need to type out your XPath. And same thing for CSS, right? If you're getting locators based on CSS, you can also use this cheat sheet. So if you don't know nothing about HTML or getting locators or anything like that, we will use in the video, we will use Ranorex Chrome plugin. Here's the link for installation, so you'll add it to your Chrome, and you can use that to grab locators. Just make sure they are unique for the element that you're looking at, and you can write your automation just using that. Okay, so let's get into it. So in the previous video with Playwright, we started the installation. We did install Playwright. We went through example tests. We did some pauses to analyze the code and to understand how it's executed. Now I'm going to tell you how you can actually start testing Playwright without knowing any code, just doing the recording. And then also we're going to create the same test manually to kind of see what it takes to actually start coding the test scripts, right? Now, again, this video is part of manual QA from scratch playlist. So I'm going to give you just information so you're aware of the Playwright tool. You have some understanding how to use it. I'm planning to create a whole playlist on Playwright on its own once I'm done with this course. So yeah, just subscribe, keep in touch, watch out for new videos. But this one, still, it will get you started. Playwright is becoming a very popular tool. And I believe, sometime down the road, maybe a couple of years, it's going to be even more popular than Selenium because of how good it is. All right, so the first thing that you want to do here, so we want to create new test file, right? So let's create new file and call it autogen .spec.js. Remember, if you're creating test file and you want it to be executable by Playwright, it has to have .spec part. So this is your code extension. .js is JavaScript, but you have to have .spec. Whatever you have, the name is fine, but it has to have .spec in order to be executable. Okay, so the file is created. Next thing, we want to type a command to start the code gen. So do npx playwright code gen. Okay, so we executed the code gen. It starts up, and you can see it brings up a window with the code and tab where you can start doing whatever is need to be done. So what I'm going to do is we will go to this page called the internetherokuapp.com login. There's login page right here, so you can enter username, password, login, and log into a page. So we can do that with automation, with the recording. You can have also the value inputs and assertions in here. Okay, so let's first thing we're gonna paste this link and press enter. And you can see immediately the first step is added. So wait, page go to, and here's the link. That's great. Now, what is the second thing we need to do? So click on the username, and we need to enter Tom Smith for the username. Okay, let's enter Tom Smith. Okay, and the next one we need to enter super secret password. Super secret password exclamation mark. Okay, let's click. I think I clicked somewhere by accident. It generated some, yeah, this click. Okay, we'll have to delete it, but that's okay. Now we're in this secure area. That means that we logged in. So now we can do assertion. So let's do assertion here. Let's make sure that we can assert text first. So this text, you see it's highlighted. I have the assert text available. I'll click on it. Confirm. And the next assertion we're going to do assert visibility. Let's assert that logout button is visible. Okay, and now we're done. So what I can do, I can just click copy here, copy the whole code, go back to the AutoGen spec, paste it here. And this is the code. This is the test, and it's ready to be run. Now, one thing that you want to do, first of all, in your Visual Studio Code, go to File and make sure the auto-save is selected. So it has to be check marked. Otherwise, you have to, every time you do a change, you have to save manually, or it will not get affected, right? Here in the terminal, let's do Control C to cancel, or Command C if you're on Mac to cancel the run. So double click it twice. And in order to execute only one test, because we also have example here, we need to do test.only. All right, and let's do npx Playwright, right, test, and do -- headed so we can see the action happening. A couple things here. We did do a misclick. Let's remove this misclick right here on line 9, or I did one. And also let's do a pause at the very beginning so we can kind of follow step by step on what's going on. So wait page dot pause. Okay, so now we added pause and we removed an extra line of code, and I think we're ready. So let's start the execution. Test.only will run only this test. No other tests will be run. So here we have the pause triggering. And here is our tab for execution. Now we can start stepping through the steps. So over here, step over. Okay, so we're going to the page, step over. Here's the page open. Now we clicked on the username. All right, now we're filling out with Tom Smith. Okay, next step we're filling out with the password. Right here, then we're clicking on the login button. Now we are in the secure area. Next step, we're verifying this text. And then the next step is verifying that the logout button is present. Okay, and that's it. So the test case is completed, and this was auto-generated. So if you don't know any coding at all, you can start doing your automation with AutoGen, with Playwright, and then kind of figure out how it works. Now, what we want to do now, let's actually try and manually create a test case, the same test case, but we're just going to do it manually, type it out by ourselves. Couple of things that I want to share. Now in the description, I will have a link to the test generator, the documentation here. I will have a link to the locators for the Playwright, because how you interact with elements, you have to create locators. I will have a link to HTML, introduction to HTML, so you need to understand a little bit how to create those locators. I will have a link to XPath cheat sheet, so you understand how you can create locators with XPath, and then CSS. Now, this is all just to kind of get you started. You don't have to learn it all right away, but just kind of as you dive in slowly in automation, you'll pick those things up. If you're very new and you don't know HTML, you don't know how this stuff works, what will be the best option for you to pick locators is to install a third-party tool. For example, locators, Ranorex. So you have to be in Google Chrome, and let's do plugin. You have to be in Google Chrome to install the plugin for Ranorex Velocity. Okay, here it is. I'm going to add it to Chrome, and I will show you, add extension. I will show you how you can grab locators using it. Okay, it has been added to the Chrome. Perfect. Over here, we want to pin it so it's visible. All right, so now, if I'll right-click on the field I'm trying to grab locator, you see there's selectors action. Now I can copy CSS or XPath to use. So if I'll copy CSS, here there is this styles tab. In here you can find another arrows here that probably needs another refresh. Let me reopen it, inspect maybe. Styles. Okay, so here's Ranorex Velocity. If I click on that, so I go to username, selectors action, copy CSS. I can paste it here. It's automatically pasted, right? And I can run it, task selector. You see it runs, it highlights the field, and it tells you, okay, here's this locator in CSS, one variant of it, another variant, here's an XPath, and there's only one of them. So if there's only one locator present, its locator is good to use. Have to be stable though. So within the Playwright, there are a couple things that you can use for locators. You can use built-in locators that are recommended. So there's get by role, get by text, get by label, get by placeholder, and so on. You can specifically use locators by property. You can use by CSS, and you can use by XPath. So as we go building this test case, I will show you some examples of each. So let's get started. So we will need a new file. Let's remove test.only. So, and we will create new file. So manual, let's call it manual gen.spec.js. Okay, so first thing, what you need to do to get started, you need to import the Playwright in here in this file. And there are two ways to do it. You can see there's import, first line here, that was auto-generated, import test and expect from Playwright test. So it will go to this folder, not modules. It will go to the Playwright test, and it will import Playwright from here. Another way to do it is in the example. So const test expect require Playwright. So require and import essentially, almost the same thing. The only difference here would be that import is newer and require is an older way to import things from node modules, right? So I prefer import. You can't have both of them, so I'm going to delete the first one. They're the same. Just if you see one or the other, know they do the same thing, right? I'm going to delete this line. So now, the very first line, I'm importing test and expect functionality from the Playwright module, all right? Okay, so what do we need to do now? Well, it starts with a test function, so test, and you open parentheses. Within the test function, you can start defining like what exactly you want to do and how you're going to do it. So let's first thing first, you have to provide a test case name. So let's name it verify login feature. And then you have to put a comma. It has to be in quotes, and then after the name of the test case, you put a comma. Okay, so that's the first step. Next, you need to provide a async keyword. So you can see it's right here. So the point behind this async keyword, your test JavaScript is asynchronous, so you don't have an order of execution. In order to have that order in place, it's mandatory you run your test with async await combination. So the reply is going to come in one by one, and async going to wait for it's like a promise return that will be returned from within the function. After async, you need to open parentheses, and you want to put curly braces inside, like this. Then we need to get back a page object. This is the one that will be executing all the actions on the page, what needs to happen, if you need to pause it, if you need to go to specific links, all of that. So this will be the way how you interact with the page, okay? And then after that, you want to provide here a function. So, but not just any function, it's called arrow function. So you put equal and angle bracket, so equal angle bracket, and you open curly braces like this. One thing that we're lacking, that we opened here, test is open, but we never closed this. So at the very end, you want to put another parentheses, just like this. Okay, so this is our like a blank test. Now we can start adding stuff inside of it. But you can see we initiated test function here. We provided test name, then we have a comma, then we have a sync keyword, then we have a page, and page has to be within curly brackets first and then within parentheses. Then we have an arrow function here, and within that function, within the arrow function, all the testing going to happen. Whatever needs to be done within the test will be inside. Okay, so the very first step that we're going to do, we want to go to the web page. So this, the internet herokuapp.com login. So we start with await keyword. So again, this is required. So if you have a page that you interact with the object page somewhere, you have to have await before it. So await page, and then go to. Now we need to provide where we're going. So within the quotes, we want to put the name of the page right here. Okay, perfect. Let's have a pause as the very first line so we can actually see how the execution is going. So await page dot pause. And for the test, so it's the only one that will run, so we'll do test only. Okay, so npx Playwright test and dash dash headed, so we can see the actual browser coming up. Okay, so here is the Playwright inspector. Here is the tab for automation. Currently it's paused. And let's go to this next step. So step over. All right, it's gonna enter this page, step over. Here's the page enters and test case ends. Perfect. So we're actually now going to the page. Now, some of you might ask, why is there a semicolon when it's auto-generated and I'm not doing any semicolon? So semicolon is not required. It's a matter of, if however you used to write your code. If you feel like you need a semicolon at the very end of your code line, that's fine. So if you feel comfortable without it, you don't have to have it at the end, whatever you prefer. Okay, so next thing what we need to do, now we're on the page, we need to click on the username, right? And then we will need to type in information. So to get the username, so there are 3 ways, or actually like 4 ways, how you can get the location of this element on the web page, right? So Playwright allows you to do by built-in locators. So all of those, and you can click on each one. You'll see a reference how it's done, or it can be done by property, or it can be done by CSS or XPath, right? If we do it, and I'll give you like a quick understanding of it. It's just a different way to reach the element. So if I'll do here this little arrow, select an element, I grab that arrow, I click on the field, it highlights in the body where the element and everything about it, like right here. The element starts with tag, so input is a tag, and then you have some properties. So here we have like opening tag and closing tag for the line. You can see it. And then we have within we have attribute and value. So input is opening tag here. And then type is attribute, text is value. Name is attribute, text is value. So you can reach to either of those in a different way. If you want to do it in CSS, you can say $, open parentheses, and within quotes here, let's provide some CSS to reach it. Okay, so let's reach it through ID, right? Username. So in CSS, if you have an ID, and here's CSS cheat sheet, to reach an ID, you have to have hashtag. So if I'll put over here hashtag and username, that's the ID, you see it's returning something. So I press enter in the console, and I can open up, expand it, and here it is highlighted. So that would be doing it with CSS. So it's just would be a different way to reach the element. Now through XPath in the console, you do $X. So for the XPath, you need to do something else. You can't just say, hey, here is ID, here's hashtag and name. So you have to provide like a path to actual element. So again, also in quotes. So let's do \\. Now I'm looking at this. It starts with the input tag, right? So I'll put input, and then within the input, it already gives me couple options here. But within the square brackets, I need to put at. And what is the element? What is the attribute? Let's say ID. Console at ID, and then equals to within the single quotes, because we have on the outside we have double quotes, and inside we have single quotes. We want to provide the actual property. So username. Okay, hit enter and expand it. So you can see we're reaching the same element. One is done through CSS, the other done through XPath. Now again, if it's too complex, right, you don't really need to get into that right now. You can get started by just select your actions, copy CSS. Over here in the elements, you go to RunnerX velocity tab, property, RunnerX velocity, paste it here, the copied CSS, test selector, and here it is highlighted. So you can use that. You can use that CSS, okay? Now within our test, we do await page, and then we need to provide locator. What is our locator? So the one that we copied. The one we copied, this is a CSS locator, and do dot click. So what it will do, it will click on that locator. And then now we have to type in the text. The last way how we can reach it that I didn't show is by property. So this is CSS, right? Over here, that would be XPath, same element. Let me have them all available. So XPath, that would be an XPath. And then the last way how you can reach it would be by property. So locator, to reach it by property in Playwright, you just need to say ID equals username. That would be by property. So 3 different ways how to get to the element. The most common that you will see with Playwright is probably CSS. And you can copy CSS with runner X velocity and just use it if it's the only one present. So if I'll go here, selector actions, copy CSS, and you see it's only one. There's no other instance, and it's pretty stable. It's not going to get updated by the developers. You can just use that. Okay. So 3 ways to reach the same element. Let's leave for the first one. I'm going to comment this code out. So 2 backslashes. It's coming out. It's ignored. We're going to reach it first by the property. Second time, we need to put some text in. So let's say await page.locator. And the second time, let's reach it by XPath. So I'm going to copy this. And we will do .fill. And we need to provide what are we filling in the test here. So we need the username, which would be Tom Smith. So let's do Tom Smith. Okay, perfect. Okay, let's run it and see if it's working. So head it. Here is our inspector. Step over. We're going to the Heroku app login. We're clicking on the field. We're providing Tom Smith. Okay, value. It's right here typed in, and that's it. So the next thing that we need to do is we need to go to the password field, right? So same thing. We need to provide await page. So we need to provide locator for the password. So here, it's expecting a locator for the password. So I'm going to open it up, just right click it, selector actions, copy CSS, then test selector. So there's only one CSS input password, or even just password. Either one will work. So input password means it provides tag first, and then the ID, and then hashtag password provides only ID. So either of them is valid. This one just is a little bit more details in the first one. It also tells you what the tag is in there. Either will work. So let's grab the second one just by the ID. And it's quite common when you will be working in automation that your selectors, developers will build in IDs for selectors that are unique for each selector, so you can rely on those IDs when you create automation. Okay, so here's our locator, .click, and we want to do the same thing here. We want to, into the password field, we want to fill in the password information, right? So the password information is super secret password. Perfect. The last thing that we need to do is we need to click on the button. So for the button click, we can go and say, okay, inspect or select our actions, copy CSS, and let's run it. So the CSS here doesn't really look that great. what .fa.fa-2x.fa sign in. So feels like that might get updated. XPath also seems a little bit, a little bit too long. What else we can do? Well, we can use the built-in locators, selectors, and one of them is by role. Locate by explicit accessibility attributes. Okay, let's click on that. Let's see an example. So by role checkbox, here's type checkbox, and then name is present, and then it says subscribe. Okay, we can use something similar. So let's grab this as an example from the document, put it in here, and let's update it. So our role, what is our role for this element? Let's take a look. So right click inspect, here's the element comes up. So the role here is button, right? Okay, so in our case, that would be a button. So let's type in button. What else it has? What can we rely on? In the example, it was relying on name subscribe. So attribute and attribute value. Attribute is name. The value of attribute is subscribe. Same thing how we had it here. So attribute and value of the attribute in the example. In our case, we have type attribute and value submit. So let's use that. So here, instead of the name, we will say type, and the value we'll have is submit. And the last step is not check. We're not checking anything, right? We're clicking on the button. Okay, and let's run it, head it, and see how it goes. Okay, here's our blank page. Here's inspector. So step over, go into the page, filling out Tom Smith, step over, filling out password. We're on the login button, and next step, we're clicking in. Okay, we're logged in. Perfect. Now let's add the same same validations that we had before or similar that we had in AutoGen. So we verified that it contains text, and we verified that the button logout button is visible right here. So let's do the same manually. In AutoGen, it did go to H4 contains text. Okay, as a locator. Let me see if I'll log in, if I can copy something meaningful as a locator with RunnerX. So log in, that's fine. Let's highlight the text. So selector, copy CSS, subheader. H4 class subheader, inner text, H4 inner text. Okay, I'm not sure. Let's just inspect it and look at the element itself. So H4 class, subheader, and then welcome, and the text. Interesting. So one of the ways how we can do it was built-in locators. They have locate by text content. Maybe we can try that instead. So go back to our manual gen. Let's do await page get by text, right? So get by text. Let's see some examples here. Okay, to be visible. And it already comes with an expect. So it's not only getting, it's also verifying. So I'm going to copy this example here so we have it in front of us. So get by text and the text value, then to be visible, and then we're actually doing expect on it. So our text value, if we're getting by text, should be here, this guy. Now, some of you might be wondering, like, should I be using double quotes or single quotes? It doesn't matter unless there is a single quote somewhere inside the text. So for example, if I would have a single quote opening and single quote closing here, that would be working fine until, let's say, I have a single quote somewhere in the text, like secured. And then what happens, the single close is actually closing the whole string, the whole text. So now it's broken. It doesn't know what all of this is. So to avoid this, you want to have double quotes on the outside, and then if there's a single quote present, it's going to treat it as a part of the text instead of cutting off your text. Okay, so we copied the text. We have it now here, get by text. We copied the text in. We want to put a couple things. We want it to be visible, but to be visible is part of the attachment for here. For expect. So here we have get by text, that's this. It has its own parentheses for the text values. You see parentheses open, parentheses closed, parentheses open, parentheses closed. Great. Then we have expect, and expect has also parentheses around it, right? Within the expect, we have all of this entered. So let's do expect, parentheses open, and then parentheses closed. And now something, what are we expecting? So the last part would be to be visible, dot to be visible. So this function is verifying that this text is actually visible. So this part will get the element by the text, and then this part will verify that it is visible. Okay, let me delete this. Let's take a look here. So we copied this text. It should be visible. Let's run it. Okay, so here we have it up, the page, the locators, inspector, next step, filling out username, filling out password, clicking login, highlights the text. You see it's right here at the bottom. This is the step we're in right now. So I'm click next. Is it visible? Yes, there's a check mark. So it is visible. Just verify that the text is there. It is visible. And then the next step, that's it. Great. One last step that we had in AutoGen is to verify the button is visible. It did it by role. So link logout is visible for the button. Let me go and inspect the button. So button, logout link, logout text. If I'll go right click it, selector actions, copy CSS. Here is that CSS copied, search for it. So again, this is not very great either with CSS or XPath. The locators doesn't seem too great. We could use the one that was used by AutoGen, which would be by role link, but I don't necessarily want to use a logout link as a reference as well. I just want to make sure that it is a button and it contains some sort of text. So we can do the last one with similar how we did here. So we were filling Tom Smith with a XPath. So we can do the button similar how we did in XPath selector here. So what we need to change, we don't need to fill. Let's get the locator. So let's get the locator, console, clear it out. Remember, so $X, and here is how the XPath will look. So first thing, if we look elements, let me bring the console here at the bottom. and we have the elements up top. Okay. So inspect it. Class button, class icon, and the logout text. So the logout text is actually within the I tag. So you see it's opening here, closing here. This is the tag, and this is the text. We can still search by this tag. So we can say \\I. So this is the I, and then within the square brackets, I can say contains open parentheses. So text also with parentheses at the end as a function, and then the text value that it contains, logout. Okay, it's provided something. Let's take a look here. Okay, it highlights the button. Okay, so this will verify by text that the I contains text logout. Tag I contains text logout. But if you want to have also making sure that it is a button based on the class button secondary radius, you can add this additionally. So it will look like this. It's going to be a longer locator, but \\A. So this tag A, then within the square brackets, add class. Here's the class, and then provide the class name button secondary radius right here within quotes, single quotes. Then again, \\I. So here's I, and then contains text logout. So that would be a longer version of this XPath. Maybe a little bit an overkill, but it also verifies it's not just the logout text within the I, but it also is here a link A with class button secondary radius. So there is no specifically button, so we cannot rely on that, but we kind of added class that says it's button, and we added text within it. So that should work. Okay, let's copy this. So page locator, and let's insert our locator. Remove extra quotes. Remove extra parentheses. Here's our locator. Now we want to put expect also open parentheses here, and the same thing to be visible. Okay, and let's run it. Okay, so next step. Okay, providing username, providing password, logging in, verify the text here, so that passed. We can see at the bottom. And let's see if the button is visible. And also verify that the button is visible. You see the green check mark here. Next step. Okay, and we're done. The test case is complete. So I know it might be a little bit overwhelming, like if you're starting the first time and you never did any coding, you don't know HTML, that might be a lot. So just stick to using CodeGen, right? But also as you go, keep on exploring, look at the XPath, look at the CSS selector, look at the locators provided by the Playwright, and kind of experiment with manually typing them out. That's going to help you because not everything can be done with CodeGen, and some things are going to be, changeable. You have to go in and do updates on the go when your application changes. So over time, you have to get used to actually to typing things out and to create more robust, stable tests that are not flaky, that not going to fail from time to time. Okay, so hopefully this video was helpful. Let me know if you have any suggestions. Leave a like, subscribe. This was Alex USA Days, and thank you. Hey everyone, this is Alex USA Days. So we're getting into mobile testing section. Now we already did a lot. We're at module 11 right now. And module 11 is unique in a way because we will have more of a discussion of mobile testing than a lot of hands-on. There will be a hands-on part with Android Studio, but still you might just want to watch it because mobile testing will be specific to the application and devices. So essentially a lot of things will be learned by you at work on how team is doing it and you will be following the process. Nevertheless, I'm going to give you an overall understanding of the process and some things that have to happen for you as a Q engineer in order to get into mobile testing, things that you should be knowing how to do. Okay, so first of all, you need to understand that there are different types of apps you can test on mobile devices. There are native apps, and they developed for a single platform, for example, Android specific or iOS specific, right? So they use platform specific languages. They ideal for high performance but require separate development efforts for each platform. Some examples of native apps are like Google Play Store app for Android, where you install other applications using that specific app, or let's say Apple native photo app where you on iOS where you take pictures and you go to the photo app. That would be like a native app specifically for iOS for your Apple device. Then there are hybrid or mixed mobile apps. They build with web technologies but run in a native container accessing some native features. So even though you install them through the store, for example, like Instagram, it's only a shell of a native app. Behind the scenes, there's a lot of web technologies, a lot of like API doing the call. So essentially, the background function of it might be the same or very similar across multiple platforms, right? So they built with web technologies but run in a native container accessing some native features. They provide balance between development speed and native features. They may have performance limitations for complex apps, and some example is Instagram is native shell for each platform, but behind the scenes we have web technologies and API. And the third type is mobile web app. So web apps are essentially websites that are optimized to function on mobile devices. They're accessed via web browser and don't need to be downloaded and installed on the device. For example, opening Facebook with your phone specific browser instead of an application. That would be an example of using mobile web app. Also, the specifics of testing as a mobile Q engineer, you will have to be aware of the latest mobile trends, operating systems, and devices, their popularity. Most popular devices will depend on the region and the product. I will have two links, some examples where you can read about the latest versions of Android and iOS. But again, most of the time it will be a team decision where do you focus your testing effort with mobile. Okay. Now, some specific of app installation for Apple devices. So you will have to have that IPA file, and it is an application archive that contains an iOS app. In simple words, it's a file that can be installed on iOS devices and used as an application. One of the methods of installing an application is using Xcode. That's a development environment used to create apps for iOS. You will have to connect iOS device to a Mac via USB. You'll have to open project in Xcode. You'll have to select connected device as a target in the top toolbar and then click on play button to build and run the app on the device. You can also test iOS devices using TestFlight. So this is a specific app on iOS Store, and you can upload the app to TestFlight via App Store Connect, add the email addresses of the testers in TestFlight. Testers will receive an invitation to download the app from TestFlight. Now, this is again will be mostly like a team effort. This has to be organized and structured, so you'll have like a team lead or a test lead that will help you throughout the process, right? And then ad hoc distribution. So you'll have to export the app as an ad hoc build from Xcode, distribute file.ipa to testers, then they will install it via iTunes or other tools like Apple Configurator. Okay, so there are different ways how you can actually install application on iPhone to test it. And then you'll have to be able to gather logs. You can definitely do like screen recording and just screenshots and email them to yourself as part of log gathering process, but there are other tools you can use as well. So you will need to gather logs and images, videos for bug reports and test reports, right? You can gather logs in Xcode, device and simulators window, or in console app, right? In Xcode, you'll have to go to Window, Devices and Simulators, and then select the connected device, and then logs will be under the device information. You can view and export logs from there. Or you can open your console app on Mac and then select the Connect iOS device from the sidebar to view its logs. You can also use third-party apps to intercept and analyze traffic, and I will be showing some of this later on, but you can use things like Charles Proxy, Fiddler to capture HTTP, HTTPS web traffic to do web and API testing, or you can use Wireshark to capture networking traffic and do troubleshooting. Now for Android, there's a little difference there, but you will have to enable developers mode on your Android device by going into settings, and then going into about phone, and then tapping on the build number 7 times. So you tap on the build number multiple times. It will show that you're enabled a developers mode. Then you can go into the settings, developer options, and then enable USB debugging. So if you have an Android device, you can see it for yourself on your Android device. Now, after that, you'll have to obtain Android package kit file of the app you need to test. So development team will usually provide this file, and then you'll have to put this file, this application, on your phone. So you'll have to connect your device to a computer where you have Android Debug Bridge installed. I have the link here for the ADB. So essentially, it's a special tool that allows you, your console and your computer, to communicate with your Android device that is connected to your computer via USB. And you can use following command to install the APK. So you can do ADB install and then just provide the path to your APK file. Or you can use Android Studio Code, and I will show you in the next video how we can use Android Studio Code. You can use Android Studio Code and test with emulator, right? For Android log gathering, you can do it through command prompt or a terminal using logcat. So you can type adb logcat to start capturing logs. You can filter the output or save it to a file with additional command line options. For example, you can save logs to a file using adb logcat-v time Android logs txt command that you see here in the file on the screen. Or you can use Android Studio for logs, right? You'll have to connect your device to your computer using USB cable. You'll have to launch Android Studio and open Logcat window. And you want to ensure that your device is selected in the drop-down menu of the Logcat window. You also want to filter log because Logcat output a lot of information, so you have to use filters to narrow down the logs to the relevant information for your app. You can filter by log level, like errors, warning, info, debug, verbose, and so on, or by a tag that your application uses in its log messages. You can also use third-party apps, and again, we'll have an example of that with Charles Proxy to intercept and analyze traffic. So Charles Proxy, Fiddler, they can be used for web traffic and API testing, or Wireshark can be used for networking troubleshooting. Now, what to focus on during mobile testing? There's a lot of things, right? So you can have functional behavior. So you want to verify all apps functionalities perform as expected. You can test user interface and experience, so assess that app's ease of use, design, and navigation. You want to verify compatibility, so check the app on different devices, operating system versions, and screen sizes. You want to check performance, so evaluate the app's speed and responsiveness, test for any lags or crashes. You want to verify battery usage, so monitor how the app consumes battery power during various operations. You might want to check for overheating and observe if the app causes the device to overheat during usage, right? You want to test networking speed, so you want to test how the app performs under different network conditions, connected to Wi-Fi, connected to 4G, 5G, 3G, and even lower speeds, right? You want to test security, so check for data leaks and proper handling of permissions. You want to verify accessibility, so ensure the app is usable by people with different abilities. And you want to verify localization, so validate proper functioning with different languages and regions if applicable. So with so many things to test, teams should prioritize. And when you're testing mobile, you would normally have a test plan in place. How do you approach testing certain applications? You want to see team figuring out what devices should be used first, like what are the most popular devices for this product, what operating systems on those devices, and what app version you want on those devices. You also want to use critical path and kind of mimic the most often used user behavior with the application, what user normally does as part of your like regression flow. And you want to verify new features first. So whatever is getting added, you want to focus on that as well. So yeah, there is a bit of a difference when you approach mobile testing, but most of it is just figuring out how to work with a mobile device, how to install the new build, new application, how to get the logs. And once you're done through that process, it's very similar to normal testing that you would do with web, let's say, right, or API. The approach, the default, the basics, the foundation of testing is very similar. It just needs a little bit of a hands-on experience. So, and a lot of things that are priority, they will be unique per product, per team. Like in mobile testing, we need to do this or that, and that will completely depend on what actually is being tested. Okay, so hopefully that helps. In the next video, we'll go and see the Android Studio, and maybe we'll do a little bit of a Charles proxy to capture the traffic and analyze traffic. All right, so this was Alex USA Days. Thanks for watching, and bye. Hey everyone, this is Alex USA Days. So we're continuing with mobile testing. We're in section or module 11 right now, so mobile testing. We already talked about the concept of mobile testing and how it is different. Now I want you to give you an example of working in Android Studio and what you kind of need to know before actually getting into testing mobile application. So in this video, we will explore Android Studio to be able to test and install Android apps. We will download and install Android Studio. Here's a download link. We'll create Android app for testing. We will create new virtual device to test our app in emulator. Here's a link to enable virtualization if you can add virtual device. This will be discussed in the video as well. We will see how to enable developers mode and allow USB connection to the phone. I will also show how you can install an app on connected Android phone on a physical device connected to your computer. Show how to add existing APK to run an emulator to launch it and test, and also gather logs and in general bug reporting with Android Studio. All right, so let's get into it. First thing, go ahead and in Google type download Android Studio. The first link you're going to see, it's Android webpage, so I'm going to go there. And here is download for the latest Android Studio. It's called Hedgehog. Now, at the time of you watching this video, the Android Studio name might be different, version might be different, but that's fine. Just go ahead and download that. It's going to ask you to agree to some of the conditions here. Sure, I'm agreeing. Here I have it downloaded. Just double click it to start installation process. It's going to take a little bit of time. It's also asking if you want to allow the app to make changes. Sure, I allow it. Okay, so here is welcome to Android Studio setup. So this installation screen, hit next. You want both Android Studio and Android Virtual Device. Hit next. Default location, yes. Start menu, sure. Install. Okay, so installation is complete. Let's hit next, and let's start Android Studio. Okay, so here is welcome screen. You might have a project already opened. That's okay. All you really need to do is to go into a new project. So I'm gonna hit new project from this menu, but I will show you in the next menu where you can open new project as well. So new project, let's select empty views, activity, select next. Let's give this application name. So I'm gonna call it Alex USA Days. So Alex USA Days. Package name is auto updated. That is fine. I don't need to change save location. Language, Kotlin or Java. Java doesn't matter for us, so I'll leave Kotlin. SDK version doesn't matter really. Build configuration recommended. This is all fine. So let's click finish. All right, so for the project to get started, it will take some time for everything to get set it up. It also says there's Microsoft Defender configuration, so automatically for whatever the configuration needed for that, I'm going to click it. Along the way, it asks some permissions from the user control. I'm just saying yes to everything. And let's give it time to set everything up. You can see the progress at the bottom here. If you open up a project that is already on your system, but you want to create a new one, in order to create a new project, you just go to File, New Project, and then you follow the same process on getting started back into this screen. So if I'll go File, New Project, you can see it opens up New Project, and I can go and create one more, right? Not going to do that because we already created this project from the welcome screen, so we don't need a new one. All right, still indexing stuff. You can see the progress at the bottom bar. Okay. Looks like we're good. So first thing I want to do, let's really quickly create some sort of a visual file that we're going to use. Assume it's an app that we're going to use for testing, right? So in order to do that, first thing I want to add a custom image that's going to be very visible on the Android app. Here in the Android, there is main activity, Kotlin file or Java file. Here you can see it in the tab, right? So this is your code file essentially. And then there's activity main XML. So this is your visual file. This is where you add images, buttons. You can work in this view to work with Android, how it's going to look, right? So one of the things that I want to do now, I'm going to add an image that I have that will show very, very, very brightly that this is my app, right? You can add any image if you want. If you have on a machine, you can just add it to the application here as well. So it is visible. So first thing I want to go into at the top, view, and then in view tools window and resource manager. Okay, so resource manager is open, and then in this view, click on add resource to the module, and here there's import drawables. So I'm going to click on that. On my desktop, I actually have a file saved. Desktop. All right, Banana Droid. So okay, I'm going to import that. Next, just import it. Okay, so after that is done, what I can do, I can go into image view and drag. You can see here in palette, there's common, and one of them is image view. I'm going to drag the image view onto the screen. And I'm going to use Banana Droid, the one that we just imported. Okay, so it's right here. One thing is, let me make it a little smaller. So you want to make sure you have it attached to each side. So like this. So you grab a corner and you pull it to the side so it stretches. Doesn't matter the size of the image or the device screen, it will stretch to be centered in the middle. So I'm kind of pulling each corner, clicking on the dot and pulling to the corner, setting up the constraints here, right? And let me resize it, make it a little bit bigger. Okay, so technically that's it. That's the whole app, right? After we did this, what we can do, we can add a virtual device. We can add a new virtual device and display this app in the virtual device. And then we will actually connect real device and display it on the real device. So let's go to the device manager. So tools, device manager, and click a little plus, create virtual device. You can see this window, device manager window opened. Let's click on plus, create new virtual device. And there's a whole list of virtual devices you can select. So let's do just medium phone. That's fine. Medium phone. Second one here. Next. Which system we want to use. I'm going to go with default Q. This is fine. Portrait orientation. Yes, in portrait. Finish. So right now it's going to add this virtual device, and then we will be able to use it and launch the emulator to see at our application within that emulator. So one more thing that I wanted to add, after you install and try to enable virtual device, if it says virtual device is not supported, you have to enable it in BIOS settings. So you can Google VTX enabling in the BIOS, and I'm going to provide an article here. But essentially, you have to enable virtualization on your system in order to be able to run virtualization or your Android device. It's not that hard. You just have to go into the settings of BIOS, find the virtualization, enable it, and save the configuration and restart your machine. There are steps here in the article, so I'll have the article here, a link to it under the video. So if you're facing a trouble not being able to add virtual device, enable virtualization first. Okay, I can say run app. This little arrow. So there's app, this is our app, then there's virtual device selected, and I can say run app. So right now it's going to launch an emulator with our application. Okay, so it's loaded in this little window as a running devices. You can see at the bottom. So I don't really want to view it like that. I don't want to view it in a small window. To change that, let's go into Tools, SDK Manager. Over here we have Tools and Emulator. So click on the emulator. So it says launch in the running device tool window. So I want to remove this and I want to see an actual like emulator device showing up. So I'm going to click on that and I remove the settings, right? Let's apply it, hit OK. And now we're going to launch the virtual device one more time. So click on the play button. Here it is. So it launched an actual phone. So I can turn it on. And here's our application. This is this picture. So I can hit on the little square. I just close the app. If I'll drag the screen up, you can see it comes up. Here's the application. Alex USA Days right here, the first one, and I click on it, and here's our image. So this app is already on the emulator. Within the emulator settings, you can change a lot of things. So let me just minimize the Android Studio. So here we have settings for location. We can update the display. We can choose what kind of network we're on. We can set different level of battery, if it's charging, not charging, and so on. Camera settings, like phone settings, microphone, fingerprint, and all of other things. There's also bug report capability, so you can take a screenshot and send it out. You can do snapshots. You can do recording of what you're doing on the Android emulator and record videos. There are also settings for Proxy, and we'll talk about Proxy. So this will be to capture traffic. We'll have it in the following video. Okay, so help, different settings here, okay, on the emulator. One thing that I wanted to show you is on the emulator, if we go to regular settings, like within the window, you can see there is about emulated device. I can open it up, and here's build number. So if I click it 7 times, 3 steps away to being developer, 2 steps away from being developer. Okay, 7 times I clicked it. Now I'm in the developer mode. You will do that on your physical phone. You'll go into settings, Android emulator device. So that will be like your about it phone. You'll go to build, click it multiple times. And after you did this, you'll be able to add USB connection, debug through the USB port. So here's in the system, there's advanced. There's developer options available now, so you click on that. And then within developer's option, you want to have, there's a bunch here. So first of all, it's on. You want to have USB debugging on, right here. So this will be on your real device, on your real phone. I'm just showing you on the emulator so I don't have to show you on my phone. Okay, so that is about configuring your phone and getting the emulator going. Now, let's get back to the Android Studio. And I'm going to turn this off. So it's off right now. I'm here in the Android Studio. And let me build and create APK file. So with this application, with this little image, right? So I go to build, build bundles, build APKs. So I'm going to hit build APK, and it's going to create an APK that I can use now and install on the phones and emulators, right? Start it. So start building. Okay. So here is the build. It says build APK. It says locate. So let's locate the APK. Hit locate. It's under debug and app debug APK. So this is the APK, the application file you can install on the phone. We created on the app. Let's copy, and I'm going to place it right here on the desktop. So the APK file is right here on the desktop. Now I'm going to launch emulator again. So click on the play button next to app, medium phone. I'm still in the app, so click on the square, signing it up, and now the app is closed. Here is my app on the virtual phone, and I can, let me close it. Here's my app on the virtual phone. I can click on it and hold. There's app info. So click on app info, and I can uninstall it, remove it. So I'm uninstalling the app from virtual device. So there's no longer my app running on this emulator phone. So let's say you have an APK that the developer gave you and you need to test it. So you can just grab the APK, open a phone, a virtual device in your Android Studio, and just drag and drop it right here. It says APK will be installed. Okay, so if you have an error when you drag and drop your app and it doesn't install, doesn't get added to the phone like that, what you need to do, you need to install your ADB. Something happened during the installation process, so it didn't get installed. If you had an error like I just did. So go to your C, so disk C users, then choose your username, then go to app data, then to local, then to Android, then to SDK, and then to platform tools. So this is your path. Over here, ADB.exe, right click it and run as administrator. So once you do that, it should install ADB on your machine, and then you'll be able to just drag and drop your APK on the phone. So let me show you again. I click on it, hold, it says app info, click on it, and uninstall. Now it's gone. And now I'm with emulator where I want to test an app that the developer gave me. So I can just grab this APK file and drag it here. It's going to install, and you can see now it's being added again, and I can open it up. Okay, so I'm done with the emulator, so I'm going to turn it off. Now let's add the application to the physical device. So here's Android. We go to the settings, right? We click on settings. We make sure that developer options is on. So developer options at the bottom is on. Make sure it stays awake and USB debugging is enabled, right? So I connect this phone to the computer using USB. And now here I can get rid of the emulator. We go to troubleshoot device connections. All right, and it says, okay, connect your device over USB. So we can hit next. Talks about device staying awake. Okay. On the phone, it gives me a code like, do you trust this computer? There's a message saying, do you trust this computer? So I click OK, allow it, click next, and one device was detected. Click finish. Now here I can choose, always trust, okay. Here I can choose the Samsung. So it found it, and you can see not only I have a virtual device now, I have a Samsung. So Samsung selected, and I'm gonna run it, run app. So now it's gonna run this application that we just created in Android Studio. It's gonna run it on this local Android device, and I can, if I had like a real app, I could tap around, do whatever's needed to debug, go through the test cases. If I find something, I can file bug reports and so on. So let's just wait for it to load on the phone. All right, it's still launching on the device. Now it's installed. And here we are. Now it's on the device. It was installed on the device and launched the device. And you can see it's right here on the bottom. So if I click on it, I can reopen it. All right. Great. So this is about like everything you need to know to get started with Android Studio. For Xcode, the process is going to be very similar. You have to connect device. You can have to load a file, launch an application, test and debug. So let's talk about getting logs. When you're debugging the app and going through test cases, you might want to get logs, right? So one thing, you can go and do debugging session here and do bug report. You can save the report, write reproduction steps. It will grab report data. You can record videos. Or maybe you want to actively monitor logs and then copy those logs and send those logs out. So at the bottom there is logcat. If you click on that, you'll have logs for your application, and it has package in mind. Now let me drag and drop APK here. It's going to install the APK. I can delete this, for example, right? And then you can see the whole thing that's happening on the phone right now is being shown. Here's the application installed. I can launch it, and it's up. Now, obviously, there's tons and tons of logs, right? You can filter by specific logs. Like you can say, I want to see errors, like level error, right? And now it's only going to give you errors. Or is there any other specific logs you want? You can apply filters, and then you can capture that. You can actually export logs to a file, so you can save it and then send it to developer, and you can highlight, okay, what exactly was wrong. Or even if there's a specific error visible here, you can just do a screenshot and send it together with the text saying, hey, this is broken, right? So this is on capturing logs. Now, one more thing, if you have a newer Android device, I had to show in my hand my Android device, but if you have a newer Android device, it will support mirroring the device it's showing here. So there is actually a settings in Tools, SDK Manager. Let's go to Tools here, and we have device mirroring. So you can enable that. You can actually mirror physical device when the device is connected if you want to, right? There will be one more video. Next one will be on getting logs using Proxy. So this is HTTP logs, like response is 200, OK response 201, 404, and so on. But this is going to be done with a different tool. This is not going to be done through Android Studio. We will explore Charles Proxy as a tool to do that, and how to actually test with a third-party device so we can capture traffic. All right, so I know it was a lot, but in order, take it slow. In order to learn this kind of and be able to repeat after different steps, just pause the video, take your time. You have to kind of explore application a little bit. You have to understand where's what connected. You have to spend some time with it. Give it an hour or so, explore it a little bit, and you know, uh, as soon as you learn where's what, learn where's what, it's going to get a lot easier to navigate it, to be able to open an emulator, to be able to add an application and test it. All right. So hopefully this was helpful. This is Alex USA Days. Thanks for watching, and bye bye.
Hey everyone, this is Alex USA Days. So today we're continuing with mobile testing. We are finishing module 11. After that we will go into first work experience, how to get it, what to do when you start working as a QA engineer for the first time. After that we'll talk about team composition with you as a QA engineer in it, and we will have interview preparation. After that, that's it, we're done. Okay, so today's lesson we talk about a tool called Charles Proxy. Now in this video we will get basics of Charles Proxy and how to use it in testing. Charles Proxy is a tool for analyzing and troubleshooting communication between clients and servers. We will start with Chrome DevTools Refresher. Then we will install and configure Charles Proxy. We will install a certificate. We will enable SL Proxy. We will get familiar with the UI layout. And we will practice how to throttle traffic. We will look and understand on JSON payload verification, and we'll add breakpoints to intercept traffic and update request response. Now, essentially, Charles Proxy is a proxy server and sniffer that captures and allows analysis or editing of all network packets passing through your system. So you can see on this diagram, you access through the client, that might be your phone or a browser in your computer. You're trying to access server. Let's say you launch an app and the app is trying to access server. Now instead of going directly to the server, it will be going through Charles Proxy. Inside the Charles Proxy, you can now analyze the traffic, you can edit it. The server will get edited traffic if you changed anything. Then the server going to send response back, and then again, instead of getting directly into your client, so into your phone or your browser, it will go through the proxy where you can actually update it. Okay? Some things that you might also see in here today that you might not be familiar is SSL. So SSL is a secure socket layer. It's a protocol for establishing secure links between network computers. So you'll have to enable SSL in order to be able to look inside the decoded traffic. So it is decoded if it goes through SSL. Another one is XML HTTP request or XHR. So those are objects that used to interact with the servers. The JSON will be inside an API request response, most likely within the XHR request. And then there's JSON itself, so it's JavaScript object notation. It's actually a lightweight data interchange format. So whenever you send information to the server, it's very likely that it might be sent within JSON format, and then the server can respond with that information also in JSON format. Okay, so let's get into it. Let's learn Charles Proxy. So we will start with developermozilla.org webpage that talks about JSON. I'll have a link for this in description, but JavaScript object notation JSON is a standard text-based format for represented structured data based on JavaScript object syntax. It is commonly used for transmitting data in the web applications. So if you go and right-click on this page and you go to Inspect, you will see DevTools. Now here is a network tab. Let's click on that. Now instead of all, let's fetch only XHR. So click on that and then let's reload the page. So once the page reloads, it sends another request to the server, gets all the information back from the server, and here we have the communication happening between the client and the server. We can see it in the network tab. For example, one of the requests here is who am I, right? If we look at it, goes to this endpoint. The request method is get, and we get back status 200, meaning everything okay. But what this request does, it requests information on the location of whoever is accessing the web page, right? And the response comes back and it says in this JSON payload, in this format, you can see it says country United States and then country ISO US, right? So this information is coming back from the server with information about the country. Now, you can test, look into the communication between server and client. If you have Chrome, you can go into DevTools, open Network tab, and do that for web testing. Now, from mobile testing, you won't be able to do that. There's no way you can do that in mobile testing, right? Especially if you test an application. So how do you capture communication like that, right? What can you use? So instead of DevTools, you will use Charles Proxy, right? And that's what we're going to go and install right now. So let's go to charlesproxy.com. Here's the web page, and in the Charles Proxy web page, go ahead and click Download tab. Now, in this tab, there is multiple versions of Charles for different systems, so choose yours. We're going to install it on Windows. We're going to configure it for Windows. If you're on Mac, your installation process is going to be a little bit different, and configuration process is going to be a little bit different, but I'll have a link after this video that explains everything how to do it on Mac. Okay, so let's click on it and download Charles. Okay, and now let's install it. A pop-up comes, something like that. So click Next, agree to everything. Now Charles will, this is a trial version for 30 days. It will work for half an hour and then reset itself. You'll have to restart it. If you want to get paid version, you can pay it for it and get it, but most likely if you work for a company and they're going to use tools, the tools will be purchased, right? Okay, so trial version for us is enough. You don't actually have to buy anything because we're just getting familiar with the tool. So hit next here. During installation process, there might be a pop-up that's going to ask you, okay, do you want to trust this tool? Just press yes. We're finished here. Done. Good. Go to your search and just type Charles. You will see the app right here. Okay, let's run it. Start in Charles. Okay, and here we are in Charles. So nothing going on here. You can see it's already kind of having some traffic showing here. So Charles will have a couple things, right? It will have a structure, so it's going to be a whole structure of the page with everything in it, and it will have a sequence. So sequence is how requests are getting based on the timeline. Most likely you're going to work in the sequence all the time, and in order to get specific requests, you can use filter and you can search for specific names or web pages to display only them, so you don't have all of it here. So before we can start using it though, we need to configure a couple things. First thing, we need to install root certificate. So in order to do that, go to help, SSL proxying, and install Charles root certificate. So mine is already installed, so actually let me delete this one. So again, help, SSL proxying, reset Charles root certificate. You don't have to do it. I'm just showing you that I'm resetting it so we can install it together. Should be reset now. Now if you're going to go again, help SSL proxying, install Charles root certificate, in the pop-up window you'll see the certificate and it has like this white X in a red circle, so that means the certificate is unrecognizable, so system doesn't really know what it is. In order to be able to use Charles Proxy, your system have to trust the certificate, so you need to install it. Hit install certificate, and over here you can choose current user, that's fine. Then click on Place all certificates in the following store, and then hit Browse, and select Trusted Root Certification Authorities. Hit OK. You will see it right here showing up, and then Next and Finish. There will be a security warning, just hit OK. Import was successful. Now, if we close this window and go ahead and bring the certificate up again, so go to Help, SSL Proxy, and Charles Root Certificate, install Charles Root Certificate, click on it. Now, once you install the certificate, you'll see there's no more X on it, and you can see that there is actual date of validity. So from 2024 to 2025, so it's issued for like a whole year. All right, so we have a certificate installed. That's great. You can see there's some stuff happening in the sequence, some communication. So to clear it out, you can hit this little broom, so clear the current session. And to stop capturing traffic for now, you can just say stop recording. Okay, so we're not recording anything yet. Now, the next thing after we installed root certificate, we need to enable SSL proxy. If there's no SSL proxy, you're not going to be able to go into the request. It's all going to be coded. You want it to be decoded. Okay, so go to Proxy tab at the top, go to SSL proxy settings, and over here, hit enable SSL proxy. There's an include. You can add. If you click add, you can add a specific host, so like a web page, specific port, but we're going to capture everything. And if you want to do, just to practice, just capture everything, you can put asterisk. So that means everything, and don't have to provide port. Port is going to be default. So hit OK. So now we will be capturing all of the traffic, and SSL will be used for all of the traffic that comes through. Okay, let's hit OK. And you can see now this little lock is locked. That means SSL is going. So if I hit on it, it's unlocked, no SSL. If I hit one more time, it is locked, so SSL is happening. Perfect. Now let's hit on start recording. So now anything that comes through my browser, the client, and goes to the server will actually go through the proxy first. So for example, if I'll go to this page, the internetherokuapp.com, and hit refresh. Actually, let me inspect it as well. Go to the network. Again, all of those links are going to be available. I'm refreshing the page. There's not a lot of XHR happening here, just some errors. But I can hit all and see everything that was sent and received, right? The whole thing. Okay, now if I'll go to Charles, I can see that all of this stuff is actually also here. There's also some other stuff happening. So how do I show only the Internet Heroku app? So I can just grab the title of the page, put in the filter, hit enter, and that's it. You see now, nothing else, only Heroku app is here showing, right? And then you can go and look inside your requests and response. There's content, there are headers right here for the request, for the response. If we go, let's say, back to developer.mozilla.org, so let's refresh that too. And let's update the filter to the developer.mozilla.org. And we can see, for example, here's our who am I, right? The same one that we were looking at in browser. So who am I? We can click on overview. So this is request overview. We can click on content. Here are the headers. And if I'll go into JSON text right here, I can actually see the same JSON response from that request. So it's coming from the United States. You can see it right here. Okay, so our Charles proxy is ready and going. So what can we do next? One of the things how you can use it to slow down traffic. So some of the web pages or apps you might want to test on a slow internet to see how long it takes them to load. If it doesn't load, what kind of message it's going to show. And you can specify what you want to throttle, like not everything, just specific web pages, for example, or specific apps. So for example, let's do throttling. So we go to Proxy again, and in Proxy there is start throttling, right? So let's hit on that, and you can see there's a little turtle now. Now we probably want to see what is the speed and configure everything. So you can do that by again going to Proxy, throttle settings. Let's open it up, and over here you can select. First of all, you need to enable it, and then you can select a specific page. So I'm going to remove this page, and let's say I'm going to throttle developer.mozilla.org, like this particular link. So let me grab that location. I'm going to add location. It's asking for protocol, so HTTPS, asking for host. So let's do developer.mozilla.org. Port you can leave as a default. Let's put wildcard from each side. Okay, so developer.mozilla.org, anything that is developer.mozilla.org. And you can select the speed. So for example, I can say 56 kilobit per second modem, like really slow. And let's put one download and one upload. Hit OK. Now you can see the turtle is running. So that ZZ green turtle, that means the throttle is happening. So if I'll go and refresh the page now, you can see the request is pending and it's loading. It's gonna be really slow because we brought down the speed down to 1 kilobit, right? It's barely loading. One more time. Pending. I think if I like clear everything out, if I'll clear all the storage, all the cookies, it's not might even load. It's just going to be so slow getting data that you're going to get like 404 back. Let's do *Amazon.com asterisk, or actually let's do all Amazon. Amazon asterisk, okay. So 5 kilobits download, 5 upload, okay. You can see the throttling is on. So go into Amazon webpage and refresh it, reload it. All right, so here we go. It's barely anything happens in the console. Usually you'll have like hundreds of those if you select all files on Amazon, scripts, documents, images. The console going to be full here. Now it's barely moving. And most likely it's going to hang, right? So let's say if you're dealing with testing application on your phone and you throttle, okay, you can see it went down, can't be reached. So if you throttle the app on your phone, you can see what actually happens is if your internet's too slow and your app requires internet, what kind of error will it show to the user? Is it proper error? Does the user know what to do if the internet speed is too slow, and so on. Okay, so this is with throttling. So the next thing we're gonna look into, I'm gonna turn off throttle settings, just disable it. Okay. The next thing we're gonna look into adding breakpoints and analyzing JSON, right? So let's do MDN. So working with JSON, so I'm going to developer.mozilla.org. Okay, let me grab this part of the link, put it as a filter, clear everything out. We're recording. Okay, so let me refresh this. And let's get into who am I, right? So if you're dealing with a mobile app, again, you will see similar request response, right, happening between your device and server. And you can go into the content of that response. You can go into JSON files and see the payloads, see if the data is coming back as correct, if locations are correct, whatever is set in there. And also, you can right-click and add breakpoints. So I can say, okay, there is actually check mark for a breakpoint. Add it here, and there's some breakpoint settings. So there are some locations, so I'm going to remove all of them from here. I just want one for now. So add breakpoint for this. Okay, it's check mark. You can see now the breakpoints is set. It's enabled. You can see this right here. Now if I'll go and refresh the page, what will happen, and immediately I get a pop-up. So you see session, not the structure, and not the whole pages, right? But in the session, in the sequence, it stopped right here with the breakpoint, and it says, okay, so we're sending this request to the who am I. Do you want to add anything or change? No, let's not do that. Let's just execute it. Immediately after the request, the server sends a response. I think this is still a request, so there was a double request send. Okay, let's execute again. Okay, so we have a response now. You can see there's a response tab. Now in the response, we can go to JSON and see, okay, we're getting back United States. So let's say update this to, let's say, Japan, right? And I'm not sure what the country is. So for Japan, probably JP, and execute it. Okay, now we can see, if we go to the latest who am I, that Japan was received in the response. Same thing here on the actual web page. If we go to the capture traffic here, let's do fetch XHR. So the last who am I think this is the one. And we'll look in the response. So browser actually thinks, okay, it is Japan, right? So that might be not so obvious, right? So what happened here, because, okay, we have to open a network tab. We have to go within the response and find the value. Okay, might not be that obvious. But let's say, for example, if we're on the web page like the Internet Heroku app, and let's add this filter to Charles. So I'm gonna now stop the breakpoints, go to Proxy, breakpoint settings. So let me actually delete this. Okay. Clear out session, close the breakpoints. Okay. I'm gonna add the filter for the Internet Heroku app. Let me refresh the page. Comes up right here. So all of this communication is captured. So let's say I will add a breakpoint where we get the actual HTML with all the information. Let me see. Yeah, it's right here. I think on the login. Yeah. So the password, username, text. So I'm going to add a breakpoint on the login pass. Right. So right click it. Breakpoints. It's check marked. I'm going to refresh the page. Okay, it's refreshed, and here's our breakpoint coming up. So we're going to execute the request as is, and then in the response, go to edit response, and let's go to HTML. Now you can see the default text is login page here, but I can go to the response and let's find the text. So here it is. Instead of login page, I'm going to say, hi, it is Charles. And for all of this long text, this is where you get to the web page, blah, blah, blah. I'm going to say, sub to Alex USA days. Okay, let's execute it. And let's take a look at our page. So you can see all the values that we're providing in Charles Proxy are now here, right? And that's what user going to get back. That's what client is getting back. Okay, so that's it. That's all the information with Charles Proxy. Now, when using it with a mobile device, on a mobile device, you will have to go and enable Proxy and provide the Proxy IP address that Charles is using. So if you grab it here, it's visible. Or let's say you can go help SL proxying, install Charles root certificate on a mobile device or remote browser. You will have it pop up like this, and it will provide your proxy IP address that you want to provide on a device. So go to device settings, choose proxy, provide this IP address, and then go to this web page to install the certificate. I'll add some also additional resources on how to enable it on the mobile devices, but essentially the same way how we capturing traffic and editing it right now in the web browser, you can do it on the mobile devices, both Android and iOS. Okay, so this was Alex USA Days. Thanks for watching and bye-bye. Hey everyone, this is Alex USA Days. So let's talk about your first work experience as a QA engineer. We're at module 12. This is going to be a shorter module, but we also getting closer to completion of the whole course. So what you want to do when you start work in the new position, right? First, you want to learn the product. So begin by immersing yourself in understanding the product. Grasp its intended function because it's crucial to formulate effective test strategies based on that understanding. You also want to master the QA tools. So you want to learn tools and methodologies commonly used in your QA team. Avoid reinventing the wheel. Instead, observe and adapt established practices for bug reporting and data management used by your peers. Once you're comfortable at the new role, then you can start proposing enhancement. Number 3 is communication. QA is also a communication bridge between development and product. QA is at the heart of making things better, so always be clear and helpful when you communicate with your team. Number 4 is expand your testing horizons. You should look beyond the obvious test cases. You want to embrace creative thinking to explore edge cases, boundary condition, and negative scenarios that others might overlook. And number 5, prioritize with insight. So understand user expectations and business objectives to prioritize end-to-end test cases that align with high-impact areas of the product. There will be the crucial areas you want to address first. Now, this is when you start at a new job. What about getting QA experience? Nowadays, it's a little bit hard to find QA job without an experience. So everyone's asking how many years of experience you have or any experience. So obviously, having a certificate of a completion of some sort of a bootcamp program, that's going to be helpful. Having a hands-on internship within the bootcamp program is also helpful. But if not, if you don't have that, you're fine. You can actually start as a QA engineer doing some freelance testing, some projects on the side. So I put a list of web pages you can go, register an account, and start doing testing on those web pages, either as a beta tester, crowd tester, working on some projects. There are several websites where QA can find testing jobs or projects. Starting out, it might be beneficial to create profiles on multiple platforms to increase your chances of finding suitable projects. So don't just register on one. Start with UTest and move along the others. Open profiles there as well. Your job right now is to get as much hands-on experience and understanding as possible, right? So it's also important to build a strong profile with relevant skills and experience and a portfolio of past projects if possible. So if there's no any disclosures that, any limitations on disclosure of the project you will be working, some of them you can even add to your portfolio and showcase like during the interview and show, hey, I've been doing this and this and this work. All right, so let's go through those pages really quick. The first one is UTest. So UTest is the largest community of testers in the world. I started as a UTest tester. Was my first QA experience. And in UTest, you go through the sign-up process, you go through the task to get into the testing platform. Why I really liked UTest, you will be working on all kinds of different projects based on the devices that you have. So you'll provide the list of the devices, and based on those devices, they'll start sending you tests and tasks. Now, what is also interesting about UTest, they have very comprehensive training on how to open bug, how to go through testing scenarios, because they want to have everything standardized for their platform when you work with the product. So you kind of go through the process of learning how to test within the UTest itself. And I think it's it's a very strong program. Even if you're not going to get a lot of jobs from UTest, just going through the sign up and going through their training is very, very good for your QA experience. The second one is testerwork.com. So you can sign up here for different testing projects similar to UTest. The next one, Test.io, become a tester. So you can join freelance community here, become a tester. And by the way, a lot of the testing jobs, right, you will get paid by number of test cases you execute, by the test scenarios you're done. You'll get paid by projects completed. You'll get paid by bugs found. So you're not just training, you're actually earning money with that as well. The next one is TestBirds. Understand how to test with this platform. They do usability checks, user acceptance testing. So you'll go through the list and checklist to understand, okay, if the product's doing what it's expected to do. The next one is betatesting.com, a beta tester. So you can join the community to become beta tester. So when the product releases early, they don't want to go and give it to the whole market, right? Because there might be issues with the servers. Too many users at the same time can cause problems. Real users interact with the product different, and everyone is unique in their way how they can interact with the product. So for that reason, there's beta testing, right? So you can prevent and find the most problems with real users, but the amount of users is limited. So this platform is very good for signing up as a beta tester and testing products early on before they become global on the market. Then we got Beta Family. So you can start testing, sign up and start testing, and also making money with Beta Family. Next one is usertesting.com. You can sign up with them, earn extra money online in your spare time, learn how to share your perspective to help brands build better products and experiences. So you're testing and providing feedback on the product. The next one is Testilo.com. So it's a global platform for freelance software testing, right? Flexible hours, 100% remote, global scale mobile apps. So they're there's a lot of similarity through the platforms, right? The whole idea is just getting into the platform gets orders from customers across the globe, and you actually test them. The next one is Playbook UX. You can actually test UI, or not testing in the fuller context, maybe a little bit more focused testing here. You can test UI, test digital products, and you can provide feedback, and based on that feedback you can get paid. And the last one, this one is kind of stands out because that's overall a freelance platform. This is not solely dedicated to testing, but the platform is called Upwork, and I specifically typed in quality assurance in the search terms for Upwork. And you can see their offers for testing. They're different budgets, different payouts. The contracts might be short, sometimes a couple months, sometimes smaller than that. But still, it's money that you can earn and you can practice your testing skills. So Appwork would be like a freelance platform that offers all different sorts of jobs, including quality assurance. And offers that you can see here, they might not be available anywhere else on like LinkedIn Jobs or anywhere, because those are solely for the purpose of freelance, mostly like smaller projects that you can get involved in. Okay, so hopefully this was helpful. This was Alex USA Days. Thanks for watching, and bye-bye. Hey everyone, this is Alex USA Days, and let's talk about team composition. So we're in module 13, and essentially when you start work in the field, there's different vast of ways how the thing might be organized, different types of agile, different mixes of different approaches. But most likely you're going to see two major things. Like you might get into a team which would be small and flexible, or you might get into a corporate structure, right? So let's talk about it so you have some understanding where you might end up and how do you fit in the process, right? In the dynamic field of software development, QA engineers often find themselves working within two predominant frameworks. Agile, characterized by its fast-paced and flexible small team structures, and more traditional corporate approach, which is process-oriented and typically features larger, more rigid teams. So in the Agile team, you will most likely going to have a product owner. Product owner will set the direction and priorities for product development. If you work in Scrum, you will have a Scrum Master, and this will be a person that facilitates the team Agile process and address impediments. You will have a QA engineer or two embedded within that Agile team, ensures the product meets quality standards through testing. You'll have software developers that code and implement the software features, so both back-end and front-end developers. You'll have DevOps engineers that will manage the infrastructure, CI/CD pipelines, support deployments, and have technical support that will provide customer support and feedback to the team for improvements. So you can kind of look at Agile structure sort of like this diagram here. At the very top, we have business, we have product, with them we can have Scrum, and with them we can have business analysts, right? So their main goal is to deliver business logic, work on requirements for the feature requests, work with customers, so kind of get the direction where we're going, okay? After that, you will have back-end and front-end developers, so engineers that will work on building that, right? So they have to build features, they'll have to do updates, if the bugs found, fix the issues. Then you will have a QA. It's all within one team that's working on a specific project, right? That QA engineer will be most likely hands-on, so working with the stories, participating in meetings, kind of getting features in a place where they're testable and everyone understands how they've been verified. You might also have like automation or software developers in test within the QA that will work more on creating automation scenarios, maintaining that, reporting, making sure that the reports are automatic if something fails when the new build is added, and so on. So focusing on verification, test scenarios, test documentation, automation. And then you'll have all that support around it for that project, whatever that might be. So you can have sales, you will have design, you might have marketing, whatever is needed, right? There's a lot of different projects possible on Agile framework, different products, whatever fits, whatever is needed for that product, okay? And then kind of alongside of it, you will have DevOps. DevOps can be global, not just within one project. Same DevOps can kind of be on multiple projects, so they can oversee the whole structure. You can see it here, and they go through like different environments, supporting it, including like production. With that, can be on multiple different parts of the product in different projects, or kind of overseeing everything. But on production side, you can have like apps team or customer support team or technical support. So essentially, they work directly with issues that customers report, whatever part of application that might be in your project or not in your project, right? And then those things will be related back to you, where you verify that they're real or not. Can they be reproduced in the test environment? And you will can oversee the fix. The developers do fix it. You'll verify that the fix is successful, nothing else gets broken, and so on. So this is in general the Agile team. So it's a small team. You are within the project. There could be multiple Agile teams, multiple different projects. But QA is integrated. So QA is working day to day with product owners, with business, with developers. There's a lot of communication happening. So you're kind of part of that team, right? Now, the second like major thing that can happen if you're going to work for kind of corporate setup, right? And it's going to be a little bit different. So in corporate team structure, which often follows like a traditional or waterfall approach, the setup is more hierarchical and departmentalized. Here's an example of what that might look, right? So you will have business at the top, so project manager that will oversee project timelines and deliverables. Then you'll have like business analysts that gather requirements to build system and analyze what are probably standards have to be followed and so on. Then we have a development department that will build a software based on specification, like a whole dev department talking with a development manager, development director, and so on. And after that, you'll have a whole QA department that it's not embedded with any other departments. It's its own thing that works on completed product that comes from the developers to you, where you go and test the software for bugs and compliances. There might be a lot of standards or procedural things that you have to do. Maybe you are in regulated field. Maybe you work for Department of Defense or aerospace, whatever. So there's a lot of things, and normally you'll have testing cycles that can last for a while. So the new updated version of a product is being released right from the development, goes to the QA, and you'll have maybe a month, a couple of weeks to kind of go through everything, make sure the compliance is still there and nothing got broken, plus verify the new stuff. So it's going to be a very long or a longer, normally longer testing cycles comparing with the Agile, because Agile, you test with the team, you're embedded with the team. It's kind of ongoing process. For QA department, the process is time framed and understood, and most likely it's well documented how it should be done, what kind of steps should be implemented, what kind of things going to be verified, how it's going, right? So within the QA department, you'll have a QA manager, QA managers, and then if you have like multiple departments or within the department like multiple QA teams that are managed, you might also have like QA director that oversees everything, right? Then you get your infrastructure team, DevOps, also its own separate team that manages servers, hardware, deployment processes. You might have a technical support, so that will provide post-launch support and troubleshooting. You'll have a security or cybersecurity team that will focus on cybersecurity and regulatory compliance that deals with security. And you might have something that works with users to train them, so like user training team, or sales or some other specialists that are also part of the whole kind of infrastructure that will train staff and customers on new systems, right? So in summary, QA and Agile is about teamwork, flexibility, and quick changes, fitting well with Agile, fast, and adaptable style, right? On the other hand, QA in corporate settings is organized and follows a set of orders and involves a lot of record keeping, so documentation is a very high priority, lining up with a traditional step-by-step way of managing projects. Now, if you ask me which one is better, my answer would be it depends. It depends what you like, because not only the way how the things are going to be done will be different, the products will be different. So for me, it boils down to if you like the product, if you feel that you're contributing to something important, right? That's the first thing. And the second thing, if you're making an impact. And the third one, if the culture is good. So if people are friendly, if you're friendly, if you feel well working with the team culture. Some people enjoy more kind of hectic, chaotic kind of a way of doing things. That would be Agile. Other people enjoy a more kind of rigorous, step-by-step, well-defined approach to testing things. One is not better than the other in terms, this is definitely a good approach and this is not. No, it's more about what fits better for that particular product, for that particular project. Some things have to be very well tested. Some things have to have long test cycles. So if imagine you work for aerospace industry and they're building planes. There are a lot of regulations to abide. There are a lot of things that have to be very well checked before the product can hit the shelf, right? And then if you work on an app that creates some, I don't know, entertainment for pets, whatever that might be, there's not a lot of, lives at stake. So yes, fixes can be fast or things can be updated quickly. So let's say you work for TikTok, right? Um, Things could kind of change on the fly, and you try to adapt to the market. So something trendy, something new comes out, TikTok tries to incorporate it, like new filters, new capabilities of the app, payment systems, whatever that might be. So again, what you like more, you kind of have to figure out for yourself. I did work in both types of environments, so what I say, just go out there and try it. Try which one you like most. Okay. Uh, Personally, I enjoyed working in startup, kind of agile, and in more organized corporate. For me, it's more about the product, making impact, and having great culture. So, being kind of respected at work and having good teammates around me. Okay. All right. So this is Alex USA Days. Thanks for watching, and bye bye. Hey everyone, this is Alex USA Days. So we are in the last module, interview preparation. A great job. We covered a lot, so there was a lot of things that we learned. Now it's time to get ready to go to actual interviews and get a QA position. Now I want to note that it is very important to have hands-on QA experience before attending job interviews. If possible, try to get involved in at least a couple of freelance projects that I mentioned earlier to strengthen your practical skills and resume. This experience will not only make you more attractive to potential employers, but also give you confidence in your abilities. Preparing for a QA interview involves understanding both the technical skills and the soft skills required for the role. Here are some steps you can take to prepare effectively. First, you should learn about the company, their mission, and product prior to interview. Second, have some examples of bugs that you filed, including most difficult bugs, readily available. Third, automation versus manual testing. Be ready to answer when to use each one and why. Number 4, work on your soft skills. People should enjoy working with you, so communication, teamwork, collaboration have to be very important to you. Number 5, be ready to talk about things mentioned in your resume. Number 6, when asked on why you're looking for a new position, talk about searching for new opportunities. Don't complain about previous job, position, your boss, etc. Note that interview experience is a crucial component of your interview preparation journey. It's common to attend many interviews before receiving a job offer. Use each interview as a learning opportunity. If you encounter questions that you're unsure of, make a note of them afterwards. This will help you to prepare for future interviews where similar queries may arise. So going through interviews is part of getting a job. You'll have to go through many interviews before you actually land an offer from a company. And while you do that, always take notes of questions that you were not sure of. Okay. Also, remember the average job hunt in a good QA market may span approximately from 2 to 4 months. So stay persistent and don't lose heart if the process seems lengthy. Continue to engage in multiple interviews. This perseverance is often what leads to finding the right job fit. To aid in your preparation, I will provide a resource with 50 interview questions and answers. Reviewing this will help you become acquainted with the types of questions that typically arise in QA interviews, enhancing your readiness for what lies ahead. Okay, so let's cover first 8 interviews questions that I'll provide. There will be 50, so you'll have the whole list attached with this video. Look it in the files available with this video. Let's grab the first 8. So the first one that is most commonly asked is, tell me about yourself. Normally, you want to say that I'm passionate about quality assurance, that I am eager to explore new opportunities in the field. I've worked as a QA engineer both part-time and full-time, and I'm dedicated to continuous learning and improvement. So it is a generic question to kind of get conversation going. You want to give a generic answers that kind of explain why you want to be in QA. So overall positive, picture of yourself being QA engineer. The second question that is quite often asked is, why are you looking for a new opportunity? So you can say that my current role lacks growth opportunities, and my QA contract is ending without an extension. I'm actively seeking a company where I can continue to enhance my skills and contribute to quality software development. Now, that question is also to kind of see how adequate you are. Why are you looking for a new job? Did something happen at the previous job? Maybe there was a conflict, or maybe there's something pushing you to get a new job. Again, this is a generic question that you want to give a generic answer, meaning that, okay, I'm looking for new opportunities, I'm interested in growing as a QA engineer, and my current job is lacking that. Or maybe your contract is ending and they're not extending it. So either of those is fine. Question number 3 might be, why our company? You want to say that I have a genuine interest in your products and have thoroughly researched your company's mission and culture on your webpage. It aligns with my values and I believe I can make meaningful contribution here. So you want to say that, I really like what you guys do and I want to do it with you, right? Number 4, this one is quite commonly asked. Where do you see yourself in 5 years? This is also a generic question that wants a generic response. In 5 years, I envision myself as a senior QA engineer with an expanded skill set. I am committed to continuous growth in the QA field and contributing to the success of the company. So you want to answer along the lines of what the job expects you to do. Don't tell them that in 5 years you see yourself as a manager if that's not a manager's position, or if you see yourself in 5 years as a developer or going in some completely different field. No, just keep on doing QA. In 5 years, become more senior, but still doing my thing as a QA engineer. Number 5, tell me about your debugging process. My debugging process involves identifying the issue, isolating the problem, and providing detailed information to the development team to reproduce the problem. So you want to be showing that you're aware how you debug something and you have skills that you can do it, and you want to be able to provide all the required steps needed to show what went wrong to the developers. Number 6, why choose QA and what do you love about it? So you can say, I transitioned into full-time QA work after enjoying it as a part-time freelancer. What I love about QA is the analytical and problem-solving aspects. It's like solving puzzles to ensure product quality. I also like making an impact and improving product quality. So why QA? Because I like QA. Number 7, tell me about positive negative testing. Positive testing checks if a system performs as expected under normal conditions, kind of a happy path, right? While negative testing examines how the system handles unexpected or invalid inputs or conditions. For example, a positive test case would be creating an account with expected password complexity, and negative test case would be creating an account with a password that does not match minimum character length. And number 8, tell me about end-to-end testing. End-to-end testing evaluates the entire system or application by focusing on user scenarios to ensure all integrated components work together seamlessly. For example, buying products on Amazon, that would include login, product search, adding it to the cart, successful checkout, and order confirmation. So this document will have 50 questions for you to go read and prepare yourself for the interview. Those are the most common things that are normally asked during the interview. Just spend some time with it. If you have to type it out or write it down, do that. That will definitely help you in preparation for the interview. Now, if during the interview you've been asked something you're not sure about, it's okay to say that I don't know, I have to take a look into it. But make sure you know that question and write it down so you can prepare for it next time you go into the interview. Now, the last thing is when you're going for a job position is getting your resume ready. One of the things that I found out is very helpful. First things first, get your LinkedIn going. So have an image of you, fill it all out. So go ahead, create a LinkedIn profile and fill it all out if you don't have one already. Make sure in your LinkedIn you have a concise about me with the skills and what you've been doing. Make sure that you list your experiences and what kind of work you've been doing in each one of those jobs, what were your responsibilities, and so on. Even if your start was a freelance as a U-test, what kind of tools you were using, what you've been testing, not specifically without mentioning the exact product names, but what kind of product that is you've been testing, right? Make sure to add your education, licenses if you have any, your skills, and so on. So once you filled out your LinkedIn, then you can go ahead and just create a resume. So you can build a resume based on that LinkedIn. And then will you do that? I mean, it's going to look pretty nice. So you can see mine is updated. I updated recently. It's going to look something like that, where you have all the information available on here on your resume, and just try to keep it to like 2 pages. Don't have it too long, and then you can save this as PDF, and that's going to be your resume that you can go with to the interviews, share with the recruiters. Yeah. Okay. So thanks everyone. I wish you all the best. Get the QA job you want, and talk to you later. Bye.